Hello friends, welcome back to our channel. So today we'll see how to download and install the RStudio software which is used to execute the code written in R programming. So we know that R programming is a language which is used for statistical and data analysis as well as for visualization. And RStudio is an IDE which is used to write and execute the R code. So here one thing we have to remember is R can be used without installing the RStudio, but we can't execute the R code in RStudio without installing the R. So we need to install both the softwares, R and RStudio. So if you are using the RStudio to write and execute the code, we need to install R also. So let us start the download and installation. So go to the official website. So rstudio.com. So go to this website and here you can find the link that is a download RStudio. So if you click on this link, you will be getting the two options. So the download options are two options. One is comes with the RStudio. Another one will be the RStudio server. So go to the download RStudio. So click on that one and see. Here you will be finding the two things. Here download and install R, and the second step download RStudio. So you need to install both the things, right? So first let me install this R. So click on download and install R. So here you will be finding a different platforms. So download R for Linux, R for Mac, and R for Windows. So click on this Windows and see, this is the first time we are installing the R. So click on here. So you'll be finding the link install R for the first time, the base, right? So click on this one. So automatically you'll get the exe file. So you can see download R 4.3.1 for Windows, right? Click on this one, 64-bit, right? My operating system is 64-bit, so I am downloading this R 4.3.1 and immediately the download has been started here. See, you can observe. So download is started, right? And before it gets completed, go back and download the RStudio, because first of all we need to download the RStudio, so then you have to install the RStudio. So first let us download the RStudio and click here, and again you can observe the second one, that means the RStudio is also started downloading, right? So it may take some time, but I'm just cancelling this downloads because already I have downloaded. In order to save the time, I'll go to the downloads option and here you will be finding the Studio and R. So this is R and RStudio. So this is R and I'm double clicking and I'm installing the R first. So R for Windows 4.3.1 setup. So click on yes and proceed. So select the language. I'm selecting the English and see, this is the agreements and click on next. And I'm not changing the path. So this is the path where we want to install the R. I'm not changing the path. This is a default path. And see user installations. So how much memory it will be occupied. So I'm just going with the next. See, and here it is a customized options. So if you want to customize the installation, go with the yes. Otherwise, simply you can select the no. That means all the defaults will be gets installed. So I'm selecting the option no. So next, and this is the folder where we want to install. So I'm also not changing this one. So just clicking next. So these are shortcuts. So create a desktop shortcut, quick launch shortcut, everything. So I'm not changing. So if I am here, it was selected for create a desktop shortcut. Automatically once it was get installed, the icon will be displayed in the screen itself on the desktop, right? So click on next and see the installation process has been started and it may take a few seconds. So meanwhile, if you are watching our video first time, so subscribe to our channel and explore the technology. So let us wait for a few seconds until it completes its execution. Yes, you can observe the click finish to exit setup, and also you observe here, so there is an icon R 4.3.1 here. So without the RStudio, now only we have installed the R, we have not installed the RStudio. So still we can execute the code in this console, right? So, and here we can execute the code, but without installing the R, we can't execute the RStudio, right? So now I will install the RStudio also. So you can change the environment, complete environment. So click on yes. So next, and again I'm not changing the path. So click on next. So I'm not changing the folder. You can observe it has been started installing. So this is also it will take some time, a few minutes to complete its installation. So you can see the console. So click finish to close the setup. So click on finish, and yes, already the RStudio is also been installed. So go to the all apps, and here go to the R. So you'll be finding the folder here. See RStudio. So click on this RStudio. The IDE will be opened here. See, here we will be having the four parts. So one is a script part where we have to write the code, and the second one is input and outputs. That means whatever the inputs we are giving, the values, environments, the data set, history, everything will be in the second part. And the third part is a console where we can get the outputs, and the fourth one is a visualization. That means a plots. If any graph is created, so that graph will be displayed here instead of in the console, right? See, it's a small program. We have written same a is equal to read line enter value and a print a. So go with the execution or run. So automatically the value has been taken with this one, right? So I'll clear everything here, and I'll just execute once again. See, here it was asking about the value. Sorry, it was asking about the value in the console. You can observe I'll give some 10 and enter, and next the value has been given, right? So here the 10 has been given to A, right? So we'll see the complete usage of this RStudio in our next session. So hope you understood how to install the RStudio and R. So without installing the R, we can't execute the code in RStudio. But without you installing the RStudio, we can execute the code in R environment. So this is a RStudio, and here once again I will show you the environment of R. So this is the environment of R. So here you can execute the programs, right? So the RStudio installation is not required if you want to execute the programs in this particular R console, right? So hope you understood how to execute, how to download and install the R and RStudio. So my suggestion is install both the things. First install the R, and the second install the RStudio, so that you can execute, you can write the code and execute the code in this particular IDE RStudio, right? So hope you enjoyed the session. If you are having any queries while installing or downloading the R and RStudio, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Hello friends, welcome back to our channel. So today we'll see the complete environment of RStudio, the work environment of RStudio. So we know that RStudio is used to write and implement the R programs. So in our previous session we have discussed about how to download and install the RStudio. So mainly we need to install the two things in order to run the complete R programs. So one is the RStudio and the R, right? So now I'll click on this RStudio. So the RStudio homepage will be displayed here, and you can see the 4 partitions here. So 1, 2, 3 and 4. So this partition is called the source partition. So where we have to write the instructions, that means we have to write the programs. So that's why we call it as a source partition. And bottom to the source we are having the console. So this is used for displaying the output. So that's why we can call it as an output console. So whatever the programs we are writing in the source partition, that will be executed and the complete output will be displayed in this partition. And coming to this one, so this is nothing but environment. So that means whatever the inputs we are taking into the program, those inputs will be displayed here. So you can see import dataset. So dataset is also some sort of input we can take to the program. So whatever the inputs we are taking, everything can be displayed here, right? And the last one, this is a files plots. That means if our instructions written in the source partition having the plots to visualize the data, that type of visualizations will be done here. That means the graphs will be displayed in this partition. So the text will be displayed in this console and the graphs will be displayed in this partition, right? So we can also customize these partitions. So you can go to the view, panes, and you can see the pane layout. Click on pane layout. You can see 4 partitions. First one is a source, console, environment, files, and you can customize here. So whatever the things you need here, you can simply tick the checkbox and just apply. So here you can see in this environment history connections tutorial, environment history connections tutorial. So build and this VCS are also available, right? So here you can see I'll take out the tutorial and apply. You can observe there is no tutorial here. So like that you can simply apply the customization, and also you can add a column. So you can see source column. If you apply, one more pane will be applicable here, right? So you can see five panes, so 5 partitions, and you can also remove the pane, right? Now we'll see the source pane. For example, let us take one variable. So in our previous sessions we have seen how can we assign a value to the variable. So one is by using a normal assignment operator. I'll take some a is equal to 10 and I'll print this a, and see this can be executed in 2 different ways. See here you can having the option. So this is a thing we have written here. So run. So this option will execute the only statement where the cursor has been blinked, right? So for example, if the cursor is here, so I'll write one more statement. B is equal to 20, and C I'll write here B is. Now see, if the cursor is in this 3rd line, if you click on this run, you can observe that line will only be get executed. B is equal to 10. Immediately the cursor will move on to the next line. You can observe here. And if you click on run, that will be executed. So even though our program is having some 4 lines of code, so if I select the cursor in the 3rd line and if I run it, only that particular line will be executed. So line by line execution can be done with this particular option, run. And if you want to repeat the same set of execution one more time, so you can go with the next option. See, you can observe the tooltip, rerun the previous code region. So if I click on this one, again the same will be get executed. See, the same thing will be executed. So whatever the thing we are executing previously, that will be executed. And here one more option here, see, source. So if you, here we can execute in two different ways. One is the source, one is source with echo. So coming to the source, everything will be get executed. See, you can observe complete program will be get executed. And if you click on this source with echo, so the program will be executed at the same time. See, the complete instructions will also be displayed here. So here you can see one brush symbol which can clear the console. So in order to avoid the confusions, I'll clear it. So just click on this one. So everything will be get cleared. I'll execute the source, just a source. So you'll get only 10 and 20 because we are printing only A and B here. And if the same program, if I execute source with echo, you can observe, say A is equal to 10, print A output, B is equal to 20, print B output. So every line by line execution, including the instruction, will be displayed on the console. And obviously you can observe here A and B values here. So these are the two inputs we have given in program. So those two values have been reflected in this environment pane, because A, here you can observe A and B are the inputs given, and see, you can observe A is a numeric and B is a numeric. A is having some 10 and B is having some 20. And again, if you go with A is equal to 100 and if you execute a run, you can see the value of A has been updated to 100 here. So whatever the inputs we are giving to the source program, that will be reflected in this environment. And why, if our program is having some plots, so just for an example I am giving, so plot 100 comma 200. So if I put the cursor in the line 6 and place run, you can observe the plot, the visualization will be displayed in this pane. Right? So the graphs will not be displayed in this console, the graphs will be displayed in this plots region. Right? And every console or every partition, you can find the brush icon. So if you click on this one, it will clear everything. See, it will clear, and here also it will clear. So if you are having any confusion, so you can simply clear the complete previous outputs or variables inputs, and again you can simply click, so execute, so that everything will be displayed here. And also history, so whatever the executions we have done, everything can be displayed in this particular history. Right? And also we have seen some rightward and leftward assignments, so that also we can give some A and C is equal to I'll remove everything, some A. So in the environment also I'll clear the complete history, and here also I'll clear the console, I'll clear. So now you can see 20, print A. So that means 20 is the value which can be stored into A. And now if I click on run, only one line will be get executed, because this run is for current line. So you can observe run the current line or a selection. And if you select the multiple lines and click on run, both will be get executed. So you can see, right? Similarly, if I go with the, we can also assign in this way some B, print B. And if I want to execute these two lines, select this one and click on run. So that will be get executed. And you can observe here, so the values are displayed in this particular environment pane. Right? So this is how we can use the RStudio IDE to write and implement the instructions in R language. Right? So after that we can save the file. So click on save. So the extension of R programming is .r, right? So you can give simply sample.r. So you can see by default save as type .r. So save. So on desktop you can find this sample.r file, right? So this is how the environment will be looked, and in our further sessions we'll go one by one and we'll learn different concepts of R language, and we'll try to execute more number of programs, and we'll visualize the data, right? So hope you understood, and if you are having any doubts, or if you are feeling any difficulty to work in this environment, feel free to post your doubts in the comment section. I'll definitely try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. So this is also a programming language similar to our Python. So this was created by two others, Ross Ayaka and Robert Gentleman. So the name for this programming language comes with the starting letters of both the others, so that's why we call it as an R programming. And where we are using this R programming, so mainly this R programming is used in statistical computings and the representation of data in terms of graphs. So mainly we'll use the R programming for these two things. So used in a statistical programming, statistical computing or calculations, and graphical representation of data. Graphical representation of data. So this will be used for both the things, right? So here also R programming is also having a wide variety of packages, so that we can make use of those packages and we can make use of functions in that packages, right? So what will be included? So R programming includes a normal operators for different computations. So the first one is the operators for calculations or computations, and the control structures, right, to say the flow of control, and functions to define the modularity, and data handling techniques. So there are a few techniques to handle the large amount of data, and graphical representation. And also we'll see a different tools for data analysis. In order to analyze the data, so there are different tools available in this R programming. So we are going to see those tools for different data analysis, right? So these all things will be included in our R programming, and now we'll see the features, some of the features of R programming. So the first one is a platform independent. So that means once you write the code, that can be run on any type of platforms, right? So that is a platform independent. So, and the next one is a interpreted language. This is also most important. Interpreted language. So interpreted language means there is no need of compilation, so directly the programs will be interpreted. So instruction by instructions will be get converted into the machine language. So example, Python is also an interpreted language. Similar to that, this R programming is also interpreted language. That means, so if a program is having some 5 lines, L1, L2, L3, L4 and L5, and if you are having some errors in line 3 and line 5, so once you get executed, if you execute this program, you will get only one error. It doesn't show both the errors, right? It will show only one error at line 3. It doesn't show both the errors because this is an interpreted language, though the transformation from high level language to the machine language will be done instruction by instruction. That means a line by line. So where the first line will be get executed and immediately the second line will be get executed, and whenever the interpreter try to execute this line 3, it will get an error and it will raise an error. So until this error has been solved, the L4 will not be get executed. That means the line 4 will not be get executed. So at a time we will get only one error. So that we call it as a interpreted, right? So here also we are going to write the program and we are going to execute the program, but the conversion will be done by using a line by line, right? So that is one more feature, and this is most suitable for implementing the machine learning operations. So suitable for implementing machine learning operations. Machine learning operations, right? And also this R programming is having a wide variety of packages. Large number of packages are available. Large number of packages are available. Example, so there are some packages like ggplot, plotly, right? So some string R. So these are all different packages. So the R programming, that means only the default packages will be available once you open the R console, and whenever it is required, so we need to install the packages explicitly, right? So only the default packages will be available with the R console, right? So there is an option of installing the packages, so we can install the packages whenever it is required. So this is all about the introduction to R programming. So mainly it is used for statistical computing and graphical representations, and mainly the data handling techniques and tools for data analysis, and this is mainly used for most suitable for implementing the machine learning operations, right? So similar to our previous languages, so this R programming is also having some predefined words which we call them as a keywords, and each and every predefined word will be having some specific functionality. So we have to use those reserved words for that particular functionality only, right? So keyword is a reserved word, defined for a specific functionality. Right? So in all the languages will be having these keywords, and definitely, so while moving on with the language concepts, we'll be understanding different keywords, but in the initial stage we have to know what are the different keywords, because we should not use those reserved words for another purpose, right? So in our next following sessions we are discussing about the variables. So there we have to define the variables,
and there is a rule that the variable name should not match with the keywords. So in order to do that, we have to know what are the keywords available in the programming language. So that's why we have to learn this before going with the variables. Now, example, I list out the keywords, and this is an abstract view. So everything in depth you will be understanding when we move on with the concept, right? So, for example, there is a keyword called function. There is a keyword called function. So this function is used to define the user-defined functions. So in our previous session, we have seen this R programming will be including control structures and functions. So there we are supposed to write a user-defined functions. So all the user-defined functions should be defined with a keyword called function. Similarly, if is nothing but a conditional statements. So if you want to check any condition, a boolean expression, we'll go with the if and which we call it as a true block. And similarly, else is also a conditional statement. Else is also a conditional statement, right? So this is called a false block and this is called a true block, and in-depth knowledge you will understand when we move on with the conditional statements. And then iterative statements for while and repeat. So all these three comes under the control structures, right? So control structures are for, while and repeat. All these three comes under the iterative statements. So repeatedly, if you want to execute some set of statements, we call them as an iterative statements, and these three comes here. So for these two, for and while, we need to write the condition, and the repetition will stop whenever the condition becomes a false. Whereas a repeat means here we are not able to write the condition directly, we are writing this repeat keyword which will repeat the following statements which are written under this repeat multiple times. So here we are not writing any condition. So when there will be a stop, so there are few more keywords like break, which will stop the iterative statements, which will stop the repetition of executing statements, right? So break and next. So next is used to skip the current iteration, want to repeat the next iteration, similar to continue in other programming languages. Next, and there are two more keywords called as a true and false. We call it as a boolean objects. So if you are writing any condition here, if and else, so the condition result will be a boolean result. That means either it will be a true or false. So here we are having a two more keywords called true, false. True, false. And also we are having a not a number. If it is not a number, so then it will return NaN. So don't worry if you are not able to understand this one, but remember these words so that we should not use these words for any other purpose, right? None, nan, and INF. INF stands for infinite. So we can check whether the number, whether the value of a variable is a finite or infinite. So there will get an infinite number. So here also we will be having a two different values, like a positive infinite and a negative infinite. That's a next process, right? So infinite. Next, NA, which stands for not available. So this is a constant with the length 1, right? So this is a new thing which we will not see in other programming languages. So NA, similarly NA underscore real, similarly NA underscore integer, similarly NA underscore complex, and similarly NA underscore character. So all these three are the not availables. I mean, all these 5 comes under the not available. That means the missing values. If the data is having some missing values, so we are supposed to work with a large amount of data which is available in tables, rows and columns. So if there is any missing data, that will be represented with this NA. And one more thing, we will represent using null, which called as a null object, which we call as a null object. right? So these are all the different keywords which are available in R programming. So these are the reserved words defined for a specific functionality. So if you want to define a user defined function, then you have to use this function. So we should not use this keyword for any other purpose. So this is only meant for defining the user defined function, right? So these are all the keywords. All these comes under the list of keywords, right? So you'll get an in-depth knowledge or understand about all these keywords while doing some programming, right? So what are the variables? So in every programming languages, the basic concept is about these variables. That means every programming language, we are going to use the term called variables. So now a variable is a memory location. It is a memory location to store the information or a data. To store data. So that means, so if you are trying to do some programs, we are supposed to give some inputs and also it will produce some output. So where the input will be stored and where the output will be stored. So it requires some memory location to store the data, which we call it as a variable. So usually a memory location is identified by address. So any memory location is identified by address. So which is a numerical, right? So obviously this is a numerical. So in our system, we are having a lot of memory, right? So it is impossible to remember the numerical address in order to retrieve the data whenever it is required. So that's why we are giving an alternate name for this particular memory location, which we call it as a variable, right? So this is nothing but a memory. So memory location, and we are giving an alternate name called as a variable. Right? So here we can store the data. So in order to store the input and output, so we are representing some variables. So those are the memory locations, right? Now, obviously the memory location, we are giving some alternate name. We are saying that we are giving some alternate names. So we have to give some names, right? We have to name the variable. So now, what are the rules to be followed? Rules to be followed while naming a variable. Naming a variable. So, in order to give the name for a variable, what are the rules we need to follow? And the first rule, it should not match with, very important rule, it should not match with keyword. So which we have already discussed in our previous session. So keywords are the reserved words working for a specific functionality. So the variable name which we are giving should not match with the keywords. So that's why we have to know what are the different keywords given by the interpreter. And the second one, it can be alphanumeric. So the variable name which we are giving can be alphanumeric. Alphanumeric means combination of alphabets and numbers. Alphabets and numbers. And it can have dot, I am writing here theoretically dot, and underscore. So this variable name can have a dot or underscore, that means a special symbols, and no other symbol should be allowed. So actually these 2 points are one, right? Those are combined. So it can have a dot and underscore, and no other symbol should be allowed. So only a dot or underscore. And then starts with alphabet, but not digit, means a numerical. So the variable name should not start with a digit. So the variable name can start with an alphabet, right? And the next, it can start with dot. It can also start with dot, but not followed by number. Number or a digit. Right? So it can also start with a dot. So that means it can start with the alphabet or a dot, and it should not start with a digit. And if it starts with a dot, the next immediate character should not be a digit. And also the last and important is a case sensitive. So case sensitive means, so there is a difference between lowercase characters and the uppercase characters. For example, so if you want to take some name as a variable, so even these three are different variables in R programming, because so it is a case sensitive. All are lowercase letters, and here it is a capitalized word. That means the first character is capital, and this is completely uppercase characters. So all the three are different, right? So it is a case sensitive. So these are the rules we have to follow while naming a variable, right? So it should not match with the keyword. We have discussed the keywords in our previous session. It can be alphanumeric, and it can have a dot or underscore, but no other symbol should be allowed other than dot and underscore. And starts with the alphabet but not digit, starts with the dot but not followed by a digit. Now we'll see a few valid and invalid variable names. Valid and invalid variable names. Let us see here. So those are valid and those are invalid. Example. So name is a variable, right? Number dot one. It is also, yes, it's also a variable. This is also valid. This is also valid. So because we are using some underscore symbol, right? And so this is also valid because we have seen that variable can be alphanumeric. So it can have both alphabets as well as numericals. And coming to the invalid. So this is an invalid because it starts with dot and it followed by a digit. So this is also invalid because the variable should not start with a digit. So this is also invalid because other than dot and underscore, no other special symbol is allowed, but here we are having a space. So similarly, first @ number or number dollar. So all these are invalid, and also we can see break is also invalid because a break is a keyword, right? Similarly, next is also invalid because it is also a keyword. So these are a few valid variable names, and these are some invalid variable names, and we have not to use these names as a variables, and we have to use only these type of variables. And moreover, the variable name should be somewhat descriptive. For example, if you are using some addition of two numbers, so you can simply take it as a first number and a second number. So it should give some description about that particular variable. That means importance or a functionality about that variable. So then it will be a self-documented program. So a good programmer will follow the same point. That means always the variables will be somewhat descriptive, and it will not be a maximum length. Okay, short and descriptive. Right. Now, the next point, assigning a value to a variable. How many ways a value can be assigned to a variable? Assigning values to variable. So three ways a value can be assigned to a variable. So the first option is using is equal to, and the second option using leftward operator, and the third one using rightward operator. So these three ways we can assign any value to a variable. For example, so let us take some example. So let us take some number is equal to 10. So automatically the number is a variable and 10 is a value which has been stored in this particular memory location. So by using is equal to, we are going to assign a value into that particular variable. Then what about this leftward operator? So usually the leftward operator stands with an arrow mark towards the left side. Okay, arrow denoting towards left side. So here we'll be having the variable name number 20. So that means this is a variable. So this is a variable or a memory location, and this is a value. So this is called a leftward operator. So by using the leftward operator, we are assigning this 20 to this variable, this value to this variable. Similarly, rightward operator. So rightward operator denoting towards the right side. Rightward operator denoting towards right side. So how to represent this leftward operator and rightward operator in the system? So simply use a minus symbol and less than symbol for leftward operator, and minus symbol and greater than symbol for rightward operator. Right? So here we'll give here it will be a variable, and this will be the excuse me. So here rightward operator, so value will be on the left side, and this will be assigned to the variable which is on right side. So here the variable will be on the right side, and here the variable will be on the left hand side. and here also this is a variable. So usually we'll use the conventional way, that is is equal to. So if you want to solve any problems, usually we use is equal to assign a value to some variable. But here we are having two more ways how we can assign the values to a variable, by using the leftward operator and the rightward operator. Right? So hope you understood. In today's session we have seen what is a variable and what are the rules we have to follow by naming a variable, and also we have seen some valid and invalid variable names, and then finally we have seen how a value can be assigned to a variable. So in our previous session we have discussed about the variables, so which holds some data. So here the complete data is categorized in different ways. So each category we call it as a data type, right? So now the data is categorized as a numeric, that means a numeric data, integer data, the complex data, character, and logical data. So numeric data means all the decimal values comes in under this numeric data, including the whole numbers, right? So for example, if it is a numeric data, so this is a decimal, and example, let us take some 10.5, so that is a decimal value, and even 10, it is also a whole number. Everything comes under the numeric, and this is a default. I mean, default means all the number data types, okay, all the numbered type is initially taken as a numeric data type, okay. See, not a default, we can say it as a number, okay. By default, if you assign any number to a variable, that will be defined as a numeric data type. So we know that assigning a value to a variable, some a is equal to some 10, or a leftward 10, right? That means a is stored under a name a, right? So here the data type of a is numeric. For example, a is equal to 3.5, okay, or a 3.5. So here also the data type is numeric. So by default, if you assign any number value to a variable, that will be considered as a numeric data type. See, the next one is an integer. So we know that integers are only the whole numbers. So the decimal points will not be accepted in these integers, right? So how can we differentiate this 10 as a numeric or integer? So all the integers will be having L as an end of a number, which indicates the integer. For example, so 10 L, this is an integer data type. So if you are assigning some a is equal to 10, that will be a numeric. That will be a numeric data type. If the same thing a is equal to 10L, that will be integer data type. So if you want to declare or store a variable as an integer specifically, we have to use this L indication. So L is to represent the number is integer, right? So that is the main difference among this numeric and integer. So that's why I have said that if you assign any value, by default the data type will be a numeric if it is a number, right? So if you want to store the integer, just use a L, right? Next, complex. So we know that complex numbers, right? Complex numbers are the numbers which are having the real part and the imaginary parts, right? So a real part and imaginary. So example, we can say it as some a is equal to 3 plus 2i. So here I is nothing but an imaginary part and 3 is nothing but our real part. So this type of numbers we call it as a complex data type. And the character, this is nothing but a strings. So group of characters or an individual character, everything comes under this character data type. So strings or characters. So which we can call it as a strings. So actually the characters, a group of characters, we call it as a string. And what is a character? So every key in the keyboard can be considered as a characters. So we can consider, say I'll write here, characters. So A to Z, capital A to capital Z, symbols 0 to 9, okay, everything. So whatever the key we are observing in the keyboard, everything comes under this character, and a group of characters we call it as a string. So we are saying that 0 to 9 is also a string. So how can we differentiate? So if I write as a 5, how can we know that the data type of this particular value, is it a string or is it a character or integer or a numeric? So if it is 5, then it will be numeric, and if it is 5L, it is integer. And if the 5 is enclosed in single quotations or double quotations, that will comes under character. Alright, so every character must be enclosed in a single quotation or a double quotations. So this is called a characters. For example, write down R programming. So this is nothing but a group of characters. So we have seen symbols are also comes under the character. So here we are having some symbol, and this must be enclosed in double quotations or a single quotations. Then only this will be considered as a character data type. Okay, character data type. So the last one is a logical. So logical data type is a special data type which will be having only two values, either true or false. So usually we call it as a Boolean data type, right? So it will result only true or false, right? So these are the basic data types which are available in R programming. And one more important point is R programming is a dynamically typed language. So dynamic typed language, dynamic typed. So what is this dynamic typed? So dynamic typed means we need not declare any variable explicitly. So directly we can assign a value to the variable, and based upon the type of value which we are assigning to a variable, the data type will be assigned to that particular variable. For example, if you consider here some a is equal to 5, now what is the data type of a? So here the data type of a is a numeric data type, because 5 is a numeric data type. For example, if b is equal to abc, now the data type of b is a character data type, because so we are giving some group of characters enclosed in single quotations. So you can be enclosed in single quotations or double quotations. Okay, that doesn't issue. And similarly, some c is equal to 3l. So obviously the number ends with L, which indicates the integer. So C will be the integer data type. Now, how can we know the data type of that particular variable? So in R programming, we are having a function called type of. So this type of function will give the data type of a particular variable which pass it to this particular function. If you want to know the data type of A, simply you can give type of A. So automatically it will return the data type of this particular variable. And one more important thing, so we will call all these as an objects. So the data type of object A will be a numeric data type, and the data type of object B will be a character data type, and similarly the data type of object C will be the integer data type. So like that, so we need not declare the variable with a specific data type explicitly. So we are not declaring any variable. So based upon the value assigned to that particular variable, the data type will be defined there. So such type of thing we call it as a dynamic typed language. Right? So hope you understood the basic data types available in R programming. So numeric, integer, complex, character and logical, and there is a slight difference among this numeric and integer. So see, the numeric comes with the decimal values as well as the whole numbers, and integer comes with the only whole numbers with L, specifying with L. L indicates the integer value. So in R programming, we are having a lot of data structures, built-in data structures. Among them, the first one is a vector. So this is a single dimension, and this is a homogeneous data. It's a collection of homogeneous data. That means it will be having the elements of same data type. And the syntax for vector is some variable name, or we can say it as a vector name, is equal to C of element 1, element 2 and so on. So here all the elements should be of same data type. So either it can be integer, or it can be a float, or it can be a string or character data types, right? So this is syntax for creating the vector data structure. And the second one is a list. So list data structure is also similar to the vector, and it is also a single dimension. But it is nothing but a collection of heterogeneous. That means it is a collection of elements, multiple elements of different data types. So we can store all the elements of different data types. So that's the main difference over list and vector. And here the syntax for creating a list is variable name, or we can call it as a list name, right? Variable name or list name is equal to use a list function followed by element 1, element 2 and so on. So here the elements can be of different data types. So here elements should be of same data type, right? That's why we are calling it as a homogeneous data, and here it can be of different data type. So no need to worry about all these things. I'll implement each and everything in the RStudio. So we'll execute a small program. Just we'll create a vector and we'll print the vector. We'll create a list and we'll print the list. Okay. For all the data structures, I'll show you the implementation. So don't worry about this. So just we'll see the syntax part. Now the two things completed. Then third data structure is a data frame. Third data structure is a data frame. So a data frame is a tabular data representing data in tabular format. Tabular format. So it forms a table, right? So it can be a collection of vectors. Collection of vectors. Collection of vectors. So for this we have to use a function called data.frame function. Data.frame function, right? So example, here I'll give an example. Let us take some vector 1. See, v1 is equal to c of some element 1, element 2 and so on, and vector 2 c of element 1, element 2 and so on. And now you can go with the data frame is equal to data.frame function and pass on these vectors v1 comma v2. So obviously if you execute the program, you will get the data in a tabular format, like giving a names as v1, v2 and indexes as 1, 2 and so on. So you will get element 1 and element 2 and so on, and here also we will get element 1, element 2 and so on, right? So in this format the output will be displayed. That means it will represent the complete data in a tabular format. So that is the data frame, data structure, data frame. Then the next one is an array. So array is a n-dimensional representation. We can represent the data in an n dimension, and here we'll give some order of data. Let it be some 2 by 2, 2 by 3, 3 by 2, right? Like that. So here it will accept, we have to use an array function to create an array. Array function to create an array, right? And the syntax for this array is some variable name or array name. Okay, variable name or array name. Give the array, give the vector here, the complete vector, and the second parameter will be the dimension. So the dimension should also be given as a vector in terms of vector, right? So for that I have to give the dim parameter, a parameter name called as a dim, which is called as a dimension. So dimension is equal to vector. So it consists of three things. One is rows, columns and number of arrays. Rows, columns and number of arrays. So if this dimension is C of 2, 2, that means whatever the vector here we are giving, so this is completely data. The vector is a data, right? So this data will be arranged in a 2 by 2 array of 2 arrays. So this is a rows, columns and this is a number of arrays, right? So 2 arrays with the order 2 by 2 will be created. And if you are giving here 3, that implies 3 arrays with the order 2 by 2 will be created, right? So the first one row, column and number of arrays with particular dimension, right? So these two are the parameters we need to give for array function in order to create an array. And the next one and the last one is a matrix. See, matrix. So matrix also will create in terms of rows and columns, right? So we'll represent a matrix order as a rows, number of rows into number of columns. So here also the same thing. So this is also rows and columns. The data will be represented in rows and columns, right? So here we need to give the n row and n column, n row and n column, right? N row means number of rows, n column means number of columns. And also the third parameter is an optional, it is a row wise, right? So by default it will be the column wise, right? So here I'll write a default, it is column wise. That means whatever the elements we are giving, that will be arranged in a column wise. So if you are using the third parameter as row wise, third parameter, so we can use a row wise. We can arrange the elements in a row wise. So here we will use a matrix function to create a matrix function, right? Now I'll write the syntax here. So variable name or matrix name, so we can write anything, is equal to use a matrix function, write on the vector. So vector is nothing but a data, so complete data should be written as a vector here. Vector n row, n column, and the third one by row is equal to true. By row is equal to true. So capital letters, right? Boolean data type, it's in capital letters, true. So this is a vector, this is a complete data we need to fill in a matrix, and this is a number of rows we require, and this is a number of columns, and this is a row wise ordering. So this is an optional thing, this is an optional parameter. So in the absence of this by row parameter, the data will be arranged in a column wise. Okay, for example, consider a vector some 10, 20, 30 and 40, and if you want to give number of rows, n row is equal to 2, n col is equal to 2, that means 2 rows and 2 columns. So first the arrangement will be done in a column wise, right? See, so 10, 20, 30 and 40. So the arrangement will be done in this way. And if you add one more parameter, this by row is equal to true, right? Now the elements will be arranged in a row wise. Row wise means 10, 20, 30 and 40. The elements will be arranged in this order. So that is the importance of the last parameter by row. So this is an optional parameter. So in the absence, data will be arranged in a column wise. In the presence, data will be arranged in a row wise, right? So this is all about our matrix. So we have seen a different data structures: a vector, list, data frame, array and a matrix. So all these are available in our R programming. Now we'll move on to the R Studio. So I'll show you the implementation and the syntaxes of all these data structures. So let us move on to the system.
So hello friends, so just now we have seen the theoretical part of different data structures in R programming. So we have seen the syntaxes. Now we'll see the implementation part. So how we can implement these data structures, the complete basic thing. So in depth we'll go in our further concepts, right? Now let us open the R Studio environment. So once it was open, so we'll go one by one. So starting from the vector, followed by a list, a matrix, array and a data frame, right? So let us write a small, initialize a vector here. So some v is equal to c of, let us give the values, so 10, 20, 30, 40, 50, and let us print that particular vector here. So execute the complete statements. So go here, so execute, you can get the elements here, right? So this is an environment variable. So here indexes 1:5 and the values will be printed in this particular output console. Now let us try with the different data types and execute. See, it was accepted. So we have studied that a vector is a single dimensional part, so where it can accept multiple elements of same data type or not a different data type, because you can observe here. So whenever you given 9.5, you can see every element have been converted into a float. So unless there is a 9.5 here, so it was executed, but all the elements are in of integers, right? So here it will accept the homogeneous elements, that means the same data type. Now we'll move on to the next one, that is a list. So let us change L is equal to, in order to create a list we need to apply the list function. So list function and give the elements, and it is nothing but it's also a single dimension, but the elements can be of different data types. It will accept different data types. So if you give the same thing, see, if you give the same elements, that means some 5 elements of integers and one a float, and I'll print L, and now you can observe, see, the 5 elements are of integer only and the last element will be the float value. So all the elements will be remain same. That means it will accept the heterogeneous data types, that means a multiple data type elements, right? So vector is a single dimension and a list is also a single dimension, but the main difference over a vector and a list is, in a vector it will accept only a same data type of elements, and in a list it will accept a multiple data type of elements, right? Now we'll move on with the next one, that is a data frame. So let us create 3 vectors. So data frame is a tabular representation, just now we have seen, right? So in order to represent any data in a tabular format, so we can go with this particular data frame, and here we can give multiple vectors and we can collaborate all those vectors into a data frame so that the data will be displayed in a tabular format. So let us take some student details. Let us take some S number is equal to C of some 101, 102, 103, and so these are vectors, right? These are vectors. So student name is equal to C of you can give ABC, DEF, GHI. So all are of same data type, because this is a vector and it will accept only the homogeneous data. That means every element should be of same data type. And I'll go with the percentage. Student percentage is equal to C of let us use some 98, 89 and some 80, right? Now we will combine all these vectors in a data frame, so the complete data will be available in a tabular format. Let us take, so df is equal to, the function is data dot frame, and you can pass all these things: S number, S name, sorry, S number, NO I think we have given, so S name and S percentage, right? Now you can just print data frame df. So if you execute here, you can see S number, S name and S percentage, and you got the complete details in a tabular format. So 101 is a serial number, and student number is 101, student name ABC, and student percentage 98. So here we have given an individual vectors, but in the output we are seeing the tabular format. So in order to represent any data in a tabular format, we can go with the data frame, right? And the next one is an array. So we know that array is also homogeneous elements. Okay, so here we use an array function to create an array. So A is equal to array of, so give a vector C of, I'll give some 10, 20, 30, 40, 50, 60, and in array we need to specify the dimensions. So array can be of n dimensions, right? So it will be having 2 2 by 2 array, 2 by 3 array. So dimensions means 2 by 2. That means 2 rows and 2 columns. We call them as a dimensions, right? So here we need to give a second parameter dim and give the dimensions as a vector. So in the dimensions, 3 parameters. The first one represents the rows, second one represents the columns, and the third one represents number of arrays of the particular dimensions. So here we have given some 6 elements. I'll give some 2 comma 3 and 1. So that implies the dimension is 2 by 3 matrix. The order of a the array is a 2 by 3 array of one array, right? It will be having only one array. And now we can see print A and execute. So you will be getting the same thing. See 10, 20, 30, 40, 50, 60. So everything will be in a column order, right? So you can observe the 2 rows and 3 columns. 2 rows and 3 columns. And the same thing we can give a matrix. We can give a matrix. So M is equal to, we need to give the matrix function. So in that matrix, again, you need to take the complete values. So C of 10, 20, 30, 40, 50, 60. And here we need to give the number of rows and number of columns. So order of a matrix, right? So n row is equal to, I'll give it 3 rows, and n column is equal to, I'll give it 2 columns, right? And simply print m, and you can observe here, see the 3 rows and the 2 columns. So if it is an array, we need to specify the dimension. So here, there also we need to specify the number of rows and columns, but we call it as a dimension. And coming to the matrix, here we need to give some n rows and n columns, and you can observe by default it will be taking the elements as a column wise. If you want to arrange them in a row wise, so you need to add one more parameter called by row is equal to true. So elements will be arranged in a row wise. So you can observe here 10, 20, 30, 40, 50, 60. So if you are not giving this by row parameter, so the data was filled with a column wise. See 10, 20 is in second column, I mean first column, and 30 will also be in the first column. Then only 40, 50, 60 will be arranged in second column. Now if you add this parameter by row is equal to true, and if you execute, you can observe 10 and 20 will be the first row, 30 and 40 will be the second row, and 50, 60 will be the another row. So that means the elements will be arranged in a row order. So we'll change the data types. So 30.4, 40.5, and still execute the same thing. And you can observe this is a homogeneous. Everything has been changed to float. Everything has been changed to float, right? So a slight difference among the vector and a list as well as the array and matrix, right? So hope you understood. These are the basic data structures, and we call them as a built-in data structures in R programming. So we can make use of all these type of data structures according to our programs.
So R programming supports different kinds of operators. So we will see the first one, arithmetic operators, relational operators, logical operators, assignment operators, and miscellaneous operators. So all these operators can be implemented for 2 things. One is on variables, on vectors. So we have seen in our previous video what is a vector, right? So it holds the complete multiple elements of same data type, right? So we can apply these operators on vectors or on variables. So if you apply these operators on vectors, the result will be in the form of a vector. I mean, vector means the operator will be implemented for each and every element of the vector. So we know that arithmetic operators: addition, subtraction, multiplication and division, right? So apart from these, a few more operators are included in this arithmetic operators, which is mod, which gives the remainder, and so this mod is represented as a double percentage, and this is a which gives the quotient as a result, quotient. And one more thing is an exponent. So if you go with the example, I will give an example. Vector, let us take some vector a 1 2 3, b is also vector, some 4 5 and 6. Alright, so if you go with the a plus b, the result will be 1 plus 4, it will be 5, 2 plus 5, it will be 7, and 3 plus 6, it will be 9. So it will add complete individual elements of the vector. So if it is a normal vector, if it is 10 and b is equal to 20, obviously a plus b will get it as a 30, right? So if it is a vector, the operation will be applied for individual elements of a vector, right? So don't worry, just I'll give you the introductory part now, and we'll see the implementation in the RStudio, right? So we know that subtraction, that's a difference, multiplication, which product, division, which gives the accurate result, right? Accurate result. And this is a mod, which gives a remainder as a result. Remainder, right? Remainder of the after the division operation. So if you apply the division operation, we'll get a remainder and quotient. So this is the remainder, and this will be the quotient, right? For example, if 3 is divided by 2, so 2 ones 2, right? So this will be the remainder, this will be the quotient. So if 2 double mod 3 double mod 2, that means 3 is divided by 2, the remainder will be 1, and 3 divided by 2, which gives a quotient, which is again 1, and 3 divided by 2, which gives it as a 1.5. So this is the difference. And exponent is nothing but a power. So for example, a is equal to 2 and b is equal to 2 or 3, and a cap b, which gives it as a 2 power 3, right? Which gives a 8 as a result. So this is the exponent, and all these operators comes under arithmetic operators. So we call them as a arithmetic operators, and we'll see the implementation part in RStudio system, right? So next go with the relational, so which gives a comparison between different operators, I mean different variables or vectors, and also it will result Boolean. It will give the Boolean result, right? Boolean result means either it will be either true or it will be false. It will be either true or false. So this can also be used in between the vectors and the variables. So for example, a is equal to some c, 10, 20, 30, and let it be b is equal to some c of 100, 10 and 40, or simply you can go with the 30, right? So you can see a, first we'll see the operators: less than, greater than, less than or equal to, greater than or equal to, double equal to, and not equal to. So all this comes under the comparison operators, or we call them as a relational operators. So if you go with the a less than b, the result will be 10 less than 100. So obviously it will return true. 20 less than 10, it is a false. And 30 less than 30, again it will be a false. So the result will be in this way. Right? It will return true or false. right? So it will compare each and every element, it will return true or false. Otherwise, if you are applying the same relational operators in between the variables, directly we will get only single value, that is either true or false. For example, a is equal to 10 and b is equal to 20. If you go with the a not equal to b, which gives the result as true, because it is only a single value. It is a single value, right? So which compares the value of a variables or a vectors is called as a relational operators. So comparisons will be done. And next category of operators are the logical operators. So here we'll get AND, OR, NOT, double ampersand and double OR, right? So usually all these comes under the logical operators. So here mainly non-zero value will be considered as a true and zero value will be considered as a false. Zero value will be considered as a false. So here also the comparison will be done. Okay, and if both are true, so if it is n, both are true, then only the result will be true. And or both are false, both inputs are false, then only it will get a false. If any one of the input is true, automatically it will be returned true. And not if true, it will return false, and if it is false, it is a true, right? So and these two operators will be used in compound conditions. So here what is a compound condition means? Comparing two simple conditions. So in comparing conditions, we are going to use this double and double OR. For example, A greater than B, A greater than C. If you want to compare these two, so we need to use this double ampersand. So we'll get a Boolean result for this condition and Boolean result for this condition. So for those results, we will apply the AND operation. So if both are true, then only we'll get a true. If both are false, it will be false. So similar to single ampersand and single OR. But here we'll use this double ampersand and double OR for compound conditions, comparing different conditions, right? So I'll show you an example in RStudio, right? Don't worry about that. But here one thing we have to remember, non-zero will be considered as a true and zero will be considered as a false. Assignment operators, we have seen the assignment operators in our second video, I think, is equal to assign a value to a variable and right word, left word. So using all these things we can assign a value. So a is equal to 10, a 10, right. So in all these three cases, 10 is a value stored in a variable a, right? So these are all called as an assignment operators. And last one is a miscellaneous operators. Here three miscellaneous operators are there. So those three miscellaneous operators are a colon, so which gives a range of values, which specifies the range, right? And ampersand, in ampersand. This is for search. And one more is a star, which gives the product of matrix with its own transpose. It gives a product of, it will be used for a product of matrix with its own transpose, or else it will give sum of products in a vector. I'll explain you one by one, right? So coming to the range, so these three we call it as a miscellaneous operators. Range means we can give a is equal to 1 to 5. That implies a can hold values 1, 2, 3, 4 and 5. So we can specify a range instead of giving a single value. Search. So if you are using this particular range, we can search whether any variable is available in that particular range or not. For example, if you go with a b is equal to 4, you can search, so b in a. So if b value is available in a, it will return true, otherwise it will return false. So again here the result is Boolean result, right? So this is for search, right? So the operator is percentage in percentage, and this is a product, I mean matrix with its own transpose, product of matrix with its own transpose. For example, if it is a vector, let us take a vector so that you will be understanding. B is equal to, again one more vector, so 2, 3 and 4. So if you go with A and into B, we will get 1 into 2, 2 into 3, 3 into 4. If you go with this miscellaneous operators, star in between star in between the percentage symbols, so it will give us 1 into 2 plus 2 into 3 plus 3 into 4. So which gives us a 2 plus 6, 8 plus 12, 20 will be the result. 20 will be the result. So it will give the sum of products. Sum of products. So this is the first element, this is the second element, this is the third element. So we are adding all these three elements. So sum of products of elements in a vector. So this is the third miscellaneous operator, right? So hope you understood this. So these are all the operators which are supported in R programming. So arithmetic operators, relational operators, logical operators, assignment and miscellaneous operators. So other programming languages also the same operators will be used, but some sort of representation will be different. The symbols to represent the operator will be changing from one language to another language, right? So hope you understood. So let's move on to the RStudio so that I'll implement each and every operator and I'll explain, so that if you are still having any queries, so everything will be cleared after watching the implementation part. Let's move on to the RStudio.
Hello friends, so just now we have seen the complete theoretical part of different operators which are available in R programming. Now we'll see the execution or implementation part, right? So let me open the RStudio, so where we are going to write down the programs and execute them. So yes, let me clear all the things which are already available. Now we can start. So we have seen a different operators in that are supported in R programming. So first one is arithmetic operators. In that operators we have seen addition, subtraction, multiplication, division, and one more thing, a mod, so which is represented with a double percentage, and quotient. So quotient is represented with a percentage slash percentage, and then exponent operator, right? We'll see one by one. So we know that arithmetic operators, and these operators can be implemented on individual variables or the complete vectors, right? So let us take a is equal to 10, a is equal to 10 or 20, and b is equal to some 30, and you can simply go with a print a plus b. So it will be executed, and see, you will get the result as a 50, right? So normal arithmetic addition, this is called an arithmetic addition. So the same thing happens if you apply on vectors also. Now we'll see the vector. So vector is represented with the C followed by the parenthesis and give the number of values. So 10, 20, 30, 3 elements, and let us take here C of let us take some 40, 50 and 60. And if you apply the same thing in between the vectors, so previously we have seen the only normal variables, right? So now execute, and now you can see the result is 50, 70, 90. So the individual elements of A and B are added, and it will be printed on the screen. So 10 plus 40, 50, 20 plus 50, 70, 30 plus 60, 90. And here you can see in the environment, the A value holds the three values because it is a vector, one column 3. So that means 1, 2 and 3. So which is a 10, 20, 30, 40, 50, 60. And the same thing, so this is all about our addition, and similarly subtraction. So normally we can go with the subtraction with the normal variables. So let us take some normal variables. Some m is equal to 30 and n is equal to 20, and once again I will go with the a minus b, right? So here a and b are the vectors and m and n are normal variables. Let us execute. And you can observe here AB are the vectors and MN are variables, right? Say A minus B. So 10 minus 40 is a minus 30, 20 minus 50 is a minus 30, and 30 minus 60 is a minus 30. And M minus 10 again, that means 30 minus 20 is a 10. So the subtraction. So all these operators can be applied on either vectors or a normal variables. And coming to the multiplication, that is also common. So which we are using in our daily life. So see, execute. See, 10 into 40, 20 into 50, 30 into 60, and similarly 30 into 20, 30 into 20. So this is a normal multiplication. And coming to the division, so you'll get the complete accurate result, right? So accurate result. So if you execute, see, 10 divided by 40, which is a 0.25, 20 divided by 50, which is a 0.40, 30 divided by 60, which is a 0.50, right? So and here 30 by 20, it's a 1.5. So these are all normal arithmetic operators: addition, subtraction, multiplication, and the division. And now we'll go with the mod operator. So we'll see the mod, so which is represented with a double mod, right? Which will give the remainder, of a value, right? So let us execute and see the remainder. What is the remainder? 10 mod 40, which is a 10, 20 mod 50, which is a 20, 30 mod 60 is nothing but 30. So because, so here this is a lower value. If you use some B and A, see, 40 divided by 10, which is 0, that means remainder 0, and 50 divided by 20, the remainder is 10, right? So 22 is 40, so and the remainder is 10, and 60 mod 30, which is 0. So we'll get the remainder as a result. What is the remainder? And coming to the normal variables, you can see 30 and 20. So 30 mod 20. So 21s are 20, the remainder will be 10, right? So that's why we got the result as a 10. Now, coming to quotient. If you want to get the quotient, so this is a reminder, okay? So this is a reminder, and now we are talking about the quotient. So that is represented with a percentage divided by n percentage. Now I'll show you. So this is the quotient. See, 40 divided by 10. So automatically 10 4s are 40. So the quotient is 4. And 50 divided by 20, because B divided by A we are giving, not A divided by B, right? 50 divided by 20. So 22s are 40. So 2 will be the quotient. 60 divided by 30, again 2, and 30 divided by 20, and the quotient is 1. So we'll get only the quotient. That is also in integral part, right? So hope you understood. Now we'll see the next one, that is a exponent operator. So let us take some 2, 3, 4 and 4, 3, 2, and let us take it as a normal exponent operator A cap B. Cap exponent, that means A power B. Oh, sorry. 3, 1, A cap B, right? So let us execute. Now you can see A cap B, 2 power 4, which is 16, 3 power 3, which is 27, and 4 power 1, which is a 4. And similarly, 3 power 2, that means a 3 square, which is 9. So all these are the arithmetic operators. Now we will move on to the next one, that is a relational operator. Relational operator. So this is nothing but comparison operators, which is less than, greater than, less than or equal to, greater than or equal to, double equal to, not equal to. So all these things will return Boolean result. Boolean result. So what is meant by Boolean result? Either it will return true or it will return false. Right? So here I'll write here. So A greater than B, and here also I'll go with the M greater than N. It will compare each and every element of different vectors and it will return the result. See, you can observe. See, 2 greater than 4, it's a false. 3 greater than 3, it's again false. 4 greater than 1, it's a true. And 3 is greater than 2, it's a true. So it will return either true or false. Okay, and similarly, less than, all these relational operators will work in the same manner. So it can be used in both the normal variables and the vectors. So here 2 less than 4 true, 3 less than 3 false, 4 less than 1 false, 3 less than 2 false. And if you go with the is equal to, again you will get the same Boolean result. Same Boolean result. Right? And also is equal to. Is equal to. See. Okay. So the complete relational operators and everything, if the operator is used in between the vectors, it will result with an individual operator, individual element of the vector, right? Next, after the relational operators, we'll go with the next one, that is the logical operators. Logical operators. So one is AND, OR, NOT, and logical AND and logical OR. So there is a slight difference between this single ampersand and double ampersand, right? So that comes with the normal. I'll show you. So if you use the same thing, so go with the A ampersand B, that means AND. So we know that just now we have seen AND means if both the inputs are true, then it will result true. So here what is a true? Here true means a non-zero value will be true and 0 will be false. So any non-zero value we can consider as a true. So here 2 is a true, 4 is true. So let us take one more thing which is a false. We can also take that one, right? So because it's also one data type. I'll go with the true, right? Now you can observe. See, 2 is a true and 4 is true. So it gives true. 3, 3, true, true, true. 4, 1, true. False and true. So false, because if both the inputs are true, then only it will return true. Otherwise, it will return false. So we can change it here 0 and I'll change here 0. Now you can observe here. See, 2 and 4 both are non-zeros, so true. 0 and 3 false and true, false. 4 and 0 false, false and true, false. So non-zero value will be considered as a true and a 0 value will be considered as a false. And also we can directly take the Boolean data types. Okay, and M and N. So here M is 3, which is a non-zero true. N is 2, which is non-zero true. So if you apply the AND operation, we'll get the result as true. And if you apply the OR operation, so we know that OR operation means if both are false, then only it will be false. If any one of the input is true, the result will be true. Right? So if you execute with the OR operation, so take the same example and apply the OR operation. So here 2 and 4 both are non-zeros, will get a true, and 0 and 3, that means a false and true. So if any one of the input is true, the result will be true. So obviously the second one will get true, and 4 and 0 again it will get true, true and false again will get true. See, you can observe true, 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 and here also will get true. I'll change here 4 as 0, and now you can see the third element of both the vectors are having the false. Now you can see, if both the vectors are false, automatically the result will be false. So this is about the logical and OR operators, right? And this again, similarly we are having one more, that is a double ampersand and double OR. So if you use a double AND, so two ways. If you are applying the double ampersand in between two different vectors, it will compare only the first element of both the vectors. If the first element of both the vectors are true, then it will return true, or it will return false. It doesn't compare each and every element of the vector, right? See, you can observe. Okay, so right, so and next one is a not. So that means, see, this not, so not is for negation. That means if the input is true, then it will be returning false. If it is false, it will return true. That means it will take only one argument, that means one operand. So A not B is not correct, not A is correct, and here also not M. Now you can see 2 means a true, 0 means false, 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 and if you execute, we'll get a false, true, 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 because this is true, so it becomes false. These three are false, so it becomes true. And here also M is 3, we'll get a false. If M is 0, we'll get it true, right? So this is how we can use the AND, OR, and negation. And coming to this ampersand, double ampersand, and double OR, these are used for a logical condition. So if you want to check multiple conditions, then we can use these AND and OR operators, multiple conditions, right? So that means, let us take here M greater than N and P greater than Q. Let us take P is equal to 10, Q is equal to 2. Let us remove all these things and execute. So you'll get a false because M greater than N. So this is a compound condition. Okay, this we call it as a compound condition, right? So compound condition means we comparing two different conditions. So M greater than N. So 0 greater than 2, false. So if any one of the condition is false, automatically we'll get a false because we are using double ampersand. For example, if you take here 20, then it will result as a true because M greater than N, that means 20 greater than 2, true. P greater than Q, 10 greater than 2, it's again true. True and true, true. So like that in the compound conditions, we are going to use these logical operators. And the next one, assignment operators. Assignment operators. So this we have already used all these things, assignment operators. So one is equal to, or we can also use right word, and we can also use left word. Okay, so by using all these things, we can use assignment operators to assign a value. So all these assignment operators we have already covered because in all these cases we are using the same thing, right? Assignment, without assignment we can't assign a value to the variables, right? And here there are a few more operators. Those are called as a miscellaneous operators. Miscellaneous operators. mainly there are two miscellaneous operators. So one is a colon, which gives a range of values, and another one is a in, so which will be used for searching for a value, and one more is a star, right? So three operators, we call it as a miscellaneous operators. Let us check with this one. So let us take some some a is equal to, I'll give it 1 with 10. 1 is to 10. So here colon is a one miscellaneous operator which will give the range. So this line indicates, this instruction indicates, so a holds the values from 1 to 10. And now you can see print a. See, a will be having the values with 1 to 10. So this is one miscellaneous operator which will give the complete range of values. And similarly, one more thing, that is a in. So b is equal to some 5. We can search this 5 whether this particular b value is available in this given range a. So for that we can go with the b in a. So search, if it is available, it will return true, otherwise it will return false. You can see it is true. And if you go with the 50 and execute, so 50 will be not available in from 1 to 10, so it will give false. So this replaces the search. If we are searching for a value in a complete sequence, obviously we can go with this particular operator called in operator. Right? So, and also you can see, let us take some vectors 10, 20, 30, and b is equal to 1. Just for better understanding, I'll see c is equal to 1 comma 2 comma 3, and here also we'll take small values 3 to 1, right? And now yes, here it is a vector, so it should start with c, and here the operator is a star operator b. Now what happens, you can observe what happens here. See, this gives the product and sum. So 3 into 3, 3 into 1 plus 2 into 2 plus 1 into 3. Okay, so you can observe 3 into 1, it's a 3, plus 2 into 2, it's a 4, plus 3, 7, 3 into 3, 3 into 1 into 3, again 3, right? So this gives some 3 into 1 plus 2 into 2 plus 1 into 3. So obviously we'll get the result as 10. Usually this operator is mainly used to multiply a matrix with its own transpose. Multiplying a matrix with its own transpose. For that purpose we are going to use this operator called a star. So usually if you take these percentage symbols, then it will execute, it will be treated as a normal multiplication. So 3 into 1, 2 into 2, and 1 into 3. And if you use a mod, in between a mod, then obviously it will be considered as a sum of products. Okay, sum of products. So 3 into 1 plus 2 into 2 plus 1 into 3. So obviously we'll get a 10. Right? So all these are the different operators. So we have seen arithmetic operators, relational operators, logical operators, assignment operators, and miscellaneous operators.
So first let us see the input functions and then we'll move on to the output functions. So now I'll tell you the complete syntax of these input functions and output functions here, and we'll see the implementation in RStudio. So let us start with the input function. So in any programming language, so we need to give the input during the runtime. So we should not assign a values to a variable in the program itself. So we need to use some function and that reads the input during runtime, right? So here we are having two types of input functions which takes the input during the runtime. So one is a read line function. read line function, and one more is a scan function. Right? So both purpose of using these both functions are equal. So both will read the elements from the user during runtime. So here always reads character data type. So read line function will always read the character data type. So for example, if user gives the input as 25, so that will be taken as a character. Okay, so whatever the data we are reading using read line function, that will be stored in terms of character. So how we can change this character into an integer. So we know that, so integer value should be ends with a L. It should be represented with a L at the end of the number. So how can we convert this character into this integer? So this is a character and this is an integer. So how we can convert? So for this conversion we are going to use a function called as.integer function. So by using this function we can convert one data type to integer data type, any data type to integer data type, right? So now the syntax here is a variable name. Syntax for read line is a variable name is equal to read line. So automatically whatever the value the user reads during the runtime, that will be stored in this particular variable name, right? And one more, also we can give a prompt. Okay, also we can give a prompt like this, where variable name is equal to read line, and here you need to give a prompt, right? Like enter value. So first this string constant will be displayed on the screen, and then it will prompt for the value, right? So I'll execute all these cases in our RStudio. Okay, don't worry. So I'm just using the syntaxes, right? And one more way we can represent is variable name is equal to read line, and instead of giving directly, we can use an attribute called a prompt. Prompt is equal to enter value. So in all these three cases, we can read read the input from the user during the runtime, right? Either you can use an empty parameter, one parameter with a string constant, and one more parameter by using a prompt attribute, right? And in all these cases, reads a single value, right? So the read line function will always read a single value as a character data type. So coming to the scan function, so it reads multiple values as a vector. So we have seen this vector in the data structures, right? So vector is a homogeneous collection of elements, right? So scan function is used to read multiple elements and it forms a vector. That's the only difference between this read line and scan. So scan doesn't take any parameters, so just we have to use a scan function only, right? So these are the input functions available in Python. So in order to read the input from the keyboard during runtime, so the user have to use either read line function or a scan function, right? Now after reading the value, so we need to produce the output, we need to display the output. Now we'll see the output function. So what are the different output functions it will support, right? So the next concept is output function. So here also we are having two types of functions. So one is a print function and another one is a cat function. So print function is used to print the string constant. So it will take only one parameter. So only one parameter, and also it doesn't concatenate multiple outputs. This is the most important. So it doesn't concatenate multiple outputs. For example, if your A is having some 5, and if you print A, this will give an output as a 5. And if you print A, it will return a result as A. But if you print A is equal to A, so it will print only the string. So it doesn't print the value of A. So this is the disadvantage of using print. So it doesn't concatenate a multiple outputs. So it can't differentiate the two different outputs. So here this is a constant string and this is a variable. So it can't concatenate both of things. So in order to display the same thing here, we need to use a cat function. So concatenate multiple outputs. So here we can write it as, so all the three cases we can write it here. So cat A, it will display the output as a 5, and cat A, it will display the output as A. Cat A is equal to comma A, then it will be treated as A is equal to 5, right? So here by using a cat function we can concatenate multiple outputs. That means we can combine both the string constant as well as the variable, right? So these are the different output functions we can use to display the output on the screen in R programming, right? So hope you understood the syntax. So now let us move on to the RStudio. I'll explain or by implementing all these 4 functions, input functions and output functions. So readline, next scan, print and cat. So let's move on to the system.
Hello friends. So just now we have seen the complete syntax of input and output functions in R programming. So input functions, we have seen 2 functions. One is a read line function and a scan function. So these 2 functions are used to read the input to a variable during the runtime. And the output functions also, we have seen the 2 functions, print and a cat functions. So the purpose of both the functions is to display the output on the console. Now we'll implement the same thing in the programs. So let us open the RStudio. So in the RStudio, we'll take some values and we'll read the values at the runtime itself. Okay, see. So previously we have taken directly a value to the variable. Now we are going to use these functions. So A is equal to read line and print A. So you can see if you execute the same code, so it will prompt for the value. So if you give the value 10 and the result will be 10. Here you can observe, right? And this can also be done with a prompt. Okay, this can also be done with a prompt. So read line, and here you can give the prompt, enter value. So we can directly give the prompt here itself. No need to use the one more print function, right? So read line, and here I'll give enter value for A, right? If you execute, you can observe, so the prompt will be displayed first and then it will ask for the value. I'll give it 20, so we'll get 20 as a result. And you can observe, so here the value of 20 is enclosed in double quotations. So that means whatever the input we are reading through the read line will be considered as a string. So we need to convert that into functions. I mean type conversion we have to do. So the one type conversion function is as dot integer, which is used to convert the any type of data into a integer data type. See, I'll write here once again. So after reading the value, so if you want to know the data type of that particular object or a variable, we can use a function called a class. So class of A will give you data type of a particular object or a variable. So here usually we call them as an objects. Okay, see, so here it will prompt for a. I'll give some 25, enter. So the class of a is a character. So this is not an integer, it's a character. Even though we are giving some numerical data, so that will be considered as a numerical string. So that's why it was enclosed in double quotations. And now after that we need to convert into integer. So the function to convert in integer is as dot integer of a, as dot integer of a. So now if you execute here, so it will prompt for a. I'll give some again 25, and now you will get the result as an integer. You can see 25L. So in our data types concept, we have already studied that the integers will be represented with a L at the backside, right? So this is how we can use the read line function. Okay, and also one more syntax. So directly we can give one more attribute called prompt. Prompt is equal to enter value. So like this we also we can give, right? So let us try with that one. So read line prompt is equal to, so you can execute. Still we are getting the prompt. I'll give some 24, and again it's an integer. So class function is used to know the data type of a variable or an object, right? As dot integer function will convert the data into integer data type, right? So these are the two functions we are using now, right? So hope you understood the read line. So if you are not passing any parameter into the read line function, obviously it will prompt for the value, so nothing will be displayed in the console. And if you give some prompt as a string constant as a parameter to read line, then first the data will be printed on the console, and then it will prompt for the value. And whatever the value we are giving after executing the read line function, will always consider as a character data type. This is most important, right? Always the read line function will take the character data type as an input during the runtime, right? So one more thing is a scan function, which is used for reading a multiple values. That means a storing of vector, right? Storing of a vector. So we know that a normal variable is different from a vector. A normal variable can hold only one value, and a vector can hold multiple values. Now you can see, so a is equal to scan. Use a function called scan and print a, and you can execute. See, it will prompt for a. So I'll give 10, see, 20, 30, 40, 50, 60. It's keep on moving. So if you don't want to enter any more numbers, press again enter. So it will stop, and you can observe if you print a, we are getting some 10, 20, 30, 40, 50, 60. So here is the value. And you can also check the class. That means a data type of that particular variable. So which is nothing but a numeric. See, 10, oh, sorry. Here it prompts for a value. So 10, 20, 30. So you can observe the data type of a is a numeric. Okay. So here also we will see giving a prompt, enter values. So it doesn't take any parameter. Okay, just we need to use scan function. Scan function is used to read multiple elements. So it will read a vector. In order to read a vector, so we'll simply use this scan function, right? So these are the two different functions, a read line and a scan function to read any value from the keyboard during runtime, right? Now the output function. So how we can display the output on the screen? So one thing is a print function. And here you can see, so read line, and let us take enter value for a, right? So it will prompt, and see, I'll execute. So it will prompt for A. I'll give some 67 and you will get a 67 as a result. If so, print function will always display the content on the screen. Okay, if I give here welcome to R programming, what happens here? So execute, it will prompt for A because first line we have written some read line and the second line welcome to R programming. So this is also right. So but we can't concatenate two different outputs in a single print function. That means if you want to display the value of A as, see, A is equal to A. So if I just want to get an output like A is equal to A, so that doesn't, see, I'll give some 10. See, that will not be supported. That means we can't concatenate two different parameters, two different outputs by using print function. So we'll get only A is equal to, this is a string constant. So only that function or that string constant will be displayed on the screen. So if you want to display both the string constant and the value of a variable, so we need to use a cat function. So cat and use the same thing, A is equal to comma A, so which will display the complete output in a given format. See, A is equal to 34. A is equal to 34. So we can combine or we can concat two different parameters by using this cat function. So whatever the string we are enclosing in the double quotations, that will be considered as a constant string and that will be displayed on the output screen. And outside the double quotations, that means other than the double quotations, whatever the variables we are giving, so that will be considered as a normal variable or a vector, and instead of printing the name of a variable, it will print the value of a variable, right? So in order to print the value of a variable, we should not enclose that in a double quotations. Okay, see, cat A, and you can execute. So I'll give some 67 and definitely we'll get the 67 as a result, right? And that's also, you can observe here the character data type, right? So these two are functions. So read line function, scan function are used to read the input during the runtime, and print function and a cat function are used to display the content on the console, right? So in this explanation we have seen two more functions, the class function, which is used to know the data type of a variable or an object, and one more function as dot integer, so which will convert the data into the integer data type. So by default this read line function will take or will consider the value as a character data type, right? So this is all about our input and output functions. So hope you understood this one. And
so today's topic is conditional statements in R. So these conditional statements are one of the control structures in R programming. So first of all, let us see about a flow of control or control structures. First we'll see the control structures. What is a control structure? Control structure. So which will give the flow of control. That means the flow of execution of a statement. Okay, which statement is to be executed, right? So here we are having three different flow of controls. One is a sequential. Sequential means instruction by instruction. So if you are writing some 5 instructions, so the first line will be get executed, and after that one the second, after that one third. So in that sequential manner the flow of execution will be there. So that we call it as a sequential flow. And the second one is a conditional, and the third one is a iterative. So this will be the default flow of control. That means default flow, right? By default. So we have seen many programs in our previous sessions. So there the default control flow is a sequential. That means instruction after instruction, right? So in which order we are writing the instruction, the same order the execution will also be done. And now coming to the conditional control structures. So conditional control structure means we have to write one condition And we know that a condition means the expression with a boolean, or relational operators. The condition with the relational operators, the expression with relational operators. For example, A greater than B is nothing but a condition, because A and B are operands, and this is a relational operator. So we are comparing the values of A and B, and the result will be either true or false. So which we call it as a boolean result. So always the condition will result a boolean result. That means either it will be true or false. So if you are comparing the two variables, the result will be either true or it may be false, but not both, right? So based upon the result of this condition, the interpreter will execute either true block or a false block. So here usually we call it as a if, and here we call it as a else. So if block and else block. So if block is a true block and else block is a false block. So here at a time, based upon the result of the condition, either true block will be get executed. That means whatever the instructions we are writing under the if block will be get executed, or the instruction written in else block will be get executed. And one more important point is, so that we call it as a conditional control structures. And here one more point, always the condition should be written in if block only. The condition should be written only in the if block. The condition should not be written on else block. Okay, so without if block we should not write else, but without else we can write if, because we are writing condition in if block only. So here the conditional statements are again categorized in different ways. The first one is simple if else, else if ladder, nested if. So these are the four categories of these conditional statements. Now we'll see the syntax of all these four, and then we'll move on to the RStudio, and I will show you the example, each and every example for each and every conditional statement, right? So other than these four, there is one more conditional statement, that is a switch case. So that we'll discuss later. In today's session, we'll discuss about these four conditional control structures: if else, else if, and nested if. So starting with the simple if. So just now we have said that if is a true block and the condition should be written only at the if block only, right? So without the if we should not write else, and without else we can write if. So here only true block will be there. Only true block. That means if block will be there, will exist. So we have to give the instruction to the interpreter which are to be executed if the condition becomes true as well as if the condition becomes false. So in this simple if, we are giving the instructions only if the condition becomes true. So we are not giving any kind of instructions if the condition becomes false, right? So the syntax for this simple if is a keyword, small letters, lowercase letters, and parentheses. Write down the condition here, and open the curly braces in order to represent a multiple statements, that is a block of statements. That's it. So this is the syntax, and here we have to write down the statements. So we can write one statement or more than one statement, depends upon our logic, right? This is called as simple if. Only true block will be there. So if the condition becomes true, these statements will be executed. If the condition becomes false, and outside the if block, statements will be get executed. So we'll write here statement X and statement Y. Okay, if the condition becomes true, then the control enter into the loop and statement X will be get executed, and after that statement Y will be get executed, because statement Y was written after the if block. And if the condition is false, the control never enter into the loop, never enter into the block, and directly the statement Y will be get executed, because statement Y will be the outside the if statement. So that will be the sequential execution again, right? So this is a simple if. Now we'll write a if else. In the if else, the name itself indicates we have to specify the instructions in both the true block and false block. So I'll write here if else, right? So here we have to write true block and false block. So even though we are writing both the blocks, only one block will be get executed, whether depends upon the result of a condition, right? So if here, and here one more important thing is, else should be written immediately after the closing braces of if. Okay, so don't write else outside, okay, in the new line. So the closing braces and else should be in the same line. So else, open brace, statement Y, statement Z. So here, this is a syntax for if else statement. So here always the condition should be written only in the if block, right? No, we should not write the condition on else block. So based upon the result of a condition, if condition becomes true, statement X will be get executed, and immediately statement Z will be get executed. So the control never enter into this else, because this is a false block. So if the condition is true, the true block will be executed and the false block will be ignored. And if the condition becomes false, directly the control enter into the else block. The control never enter into the if block, because if is a true. So this block of statements will be executed only if the condition becomes true, and this block of statements will be executed only if the condition becomes false, right? So only one block of statement will be executed based upon the result of the condition, and immediately after that the statement Z will be executed commonly, because that was written after the if else statement, right? So hope you understood this one. So example, I'll show you the implementation part in the laptop. Okay, now we'll move on with the next one, that is else if ladder. Else if ladder. So here, if we want to check multiple conditions, okay, if one condition is already verified, and based upon the result of the condition, again if you want to check one more condition, then we should not write the condition in the else, right? So that's why we have to include once again if, and we can write the condition. So in order to check multiple conditions, multiple conditions. So n number of conditions can be written here, any number of conditions. So even though number of conditions have been written, only one block will be get executed. For example, see else, and again here we have to write one more condition if you want to check it, right? And after that, simply you can write a else part, and you can repeat the same thing multiple times. If you want to write a multiple statements, you can repeat it multiple times, and finally the else part can be written here, statement Z, right? So first this condition will be verified, and based upon this condition, if this condition is true, this will be executed, and automatically the control will never enter into any other condition. If the condition becomes false, and if you want to check one more condition, okay, if the condition becomes false, and if you want to check one more condition, then simply it moves with the next condition. And here also, if the condition is false, it will move to the next condition. So if the condition is true, there it will stop. Okay, it will enter into that particular block, and it will stop executing the complete else if ladder. So here we can write a multiple number of conditions. So 100 conditions also we can write. but only one block of statement will be executed. So whenever the condition becomes true, then only that will be executed, otherwise the else part, this else will be get executed. Okay, so in order to check multiple conditions, we are going to use this else if ladder. For example, let us take some, we need to check a number is a positive, negative, or a zero, So first we can check a is equal to 0. If it is true, then we can simply say that the given number is 0. If it is not 0, we have to check whether it is a positive or a negative number. Okay, again we are having two things. It can be a positive number or it can be a negative number. So once again we can write, so this is a if statement, and else means nothing but the condition becomes false. Again we have to check condition, else if a greater than 0, then simply we can say it's a positive number. And if both the conditions are false, simply we can say else, simply it's a negative number. If a number is not a 0 and not a positive, obviously the number will be a negative number. So here we are writing the three blocks of statements, right? Here we are writing 3 blocks of statements, but the only one block of statement will be get executed. Okay, not all the 3 blocks will be get executed. Only one block of statement is being executed. So this is called the else if ladder. So multiple conditions can be written here, right? Next, last one is a nested if. Nested if. The name itself indicates we can write the if block inside another if block. So let us write nested if, right? So we can write if and condition, and if the condition is true, again we can write one more condition here. We can check one more condition here. So here we can write else, and here we can write else, right? So like that, inside the if condition, once again we can write these if else conditions. Depends upon our logic. Okay, depends upon our logic. So don't worry, I'll explain everything by implementing with a simple example, right? So we'll see all the 4 conditional statements: simple if else, else if ladder, nested if. With a simple example, I'll execute for each and every conditional statement, right? So let's move on to the computer so that I'll execute everything on the RStudio, right? Let's move on.
Hello friends. So just now we have seen the syntax of conditional statements, simple if and if else. Now we'll see the implementation part. So let me open the RStudio, and here we'll see a simple example which you can understand the working of simple if and if else statements. So before that I'll clear everything. Now let us write here first. Let us take an example for a simple if. So let us take one variable. So n is equal to as dot integer, and directly we are converting it into integer, and we are applying the readline function. So enter value of n. So we'll check whether the given value is either positive or a negative, right? So you can see we can write down if and followed by the condition. Here we need to write the condition. So if n greater than 0. So if n greater than 0, n greater than 0 is a condition which gives the boolean result either true or false. If the condition becomes true, then the true block will be get executed. So here what we have to print, so cat, which is an output function, so n is positive number, right? Here just I am giving only if condition, right? So we are not writing any else condition, so else will be the false block. And this is an example for simple if, so we need not write the else part, that means a false statements. So only we can write only the true block. We can ignore the else block, right? So simply we can execute this one. So it will prompt for n. If we give some value which is greater than 0, so we'll get the result as a 10 is a positive number. You can observe here. And if again just execute, if you give the n value as a -1, so nothing happens, because we are not giving the instructions what to be get executed if the condition becomes false, because this is a simple if condition. Okay, simple if condition. So here we are supposed to give only the true block statements. That means the statements or instructions which are being executed only if the condition becomes true, right? So this is a simple example for if else. Now we'll see one more thing, else also. That means we have to pass the instructions which are being executed if the condition becomes false. Now we have seen the condition becomes true, and if the condition becomes false, we have to write everything in else part, right? So remember, else should be written immediately after closing of the if condition block, right? Now, so here again I'll write here n is negative number, right? So let us execute here. N, I'll give -10, so we get -10 is a negative number. -10 is a negative number, right? See, one thing you have to remember, so else should be written immediately after the if closing braces. So if you go here, so you'll get an error. See, error in source, unexpected else, right? So we have to write the else immediately in the same line after the closing brace of if condition, right? So this is an example of if else, right? Now else if ladder. So here we are checking only for positive or negative. Then what about if you give the input as 0? If you give the input as 0, what happens? So if you execute the same thing and if you give the input as 0, we'll get it's a negative number, but it's a false, right? So here in this case we need to check one more condition, right? One more condition. So where we have to write down this particular condition. So inside the else, start again if. So one thing you have to remember, as I have said in the class, so the condition should be written only in the true block, not in the else block. So here we need to check 3 conditions. Okay, one is given number is greater than 0, given number is less than 0, given number is equal to 0. So we need to check 3 conditions, right? So if the given number is a greater than 0, we'll get the result as positive number. Again, if it is false, we have to check 2 more conditions. That is whether n is less than 0 or n is equal to 0. If n is less than 0, again we have to get a negative number. So here we need to check one more condition. So obviously we cannot write the condition at the else. So once again, just use a if statement and write down the condition n less than 0. And if both the conditions are false, simply you can give a else block. So else is also should be written at the end of the braces, right? So again you can write cat n is 0. Okay, so you can execute here, execute n value. If I give 0, you will get a 0, right? So given number is 0, right? Now you can observe. So execute. If I give the input as 0, we'll get a given number is 0. And if you give any other output, for example positive value 10, we'll get the result as a positive number. And if you give -20, and the result will be -20 is negative number. So here one thing we have to remember. So in the else block we should not give any condition, and if you want to check one more condition in the else, we have to include if and we have to write down. So in this way we can give a multiple conditions. We can check a multiple conditions in a single program. So even though we are giving multiple conditions, only one block will be giving one block will be getting executed. So here we have written 3 blocks, 1, 2 and 3. So even though we are writing 3 blocks, only one block will be get executed. So if I am giving the input as -20, see -20, automatically this second block will be get executed. second block will be get executed, right? So you can give a number of blocks. You can also write a number of conditions. Okay, 100 conditions we can write, but at a time only one condition or one block will only be get executed, right? All the remaining blocks will be ignored. So this is an example, simple example for else if ladder, right? Then next one is a nested if. That means inside the if we can also use one more if statement. So for that we'll take the example of largest among three numbers. So first of all, let us take three values. So let us take a. Largest among three numbers is an example for nested if. We'll take it as a nested if. So I'm taking three values a, b and c. So the first three lines takes the input from the keyboard during the runtime. So we are having some a, b, c values. So we need to check first if a greater than b, right? So whenever the condition becomes true, we can't say that a is largest or b is largest. Okay, and else. So this is the control enters into this else only if a is less than b. Okay, only if a is less than b. So here if a is greater than b, once again we need to check whether a is greater than c, then only we can say that a is bigger than b and c. So again we can write here if statement a greater than c. Okay, so you can observe inside the if statement again, once again we are checking the condition a greater than c. So again here we'll be having a two. So for true and false. So if a greater than b, okay, a greater than b, obviously a can be larger or c can be larger. If a is greater than c, a will be largest element, or a less than c, it will be c will be the largest element. Okay, so here we can write it as, so whenever a greater than b true, then this true block will be get executed. So in this true block again we are checking a greater than c. If a is also greater than c, we can say a is larger. A is larger. And if a is not greater than c, we can say that, so a is greater than b but not greater than c. So that means c will be the larger. C is larger. Okay, and if the first condition itself false, that means if a is greater than b is false, obviously it will be a is less than b. That means b greater than a, right? So again we can check b greater than c. If b is greater than c, obviously we can say b is larger. And else, that means if b is greater than a but not greater than c, we can say that c is larger. So the simple code we can have as an example for nested if. So inside if we are writing, so first we are checking whether a is greater than b and the possibility of this condition is true or false. If it is true, then we can say that a is larger than b. And if it is false, we can say that b is larger than a. So if the condition becomes true, so this will be get executed. If condition becomes false, this will be getting executed. So if a is greater than b, it is true. Again we have to check whether a is greater than also c also. Then only we can say that a is larger. So if it is false, again c will be larger. Similarly here also. Now we can execute with all the three cases and we can check. Let us take some 10, 20, 30 and we can say 30 is larger. Yes, correct. And again let us take 10, 30, 20, sorry, yeah, I am giving the values 10, 30, 20. Again 30 is larger. Once again let us take 30, 20, 10. Again 30 is larger, right? So we have taken the three cases. One in the first case we have given the third element as the largest element. we are getting the C as largest, and in the second case we are giving B as the largest element, still we are getting the correct result, and the third case we are giving the first element as the largest element, still we are getting the correct result, right? So this is how we can implement nested if, right? So in today's session we have seen all the conditional statements. So a simple if else if ladder, and nested if, right? So hope you understood, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.
So this is another control flow or another control structure. So in our previous sessions we have discussed about the conditional statements, right, where the instructions will be executed based upon the result of a condition. And here same set of instructions will be executed multiple times. Right? So for example, just a string called ABC, if the same instruction was being executed multiple times, so I'll give a print function, print ABC. So if this is executed some 4 times, so that we call it as an iterative statement. So how we can execute the same thing multiple times? So we need not write the same thing multiple times. We have to write only once, and the same instruction will be get executed multiple times. And for that we are going to use one iterative statement called for loop. We call it as a loops. So the first one is a for loop. So here the question is where to stop the iterations. So every time the set of instructions are being executed is called an iteration, right? So I'll write here iteration. Iteration means every time the instructions are being executed. Instructions are being executed. So for example, if one instruction is being executed 4 times, we call it as a 4 iterations. Okay, if the same instruction is being executed for 10 times, we should call it as a 10 iterations, right? So here the question is where to stop these iterations. So if you are not able to stop these iterations, what happens? It will lead to the infinite loop. So multiple times it will be keep on executing the same set of instructions infinite times. So we should be very careful while writing these iterative statements, because after some finite number of iterations, so the loop should be terminated. The control should exit its termination, right? So one such iterative statement we call it as a for loop. For loop, right? For loop. So here the for loop can be implemented in 2 different ways. So one is by using a sequence, and another one by using the data structures like a list or matrix or a vector, right? So we can use any one of these 3 data structures, or directly we can use the sequence. Now I will show you the syntax of this for loop in R programming here, and let us move on to the RStudio, and I will implement a small program demonstrating all these cases by using a sequence, list, matrix and vector. So here the for loop will take multiple parameters. So the syntax for loop. So use a keyword called for keyword. So keyword means a reserved word. For open parenthesis, give the value give the value, use an operator called in, membership operator. In, you can give here the sequence, and here we need to write the statements. So this is a one syntax, one way of implementing the for loop, right? So here the sequence can be written as a sequence of 1 to 10, for example, okay, 1 to 10, okay, sequence of 1 to 10, sorry, comma. So this implies, let us take a small value, let us take 1 to 5. So this value will be repeated, okay, I mean the value, if the value is available in this sequence, then only the statement will be get executed. That means the sequence 1 to 5 means 1, 2, 3, 4 and 5. So from the first element onwards, from the last element, so here we are having some 5, so there will be a 5 possible iterations. Okay, there will be a 5 possible iterations if the value is available in this sequence. If the value is not available in this sequence, the control will never enter into the loop. Okay, the control will never enter into the loop. Only if the value is available in this sequence. Here sequence is 1 to 5, so 1, 2, 3, 4 and 5. Okay, so this is how we can implement the for loop by using this sequence. Another way of implementation is by using a list or vector or a matrix. So instead of writing here the sequence, we can write here the list or a vector or a matrix. So obviously it will be starting with the starting element and it will end with the last element, right? So in such a way the for loop will be get executed. So in other programming languages we are going to use a syntax like for example in C for initialization, condition, updation. So like that we have to use a for loop, but here we are using the membership operator, we are using some value or expression, and it will search whether this value is available in this particular sequence or the data structure, and if it is, then the following statements will be getting executed. So if this becomes false, automatically the condition, I mean the control will never enter into the loop. So automatically it will skip from the loop. So at finite number of steps, obviously the value should be false. I mean this particular section will becomes a false, right? So if it doesn't becomes false, automatically the loop will be infinite. The same set of statements will be repeated infinitely, right? So these are the syntax for implementing the for loop using a sequence or these data structures. And now let us move on to the RStudio, and I'll demonstrate each and every case. So implementing sequence, implementing with a vector, implementing with a list, implementing with a matrix. So let's move on to the system.
Hello friends. So just now we have seen the syntax of for loop. So implementing using sequence and the data structures. Now we'll see the direct implementation of all those cases. So how we can implement the for loop using a sequence and list or vector or matrix. So let us take here, I'll clear all the remaining, I mean previous output inputs and outputs. So now let us take one variable. So a is equal to, I'll take okay, let us give directly the for loop for. So let us take one variable or a value, so I in, and let us take the sequence. So sequence from 1 to 10, and here I just want to print I value, right? So we are just giving I value in this sequence. So I will be, and this statement will be executed until I value is in this particular sequence. Okay, so first the sequence 1 is to 10 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So until the I becomes 11, so it will be keep on true. So that's why this statement will be get executed. So once let us execute, see, you can observe, let us give small values, and now you can see 1, 2, 3, 4 and 5. And if you give this one as a star and execute. So you'll be getting, see, 5 stars, 5 different stars. So this is just using a sequence, okay, just by sequence, right? So here in the sequence we are having a third parameter, that is a difference. So let us take some 10 and by is equal to 2. So that means it will take a difference of 2. So let us print I value here. Let us print I value here. So you'll get 1, 3, 5, 7, 9. So you can observe the difference between one number and another number will be 2. So the third parameter will give the difference over the updation, right? The first number, it will start with 1. So I value 1 in the first one, and it will be printed within the range, right? So here the 10 is a stop one, right? So that will be treated as a termination. So whenever I becomes 10, it will be terminated. Okay. So similarly here also you can use any other updations. If I want to update with 3, so you can observe the difference over the numbers will be 3. So 1 and with a difference of 3, 4, 4 with a difference of 3, 7 with a difference of 3, 10. So it will stop at 7, 10 because we are giving the stop as a 10, right? So first the sequence of values will be taken, and until the sequence of values, this particular statement will be get executed, right? So this is an example for a sequence. Now let us check with the list. A vector. First let us take a vector. Some b is equal to, so vector can be initialized as a c of, I'll take 10, 20, 30, 40, 50, and here I can give it as a v, right? I in v. So I will be starting with the value 10 and it will terminate at whenever I becomes a 50. So you can observe, so all the elements will be get printed. So I will be 10 in the first iteration, in the second iteration I will be 20, in the third iteration I will be 30, in the fourth iteration it will be 40, and the fifth iteration it will be 50. So whenever I reaches to the last element of the vector, immediately the control will come out from the loop. So until it will repeat. So for example, if you want to print any other, so star, so how many elements are there? So total 5 elements are there, so 5 iterations will be repeated. You can observe 5 stars will be here, 5 repetitions will be there, okay. And also you can give any other versions, okay, any other expressions, I into 2. So if you observe I into 2, 10 into 2, 20 into 2, 30 into 2, 40 into 2, and 50 into 2. So like that we can give any other expressions, right? So but until the I value reaches to the last element of the vector, this particular instruction will be keep on executing. Okay, now see, this next one is a list. If I take it as a list, we know that L is equal to list function, list of. So let us take all the different data types. We can take a different data types. So I'll take it as a ABC, and I will also take some 90.5 float value, okay. And let us check I in L, and here you can see print I. Obviously the complete elements will be get printed. So 10, A, B, C, and 90.5, everything will be get printed. So here also similar to a vector, it will start with the starting element, okay, and it will end with the last element, right? Directly it will iterate. So here 3 elements are there, so this statement will be repeated 3 times. So if you don't want to use these type of data structures, simply you can use a range that is called a sequence. So how many iterations? So the same set of statements should be iterated for 5 times or 10 times. So give here 10. So 1 to 10, right? And here give the value like Sundeep, right? So execute. So 10 times the instructions will be being executed. 10 times. Okay. So the next one is a matrix. So we have seen the vector, list, sequence, and now we'll see the matrix. So we know that matrix can be created with the help of a matrix command and the matrix function. So the first parameter will be the vector of values. I'll take some 4 values, 10, 20, 30, and 40. and after that we need to give a number of rows and number of columns. N rows is equal to 2, n columns is equal to 2, right? And instead of here sequence, list or vector, we can simply pass m is nothing but a matrix. M is nothing but a matrix. See, yeah, sorry, and yeah, n row and n column. Yes, so you got the same 10, 20, 30, 40. Okay, so n row, n column. So we are giving 2 rows and 2 columns, and here we are giving some 4 different values, and in all the cases we are printing some I, or else you can print some any other character so that it will be get printed. So 4 times a star will be printed. So like that we can implement the for loop by using a sequence or a list or a vector or a matrix. So the variable I will be pointing towards the first element in the first iteration, and it will be keep on moving towards the next elements until it reaches to the last element. Okay, so if you don't want to involve these elements, so you can use a different sequences. You can use a sequence, and mainly when we are going to use the for loop means if you know how many iterations you need to implement, so then we'll move on to this for loop. For example, if my logic requires some 10 iterations, definitely I'll go with the for loop. So simply I'll give I in sequence of 1 to 10, right? So if my logic requires only 5 iterations, so I'll give 1 to 5. If my logic requires the elements directly, I'll give the vector or list or matrix, right? So hope you understood a simple for loop. So this is a one of the control structure similar to our conditional statement. So this we call it as a iterative statements. So iterative statements means, so as we discussed just now, same set of statements are being executed multiple times, and at some finite number of iterations the loop should be terminated. Okay, so if the loop doesn't terminates after finite number of iterations, it may lead to infinite loop. Okay, so hope you understood everything. So
usually we can call it as a switch case or a switch function, right? So this can be represented as switch function, right? And here, and this is also called as a multi-way selection statement. It is a multi-way selection statement. So based upon the input given to the switch function, the corresponding case will be get executed. So here the syntax to implement the switch case is, so switch, which is a keyword, and open the parenthesis, and here we need to write the expression or a value, comma, and give the cases here, right? So we can call it as a value 1, value 2, and so on. So this is a normal syntax to implement the switch case. So this is the input, and based upon this input, the corresponding value will be returned, right? So this is a input for switch. Input for switch. So corresponding value will be returned. So here, for example, let us take some x is equal to switch of, give the value, I'll give directly a value like 1, comma, I'll give here 10, 20, 30. So the first parameter in the switch, always will be the input. So this is the input, so which is 1. So among the remaining list of elements, the first element will be returned. Okay, so switch will return the corresponding element of the value. So this we call it as a list of elements. Right? So based upon the input, the corresponding element from the list will be returned. So here 1, so the x will be having a value 10. So this is the first value. This is not an index, right? This is not an index. So the positional order, so whatever the element which is available in the first position will be returned. For example, if it is 2, obviously the second position element, what is the second element position? 20. So 20 will be in x. And if it is 3, the third element 30 will be available in x. So what happens if the input is out of range? So if given input is out of range. So what means out of range? For example, here I have given some 4. So that means it will return, this switch function will return the 4th element. So but we are having only 3 elements. In such case, switch will return null. Switch will return null. So if the given input is out of range, immediately the switch function will return a null. Okay, so this is a one way to implement the switch. That means directly giving the expression or a value based upon this one, and the corresponding value will be returned. And the second way of implementation is string expression, with a string expression. So we can match the given value with the multiple cases. So I'll tell you the second example, the second syntax. See, second syntax, switch, and here we can write expression or a value, and from the second parameter we need to use the matches, string expressions, right? So we can write it case, no, we'll write name 1 is equal to value 1 comma name 2 value 2, okay, and so on. So this will be the second syntax. That means this name, instead of name I will write it as result 1, okay, and here I will write result 2. What about this result 1 and result 2 means that those are the inputs of this particular expression or a value. This particular expression or a value, based upon the value result, that will be matched with this one. So if the expression matches with result 1, the corresponding value 1 will be get executed. Okay, and what happens if it doesn't matches? That means in the previously we have tell that expression or a value is given out of range, then it will return null. But here, if the expression or value doesn't matches with any one of the cases, then what happens? So then automatically unnamed case will be get executed. Unnamed case. So in the last we can give an unnamed case, and that will be executed, and that value should not match with any other string expressions. It should not assign to any other string expression. So a little bit confusion. Let me explain with an example, and after that we'll move on to the RStudio and I'll execute each and every case in these two cases. For example, our problem is to perform the perform the arithmetic operations, right? So here I need to take some two operators A and B, two operands, that means input variables, two inputs, and the third input is an operator OP. So here we can give either plus or minus or star or division. So based upon plus, the addition should be performed. Based upon minus, if the input is minus subtraction should be done, and if the input is a multiplication star, it should perform the multiplication, and so on. So for that we can write here as switch, and what is the first one? First parameter will be the input. So OP is the input. If OP, and if OP matches with the plus, so which is a character, so I should enclose it with the quotations, is equal to, okay, is equal to, if the OP matches with this plus, what happens? We have to perform the addition, right? So I'll write here a result is equal to switch off OP, and here I can write it as A plus B. A plus B. And if it is a minus, and one thing observe, these are all the different parameters, so I am giving comma. Here we have opened the parenthesis, and for just easy understanding I am writing in a new line. Okay, so if it is minus, it should be A minus B, and if it is a star, it should be A star B, and if it is division, it should be A divided by B. And let us close here. So these are all the 5 parameters, and if OP is a plus, this case will be match, and A plus B will be performed, and that will be returned to result. And if minus is given, this case will be matching, so A minus B will be calculated, and the result will be sent to RES. So similarly here. So what happens if the OP is given as some dollar symbol? That means which doesn't matches with any one of these operators. Okay, any one of these cases. OP doesn't matches with any one of these cases. So in such a way, in that case, we need to give an unmatched case. Okay, unmatched case which should not be assigned to any other string expression. Okay, it should not be assigned to any other string expression. So I'll write here some print invalid operator, or simply we can write it as, so already we are assigning to result, so here we can write in double quotations invalid operator. So you can observe the last parameter we are not assigning this one to any one of the variable. That implies this is the unnamed case. So this will be the unnamed case. So whenever there is no match, then only the unnamed case will be executed. Then only the unnamed case will be executed. Right? Now if you go with the dollar, automatically this invalid operator will comes into this result. Okay, if you give plus, the addition will be done, and the final value will be assigned to result. So this is how the matching will be done in the switch case. So whatever the case we are executing without match or with match, so everything should be written as a parameter to the switch function. So we are passing parameters to the switch function, and first parameter will be the expression or the value, and the rest of the things will be the cases. Right? So hope you understood the syntax of switch function or a switch case in R programming. Now we'll move on to the RStudio, and I'll show you the implementation of both the cases. So what happens if we are not giving any matches, that means this assignment operator string expressions, and what happens if we give the same string expression. Okay, and also this unnamed case, when the unnamed case will be executed, and what happens if the input expression or value is given out of range. Right? So every case I'll explain you by executing a small programs. So let's move on to the system.
Hello friends. So just now we have seen the complete syntax of switch case in R programming. So here the matching will be done if you are giving any options, or else it will take the positional order. Right? So let us start the implementing switch case. We'll open the RStudio, and then we'll write some small syntax and a small program. So switch case will take a multiple parameters. The first parameter will be the option, and the remaining parameters will be the cases. That means what actually should be done. Right? See, I'll tell you here some result is equal to switch off, and this switch can be implemented in 2 ways. As I said, that the first one, you can give an option which is a normal value as a positional value. So let us give 2 comma, and the second line, second parameter onwards, we can give the cases. So what should be executed? For example, I'll give I'll write a branches CSE, ECE, EEE, civil mechanical, right? So here I have given, and if you print a result, so here we are not giving any assignment, right? So there will be no match. We are not matching any cases. So the first parameter is 2. So in the positional order, what is the second value? So ECE, so that will be automatically copied to result and that will be printed. So let us check here. See, you can observe here, print result. So we'll get ECE as a result. Okay, so if you are not giving any matches, so if you want to give a match, then we have to use an assignment operators. So in that also, everything should be passed as a parameters to the switch function. For example, let us consider, so this is one thing, this is a one thing. Okay, if there is no match, it will obviously the first parameter will be considered as a positional order, and here the positional order will be starting from one only. So one, I will explain. One, if we give 1, it will return CSC. If we give 3, it will return triple E. So what happens if we give some excess value 7, where 7 is not here? See, then null. Hope you understood. So the first one will be taking as a positional order, and in the particular position, whatever the value is there, that value will be returned. Okay, so the positional order, it will start with the 1 because 0th element is a position, right? So this will be starting from 1 onwards. Now if we implement the switch case with a assignment, assignment matches, right? So let us take some simple calculator: addition, subtraction, multiplication, division, four arithmetic operations we'll see, right? So first we need to read 2 variables, values for 2 variables, and the third input is nothing but an operator which we have to give, and based upon the given operator, the particular operation should be executed. So that is our problem. First, let us read 2 variables. A is equal to as dot integer of read line, enter value of A, right? And the same thing we can write for B. So the 2 variables we are reading, 2 are integer variables, right? Because we are giving as dot integer, so that means it is an integer variable. Now we have to take the third one, that is a operator. Operator is equal to, this should be a character. So we want to print, we want to give the input as a symbol. Okay, plus symbol for addition, minus symbol for subtraction, star symbol for multiplication, and by symbol for division. So operator is equal to, we can go with the read line because by default the read line function will return the character data type. So read line, enter operator for enter arithmetic operator, right? Arithmetic operator. Now, so what we have to do? So we need to pass this operator, right? So we can simply go with here switch. The first parameter will be the option operator. Okay, operator, and if that operator matches with, see, cases, the next one is a cases. So the first case, if it matches with the plus, is a character, so I have enclosed in a quotations. Plus is equal to, so here we need to give the is equal to which matches, and here I will go with a cat sum is, I'll go with A plus B, and comma the second case. So here all the cases will be acting as a parameters to the switch function. So parameters should be differentiated with a comma. So first parameter and the second parameter minus is equal to cat difference is A minus B, comma the third case is a multiplication operator is equal to cat product is A star B, and the fourth one division is equal to cat division is, and here we can give A by B, right? Difference. Now you can observe, let us execute the program. So there is a small problem. So yes, spelling mistake, read line. Yes, now we can execute. We have to give values for A and B. I'll give some 10 and 20, and here we need to give the operator. If I give the operator as a star, that should be matched with this third case, right? So A star B should be printed. 10 into 2, obviously it will be 200. Right? Similarly, if you give the values some 10, if you give the values as 10, 20, and if you give here plus positive, addition, plus symbol is for addition, so we'll get the result as 30. So what happens if you give the operator which is not available in the cases? That means if the input doesn't matches with any one of the cases. So here we are writing only 4 cases: plus, minus, into, and division. And if the operator value doesn't matches with any other cases, for example, A is equal to 10 and B is equal to 20, and I'll give here cat symbol, see, nothing will be displayed here. Okay, so for that purpose we can give it as an unnamed case. Okay, unnamed case. If the input doesn't matches with any one of the case, then immediately the unnamed case will be get executed. So the last parameter can be unnamed case. It will be considered as a unnamed case, right? So here you can write invalid operator, right? So I'm not matching anything else, right? So here this particular last parameter I am not matching with any other operators or any other symbol. So that will be considered as a unnamed case, right? So if the operator doesn't matches with any one of these 4, immediately this unnamed match will be executed. For example, let us take source. Yes, 10 and 20, and if I give any other operator other than plus, minus, star, and division, so that will be executed. Invalid operator. You can observe here, invalid operator. So in this way we can implement the switch case, okay, with 2 different ways. One is by using the match. Okay, the first parameter will be the input, and that will be compared with the different cases, and here all the cases should be passed as a parameters to the switch function. Okay, then the another way is, if you are not giving any case matches, immediately the order will be taken as a consideration. Okay, so whatever the value given in the first parameter, that positional order will be executed. That positional parameter will be get executed, right? So hope you understood this switch case. So everything will be in a single switch function. Okay, so hope you understood this one. Let us stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.
So in our previous session, we have discussed about the for loop, right? So now we will see the while loop. So whatever the loop it is, while or for loop, so the same set of instructions are being executed multiple times is called the loop or iterative statements. So every time the set of instructions are being executed is called as an iteration. So all these things we have discussed in our previous session. So if the instructions are executed 5 times, we call it as a 5 iterations. Right? So here the question is, after finite number of instructions, after finite number of iterations, the loop should be terminated. That means the control will come out from the loop. And if that doesn't happen, the complete process may lead to infinite loop. That means always the same set of instructions will be executed repeatedly. So for the implementation of this while loop or for loop, the three things should be focused. The first one, loop variable initialization. Loop variable initialization. So we need to initialize a loop variable, okay, to perform in the iterations. So that means assigning an initial value to the variable. And then we need to focus on condition. So we should write the condition very carefully, because this condition is mainly used to terminate the loop, okay, to stop the iterations. So if the condition is not written properly, the instructions will be keep on executed. That means it may lead to the infinite loop. So the instructions will be get executed until this condition becomes false. And the third one, updation. So the third one is updation of loop variable. Updation of loop variable. So after every iteration, this loop variable should be updated. It may be incremented or decremented, but that updation should be done. Okay, so for both the iterative statements, for loop or while loop, we have to follow the same thing. And this is also called as entry controlled loop. Entry controlled loop. Because before entering into the body, before the control goes to the instructions of the while loop, the condition will be verified. And if the condition is true, then only the control will enter into the loop. So at the beginning itself, we are checking the condition. So that's why we call it as an entry control loop. So the syntax for a while loop is, we have to use a keyword called while and followed by the condition, and we need to write a condition, and this condition can be a simple condition or a compound condition. So if it is a simple condition, we are going to use the relational operators, and if it is a compound condition, we are going to use some logical operators, right? And curly braces, and here you need to write the statements. You need to write the statements, and here we need to give the initialization. Initialization. So if you write this initialization inside the while loop, so for every iteration the value will be initialized to same initial value, right? So initialization should be done above the while loop. So before control entering into the while loop, and after that we have to write down the while condition and statements, and after that we need to write the updation. So this is the syntax of while loop, and the first step is this one, and second step is a condition, and the third step statements, and the fourth step updation, and the fifth step is condition. Again it will check the condition. Okay, after completion of this closed brace, it will again check the condition, and if the condition is true, again the sixth one will be statements were being executed, and after that 7, and again 8 will be the condition. So this will be repeated until this condition becomes false. So the control will enter into this particular loop only when the condition becomes true, and when the condition becomes false, the control will never into this loop. So this is called a while loop, and this is one of the control structure which we call it as a iterative statements. So every time the statements are being executed is called as an iteration. So one time the statements are being executed is called iteration. So if these statements are executed 5 times, we call it as a 5 iterations. So that we have already discussed in our previous session. That means the explanation of for loop, right? So hope you understood this while loop, and now let us move on to the system. I'll show the demonstration of this particular while loop in RStudio. So let's move on to the system.
Hello friends, so just now we have seen the complete syntax of a while loop. Now we'll see the implementation part. So let us open the RStudio, and then we'll remove the complete existing data, and then we'll start. So let us take the initialization of a loop variable. I'll take the loop variable as I and I'll initialize to 0. And now I'll write the while, and now I have to write the condition. We'll write the condition as I less than 5. That means whenever I becomes less than 5, then immediately the control will enter into the loop. So whenever this condition becomes false, then that means whenever I becomes, the value of I becomes greater than 5, immediately the control will exit from the loop, right? So here I am giving the body of the loop, so I'll give print I, and I need to update the variable. Every time I need to update the variable, because if you are not updating the variable, it may lead to the continuous execution, that means infinite loop, because I value will be 0 initially. So 0 less than 5, it is a true, so this statement will be executed. And if you are not updating the loop variable automatically for every time 0 is less than 5, that means every time the condition becomes true only, then it may lead to the infinite loop, right? There is no termination. So here I need to update the variable. So I am updating the variable with 1. So after one iteration I becomes 1, after second iteration I becomes 2, after third iteration I becomes 3. So every time we are checking the condition with the change updated variable. So at one particular time the I value will be automatically greater than or equal to 5. So at that position, so the loop will be terminated, right? So this is a simple code to display the complete details. So let us execute. Source, you can see it will start from 0 to 4. If you go with a less than or equal to 5, and if you go with a 1, so it will display the complete details from 1 to 5. And let us take if it is 10 or if it is a 5, and if it is greater than or equal to 0, right? And here we need to decrease the value, so you can observe the complete details will be repeated. I mean, from first iteration 5 will be printed, in the second iteration 5 will be updated to 4, and the 4 will be checked with the condition, and it will be repeatedly, it will be executed. So here instead of taking this one, we can read one value here. Okay, I'll take n is equal to as dot integer of read line, enter value of n, right? And here we need to take a loop variable as a 0, and let us take some I greater than or equal to I less than or equal to n, right? And here you can simply go with this one, so that we can prompt, we need to update it. So execute. So we have to enter the value of n. If I give it as a 10, we'll get the complete values from 0 to 10, because here we have started with a 0. So go with a 1. So simply you can go with the 20. If you go with the 20, it will display all the values from 1 to 20. And if you go with the 100, it will display the complete elements from 1 to 100. What happens if you are unable to write the updation? So we said that it may lead to infinite loop, right? So let us take some 4, and you can see, so it was keep on printing 1, because we are not updating the I value. Always I value will be 1, and always n value will be 4, right? So I less than or equal to n, that means a 4, right? So simply what happens here, so it will be keep on moving, so there is no updation of the loop variable. So you can observe here, right? So this happens. So if you want to stop this infinite loop, just press escape, so that it will be stopped. Again we'll get the console. Now you can observe, so I is equal to I plus 1, and once again you can execute the value. So let us give some 10, and we'll get the values from 1 to 10. So if you don't know how many iterations we required in the logic, in such cases we are going to use this while loop. Okay, if you know the number of iterations we required for the logic, we can simply go with the for loop. If we doesn't know how many iterations it will take for our logic, then we'll go with this while loop. right? So hope you understood the implementation of while loop in R programming.
Break and next. So these are similar to break and continue statements in other programming languages. So in our other programming languages, break and continue, the unconditional jump statements, right? So the same working of break and continue is equal to break on next of in R programming. So don't worry if you are not aware about any other programming language, I'll explain you once again, right? So starting with the break. So break is a keyword and it is all in a lowercase characters. So we have seen the iterative statements for loop and while loop, and in any one of the loop that repeated iterations will be terminated only when the condition becomes false. So until the condition becomes false, the same set of statements will be keep on executing. So irrespective of the condition, if we want to terminate from the loop, then we can use the statement called break. So if you use a break, whenever the control executes this break, immediately the iterations will be terminated, even though the condition is true, right? So this break statement is used to terminate the loop. And another important point is irrespective of condition. Irrespective of condition. And one more important thing is these two statements, break and the next statements, are only used in iterative statements, right? So used in iterative statements. So iterative statements means for, while, as well as repeat. So don't worry about this repeat. So once we get finished about this break and next, in our next video I'll explain you about the repeat, right? So this is to terminate the loop irrespective of condition. So even though the condition becomes true, still we can break the loop. That means the control, we can get back the control from the loop itself. For example, let us take some for I in, let us take some sequence of 1 to 10. So here 1 to 10 means sequence of, see I'll write here print I. Okay, so what is the output of this one? So sequence of 1 to 10 means, so 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So it will print every number within this particular sequence. Now if you write some condition here, if I is equal to 5, simply you can write it here break. Okay, and here you can write it print I. What happens whenever first I is equal to 1, so I will be in this particular sequence. So 1 is equal to 5 false, so 1 will be printed. Similarly 2 will be printed, 3 will be printed, 4 will be printed. Whenever I becomes 5, so whenever I becomes 5, so 5 is equal to 5, that is true. So if this condition is true, this block will be get executed. So immediately the control enters into this conditional statement and break. Immediately the loop will come out from this loop. So the next statements will not be get executed. So the output will be only 1, 2, 3, 4. And see, here I is equal to 5. That means when this loop will be terminated, whenever I becomes 10, I mean beyond the 10, right? So because we are checking the condition, we are updating the loop variable I from 1 to 10. Whenever I becomes more than 10, then only the condition will be false. So then only the statement will be terminated. Okay, these iterations will be terminated. But still here, when I is equal to 5. So when I is equal to 5, sorry, I is equal to 5. So 5 is within this range. The condition is true. Still, we are using this break. Immediately the control will come out from the loop. So this is the working of break statement. Not only the for loop, you can also use this break in while loop or repeat statements. Okay, and one more, second, used in iterative statements only. So you will be having some doubt. Here we have written some condition. So why we are writing this break? So even though we are writing the condition, this break is implemented in this loop itself. So without the loop, only in the conditional statements we can't use these break and next statements. Okay, so even though we are writing the condition and we are writing the break, so these statements belongs to this particular loop. So this break statement is one of the statement in iterative statements. Okay, so that's why we have written that we have to use the break and next statements in only the iterative statements for while and repeat. So hope you understood. So this is a syntax. Just a syntax is a break keyword. Just writing the break keyword. So no other parameters or no other syntax, right? Simply just mentioning the break statement. So this is about our break. Don't worry, I'll execute the same thing. I'll demonstrate the same thing in the RStudio. So here we are checking about the syntax and a small example. Next we'll move on to the RStudio and I'll explain you everything. Okay. See, the next one is a next. Next is also a keyword which is in a lowercase characters, and there is a slight difference between next and a break. So break means it is used to terminate the loop irrespective of condition. But here the next is it is used to skip the current iteration. It is used to skip the current iteration and continue with next iteration. So in which iteration we have executed this next statement, that statement, that iteration will be ignored and automatically the control will move with the next iteration. So here you can see, and the second statement is common because similar to our break, continue, this next is also used in iterative statements only. So the next statement is also common, and here you can see whenever the control executes this next statement, whatever the instructions written after the next will be skipped, will be ignored. For example, let us take the same example. Instead of break, we'll write it here. Next, right? See, similarly, first I will be 1 in the first iteration. So 1 is within this range. So it is true. Now the control will come here. 1 is equal to 5, false. So the control will never enter into this particular condition. So print I, 1 will be printed. Next, in the next iteration, I becomes 2. 2 is also within the range. 2 is not equal to 5. So print I, 2. And next iteration, 3. 3 is also within the range. 3 not equal to 5. So the control will enter into this particular if condition only if I becomes 5, right? So I is 3 now. So 3 not equal to 5. So automatically 3 will be printed. Next, I is 4. 4 is also in the same sequence. So 4 is also not equal to 5. Print I, so 4. And next iteration it's a 5. So 5 is also within the sequence, true. So 5 is equal to 5, true. So then the control will enter into this loop, this condition, and we are executing the next. Immediately, whatever the statements written after this next will be skipped and it will continue with the next iteration. So print I will not be get executed. So because we are writing here next, so immediately it will move with the next iteration. So next iteration I becomes 6. Okay, in the next iteration I becomes 6. So 6 in sequence, yes. So 6 not equal to 5, true. False. So print I, so 6 will be printed, 7, 8, 9 and 10. So whenever I is equal to 5, automatically this next is executed. Whenever the next is executed, immediately whatever the instructions written after the next statement will be ignored. So immediately it will move with the next iteration. So that's what we have written here. So this next statement is used to skip the current iteration and continue with the next iteration. So it will continue with the next iteration until the condition becomes false. Right? So both the break and next statements will be used to terminate. One is used to terminate the loop and one is used to skip the current iteration. Right? So if our iterations may lead to infinite loop, so that can be controlled by using this break statement. So the infinite loop can be terminated with the help of break statement, right? So here also there is no syntax for next. We have to write the keyword called next. So here break and next are the keywords which are of lowercase characters, and we are just using the words break and next in the programming. And this is the most thing I am once again repeating. These two statements should be used in iterative statements. So even though here we are writing inside the condition and the complete condition is written inside the iterative statements. So we have to write these break and next statements in the iterative statements to control the loop. Right? So hope you understood this simple syntax and a simple problem, simple example. So now we'll move on to the system and I will demonstrate these break and next statements in the RStudio. So let's move on to the computer.
Hello friends. So just now we have seen the syntax of break and next statements, and these two statements are to be used in only the iterative statements. So now I will demonstrate the same thing in the RStudio. So let us take a small example and I will demonstrate both the break and next statements here. So here let us remove all the previous inputs and outputs, and now here we'll see. And here we'll take one range. Okay, so I'll take n is equal to, I'll take some range 1 is to 10, and we'll write one variable for I in n. Okay, and take the loop variable initialization I to 0 and I in n, and here just will print this I. Okay, now let us execute. So we got the values from 1 to 10. Okay, we got the values from 1 to 10. So whenever the I becomes a 10, immediately the loop will be terminated. So that we know, because here n holds the values from 1 to 10. You can observe here. So in this window you can observe n holds the values from 1 to 10 and I becomes 0 in the first iteration. So yeah, we can. So we need not use this one. So I in n, so we can simply iterate I value till in that particular sequence, and we can print here I, right? So we see here I am writing the condition. So if I is equal to 5, and I am just writing here as a break. Okay, so what happens here? So even though the condition becomes true, whenever this condition becomes true, immediately the break statement will be get executed, and you can see 1 2 3 4. So whenever I becomes 5, immediately the control will exits, because whenever I becomes 5 and this statement, this condition will becomes true, and the control enter into this particular block and it will be get executed. So if the block contains only a single statement, we did not use these curly braces. Okay, so it's not mandatory to use a curly braces. So if the block consists of more than one statement, then we have to use the curly braces, or simply in order to avoid the confusion, you can also use the curly braces, no problem. Okay, so here this particular loop will be terminated whenever I will be beyond the 10. Okay, and in this case we are terminating this loop execution of these instructions whenever I becomes 5. So here the condition is true, and even though the control comes out from the loop because of this particular break statement. So not only here, we can also use a while loop also. We can also use a while loop. Okay, see, let us remove all these things and write down while. Let us take some I is equal to 0 and n is equal to 10 and I less than n. Let us take from 1. Okay, I less than n, print I, and execute here. Okay, sorry, we have not updated the I value, because here, as we are not updating the I value, I will be always 1 and it will be always less than 10. So obviously what happens? So it will lead to infinite loop. So here I need to update the value. So I is equal to I plus 1. Now you can observe it will be terminated, and whenever I becomes 9 and whenever I becomes 10, the control will come out from the loop. And here if you go with is equal to n, so we'll get 1 to 10. Now before printing here, let us check the condition. If I is equal to 5 and write on the break. So what happens here? We can observe 1, 2, 3, 4. Immediately the break statement. Automatically, whenever this condition becomes true, break statement will be executed, and if the break statement is executed, the control will come out of the loop. Now we'll see the next statement. So next statement will skip the current iteration. It will not terminate the complete loop. It will skip the current iteration. So a small change I'll do. So I is equal to 0, let us start, and we'll see the increment in the starting itself, because whenever this next statement is executed, immediately the remaining statements will not be get executed, right? So the statements written after this next will not be get executed. So that's why I'm writing next I increment at the top itself, right? So let us see execute. So first, initially I is equal to 0, 0 less than or equal to 10, it's true. So I is equal to I plus 1, so now I becomes 1, 1 is equal to 5, it's a false. So the control will never into the control doesn't enter into this particular condition. So print I, so it will be printed 1. Similarly, next iteration I becomes 1 less than or equal to 10, true. I becomes 2, 2 is equal to 5, false. 2 will be printed. Next, 2 less than or equal to 10, again the condition is true. So this will be repeated until I becomes 5, and whenever I becomes 5, so 5 is equal to 5, true. So it will the control will enter into this particular conditional statement, and next will be executed. So whenever the next is executed, whatever the statements written after this particular statement will not be get executed, it will move with the next iteration. So immediately it moves to the next iteration, 5 less than or equal to n, true. Now I becomes 6, so 6 equal to 5, false. So immediately this print I, 6 will be printed. You can observe in the output 1, 2, 3, 4 and 6. 5 is not printed, because whenever I becomes 5, immediately this next is executed. So next instructions will not be get executed. It will move with the next iteration. So similarly, we can also implement the same thing in for loop, right? So n is equal to, let us take some 1 to 10, and here instead of writing these things, so let us write for I in n. So inside the loop, what we have to do, so we have to print I. Okay, so let us take this one, and you can observe if you execute, we'll get the complete loop 1 to 10, right? Now before printing, we have to check the condition. If I becomes 5, and let us go with the next statement. So immediately you can see 1, 2, 3, 4, and whenever I becomes 5, immediately the next statement will be get executed. So immediately it will move with the next iteration. So 5 doesn't print here. It doesn't print the value of 5, because whenever I is equal to 5, this statement will be get executed, right? So this is the use of break and next statements in R programming. So one is to terminate the loop, and another one is to skip the current iterations, right? And both we have to use in for loop only. For example, if you not taking any loop, right? So here we are taking some see I is equal to 4, I is equal to, let us take I is equal to 4 and see and execute. So nothing will be executed, directly 4 will be get executed. Okay, and if I is equal to 5, and you can see error in evaluation, no loop or break or next, jumping to top level. So we have to use this one only in the iterative statements. Even though here you can observe I is equal to 5, so 5 is equal to 5, condition is true, so then next should be executed, but here we got an error in evaluation. Eval means evaluation, right? Error in evaluation. So because we have to use this next and break in only for loops, so here also we can get the same thing. Here also we will get the same thing. So without writing the iterative statements, we should not implement this break and next statements. So hope you understood the working of break and next. So let
So the name itself indicates this repeat statement will execute the set of instructions multiple times. So what's the difference over this repeat with the for loop and while loop? So in the while loop, okay, so we are writing the condition. In the while loop we are writing the condition, and based upon the result of this condition we are terminating the loop. That means until this condition becomes false, the same set of instructions will be keep on executing for multiple iterations, right? So the termination depends upon this condition. So when the termination, that means when the iteration should be stopped, that will depends upon this condition. And coming to the for loop, and here we are going with the sequence and membership operator in or not in. So the termination depends upon this particular sequence. So whether the loop variable holds the value which is available in this particular sequence. So if the loop variable holds the value which is out of this sequence, then immediately the termination will be, the iterations will be terminated. So this is for loop. Now what is a repeat? So we are saying that repeat is also a category of iterative statements. That means here also the same set of instructions will be keep on executing multiple times. So here what about the termination? So when there will be termination. So here there will be no condition. So we are not able to write any condition, and also no sequence. So we are also not going with any other sequence. So this is not possible, right? So we are not writing any condition and not any sequence. So when the instructions will be terminated if we use this repeat, so the instructions will be terminated with a break statement. With a break statement. That means this repeat is always an infinite loop. Infinite loop, right? This repeat is always an infinite loop, and the infinite loop will be terminated only with the help of a break statement. So the same way, the repeat, we are not writing any condition, we are not writing any sequence, and just by using the repeat keyword we are going to execute the same set of instructions multiple times. So whenever until the break statement is get executed. So we have already seen the importance, the syntax and the working of break in our previous session, right? So once go through that one and see, whenever the control executes this break, immediately the loop will be get terminated. So in the absence of this break, the repeat will be always an infinite loop. Okay, so here the syntax for a repeat is repeat and give the statements here. Repeat and give the statements, right? And here we need to write some break. We need to give some break. So we need to check for some condition and we have to include that break. So whenever the condition becomes true, then this break will be get executed and the iterations will be terminated, right? So this is a simple syntax for repeat. So this will also be a category of iterative statements. Iterative statements, right? So hope you understood the syntax and the working of repeat. Now we'll move on to the system and I will demonstrate the working of repeat by executing a small program, taking a small example, and I will execute so that you will be understanding the working of repeat statement. Let's move on to the RStudio.
Hello friends, so just now we have seen the syntax of a repeat statement. Now we'll see a small example and I will demonstrate the working of a repeat statement in R programming. So let us start with the RStudio. So let me open that and let me erase the previous content which is available, both the inputs and the program, and then we'll take the example, small example. So I am clearing all the previous contents. Yes. Now let us take one loop variable. I'll take loop variable as I is equal to 1 and I'll repeat. I'll use the repeat, and here we need to print I, and I'll go with the I plus 1. So what happens here? So this is the instructions we are giving. These two are the instructions we are giving inside the repeat statement. So that means these two instructions will be repeatedly executing, right? So here we are not writing any condition, we are not writing any sequence. So this will lead to infinite loop. For example, see, this will lead to infinite loop. So it will start with 1 and see, you can observe it was moving on with a lot of numbers, right? This is an infinite loop. Now, so without any condition, it will be an infinite loop. You can see, I'll write here, I'll write if I is equal to 10, let us take it as a break. Okay, now you can execute here. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the absence of this break, this repeat statement will be an infinite loop. So by using the break only, we can change the infinite loop to the finite. Okay, so break statement, we have already seen the working of break statement. So whenever the control executes the break, immediately the loop will be terminated. The control will come out from the loop, right? Even though the condition becomes false. But here we are not writing any condition. Still, if the condition becomes true, then this break will be executed. And here we are writing the condition when we have to stop the iterations. So if I is equal to 10, then we are saying that break. So immediately whenever I becomes 10, immediately the control will stop iterating, right? So this is the working of repeat statement. So we call this repeat as also an iterative statement. So for loop, while loop, and repeat, the three statements comes under iterative statements, right? So hope you understood this one. So let's stop here. If you are having any doubts regarding this repeat statement, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.
And these functions are usually known as, we can call them as a procedures, modules, or we can also call it as a modules. So this process, we call it as a modular approach. So actually these functions are nothing but a simple piece of code which makes the code reusability. That means if we want to execute the same set of statements multiple times somewhere else, so in order to rewrite the statements once again, we can create a small function and we can continuously call that function repeatedly whenever we require. So that's why the main purpose of using this function is code reusability. So only one time we'll write and multiple times we can use that particular function. For example, so we are having a lot of built-in functions. built-in functions. So like print function. So we are not writing any code. Okay, we are not writing any code. Just we are using this particular print function so that whatever the content we are giving here, that will be printed on the output screen, right? So multiple times in the same program we are using multiple times. Similarly, we can use a cat function. Also we have used this cat function. This is also an output function. And similarly, there are a few more functions like sequence. So in order to find the sequence, in order to give the sequential values, we can go with the sequence. In order to find the minimum or maximum, so we are having a function called min and max. So this will return the minimum value from the given list of elements, and this max function will give the maximum value from the list of elements. So for that we are not writing any code, just we are writing this particular function, and the code is available somewhere else. Okay, the code will be available in somewhere else. So similarly, we can also write our own functions. Those we call it as a user defined functions. User defined functions. So these user defined functions were written by the user, and only once we will write the program, and we can repeatedly call the function multiple times whenever it is required. So one is code reusability, and also by going with this modular approach, okay, so complexity will be reduced. The complexity, code complexity will be reduced. Code complexity will also be reduced. So a complex problem can be divided into different modules. We call them as a functions, and later we can integrate all those functions, right? So, and complexity will be reduced, and easy debugging. Easy debugging. So let us consider any complex problem. If you are having any error, so if the code is not working, it is difficult to find out the error where actually it occurs, right? So when you go with this modular approach, whenever the error came, so you can go with the particular module where you got the error, right? So automatically the debugging process is easy. That means identifying the errors and rectifying those errors, we call them as a debugging. So that process will become much easier in writing a function. So a function is also a piece of code. That means a set of statements that perform a specific task. Okay, set of functions that specific task. Okay, function, set of statements. We can define a function as set of statements that performs a specific task with a code reusability. Right? This is also a function. Now there are two categories, as we discussed, built-in functions, so which are already available in the R programming. So directly we can make use of those functions. Instead of writing the complete code, we can use these functions. And another one is a user-defined functions. So user-defined functions are the functions written by the user. Okay, so coming to the user-defined functions, there will be a function name. The four things will be there: function name, arguments, and return function body. So these four things should be filled by the user, right? So now we'll see what are these things. What is a function name? What is a function body? And what is the return statement? And what is the arguments? Coming to the function name. So every user defined function will be having a user name. It will be having the function name which specifies the functionality. Okay, so user defined name, and we can also call it as a identifier. So which identifies the memory location. Okay, this is also a memory location. So which will identify the memory location. So we need to follow the rules. In our first sessions we have seen the rules to be followed while giving a name for any variable, right? Any identifier. The same thing should be happens here, and we have to call that particular function with the help of this particular function name. So without giving the function name, we can't access the function. So every user defined function should have the function name, which gives the functionality, which shows the functionality. And the second one, arguments. Arguments are the inputs. Arguments are the inputs given to the function. Arguments are the inputs given to the function, and these are optional. It's not necessary. It's not a mandatory to give the arguments to the function. So we can take the arguments, we can take the inputs inside the function also. So we can pass the arguments or inputs from the function call to the function definition. Otherwise, we can take the inputs inside the function also. Right? Now, the third one is a return. So this is a control or value return. Control or a value return. So once the complete function, user defined function is being executed, the result of this particular function, either it can be a value or just a control, that should be sent back to the function call. So this will be the last statement. This will be the last statement being executed inside the function. This is the last statement. Okay. And the last one is a function body. Function body. So this is a place where we have to write a set of instructions. This is a place where we have to write set of instructions. Okay, the actual logic. So the actual logic to be implemented, that should be written inside the function body. So if you want to write any user defined function, these four things are important. So every user defined function should have the function name, and every the user defined function may or may not have the arguments, and the user defined function definitely will return a control or any value to the calling function. And function body, for every user defined function there will be some set of statements which are going to be executed, should be written inside this function body. So coming to the built-in function, just we are using these function calls. Okay, so we are not writing any explicit code to find the minimum value or maximum value. So just we are using this function, automatically we are getting the value because of the code written somewhere else. Okay, the code will be available somewhere else, and just we are calling that particular function. Similarly, we have to write the code here and we can call the function somewhere else. Okay, so let us see the syntax of this particular function. Syntax of user defined function. So the first one is a function name, and this is a function name, is equal to, every user defined function will start with the function keyword. So function, okay, and inside we can give the argument 1, argument 2 and so on, and here we can write the function body, that means statements. So statement 1, statement 2 and so on, and we can write here return. So this is a syntax to define a user defined function. Okay, and these are the optional and this is also optional. Here you can write return value or any expression. Return value or expression. So every function will return either value or expression or a control, an empty control, right? So that's why we can go with this. It's an optional. So it's not necessary to write down the return function. So we may or may not write the return statement. So if you are not giving any return statement, automatically the control will go back to the calling function, right? So this is the introduction to the functions concept. In our next session, we'll go in deep and we'll see different examples. We'll execute a small programs, so demonstrating these particular simple functions with arguments and without arguments, and with returns and without returns. For everything, we'll see with an example, right? Executing in the RStudio functions. So working of functions. So here we have to consider two things. One is function definition. What is this function definition? So this is the place where we are going to write the complete code or logic, right? So block of code or logic is called a function definition, right? And coming to the second one, which is a function call. Function call. So this is nothing but a reference to function definition. This is a reference to function definition. So whenever the control executes this function call, then only the corresponding function definition will be get executed. Okay, so the syntax of function definition we have seen in our previous session. Syntax of function call. Syntax of function call is a function name. So whatever the name we are giving, and give the arguments. If you are passing any arguments, you can write down all the arguments here and give the semicolon, or it's not necessary. Okay, so this is a function call. This is a syntax for function call. And syntax for function definition, so I'll write here function name is equal to function keyword, and here you need to write argument 1, argument 2, and so on. Open this one and write down the statements need to be executed and return, right? So this is the syntax for function definition. So whenever the function, the control executes this function call, immediately the corresponding function definition will be get executed. So unless the user executes this function call, this function definition will not be get executed. Okay, so that is most important, that our program should have both the function definition and the function call, right? So let us move on to the RStudio. So I'll explain with a small example so that you will be understanding how it will be working. So with writing this function name, function call, and without writing the function call. So let's move on to the system.
Hello friends, so just now we have seen the working of functions in a theoretical part. Now we'll see the implementation. So I will demonstrate by taking a small example, so how the functions will be worked. So let us move on to the RStudio, and let me remove all the remaining previous data, removing the history. Now we'll take the function definition first. So the function definition, first we have to go with the function name. So I'll go with the display function. Okay, the function name is display is equal to, and here function. Okay, and pass on the arguments. If you want to pass any arguments, you can pass, otherwise you can leave it. I'm not passing any arguments, right? I just want to display the some content. So print hello world, right? Now if you execute the same thing, nothing happens here. You can observe nothing happens. So until you write the function call, so this is a function definition, right? So this function definition will be executed only after executing the function call. So how the function call should be written? So the syntax is the function name followed by the parenthesis, and if you are passing any arguments, we can pass the arguments. So I'll write here display. So this is a function, and here you can execute, and now you can observe display, so hello world. So even though you are writing the function definition at the top, so that will not be get executed. Okay, that will not be get executed because by using this function keyword, so we are using some function keyword that implies this is a user defined function, and that should be executed only after executing the function call. So unless the user writes this function call, see, I am removing once again. So there is no function call, only function definition I am executing. So you will be not getting any output. The program will be displayed like this, but the output is not displayed. So whenever you write this function definition, I mean function call, immediately the control executes this function call and it will search for the corresponding function definition. See, yes. And before that function definition, you can observe, I'll write one more printf. See, welcome to user defined functions. I'm writing here, and after that I am writing the function. You can observe. So first it will be get executed. And then the display function will be get executed. So this is normal sequential flow. Okay, by default the control flow is a sequential execution. So even though we are writing some function definition at the top from line 2 to line 5 in this example, so we are using the keyword called function, which implies this is a user defined function. So this should be executed only after function call. So immediately the control will move to the line 6, and here we have not written anything. So line 7, so this will be get executed immediately. Again, a display the next line display function, that means a function call. This is a function call. So immediately it will search for this function definition, right? See, once again after that I'll write one more print. Thank you for watching. Right now let us execute. You can see the first welcome to user defined functions, this was executed, then a display function, sequential execution, line 8, line 7 executed, then line 8. So whenever the control executes the line 8, automatically the control will move to the line 2 to line 5. It will execute line 2 to line 5. So whenever it came with the closed braces, that implies the function ends. Immediately it will go back to the original position. That means it will go with the 9. So that's why we got this welcome to user defined function as a first output, and then display function, that means a hello world, as a second output, and the third one thank you for watching as a third output, because that was written after the function call. Okay, and once again if you want to write one more function, right, I'll write with the show is equal to function, and here we can write it inside show function, right? And if you execute, we'll get only the 3. You can observe we will get only the 3, because so there is no function call for show. So whenever you write here show and execute, immediately we'll get a 4 results. See, the first welcome to user defined functions, and then display function result, and then again thank you for watching, and the last it's a show inside show function. Now we'll see what happens if we write this function call above the function definition. So I'll remove this show function also, so in order to avoid the confusion. So yes, so I'll write the function call here. Okay, so I have written the function call first and then function definition. So let us check what happens here. See, so you can observe it will start executing from this part itself. So it is necessary to write the function definition always before the function call. So always write the function definition before the function call. So here this is a case where we are writing the function call before the function definition. So this is the function definition, line 3 to line 6, but function call is line 1. So if you execute this one, if you write the programs in this way, so the function definition will not be get executed. Okay, so it will start only, I mean the program should start always with a function definition only. So the function call should be written after the function definition. So this is the most important thing. Okay, so you have seen the example here. Okay, only two things have been executed, welcome and the thank you. So display function was not executed, just it was displaying the code, but it was not yet executed, right? So this is the working of function. So two things are important. So first one is a function definition and a function call. So only the function definition will be executed only after executing the function call. That's the first point. And the second important point, always the function definition should be written before the function call, right? So let's stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.
Arguments in functions. So here the three categories. So one is function without arguments. Function without arguments. That means it is not mandatory to give the arguments from the function call. So that is an optional. So here just for understanding, we can say the arguments are nothing but inputs given to the function definition. So from the function call, there we are giving some sort of inputs to the function definition, and that is not a mandatory, that's an optional. So we need not pass an inputs from function call. We can take the inputs inside the function also. So the first category, function without arguments. So for example, let us take the function name. I'll write here the function name. Let us go with the addition. So add is equal to, write down the keyword function, and I'm not writing any arguments, right? Zero arguments, and open the curly braces, and here I'll take the arguments, right? So I'll read some a is equal to 10 and b is equal to 20, and print a plus b. So here I'll write the function call add. So this is a function call, right? So this is the function definition, and this is a function call, and this definition will be get executed only once the control executes this function call. So without this function call, this code will not be get executed, right? So here we are not passing any arguments here. So obviously just a function call is executed immediately, the control moves with the function definition, and here we are taking two inputs and we are performing some logic. Okay, we are writing the logic inside the function. So here the parameters we are taking inside the function itself. So there is no need to give the arguments, it's not a compulsory. Next category is function with arguments. So here we can pass inputs from function call to function definition. So outside the function definition, we can read two values and we can pass not only the two values, we can give a multiple arguments, right? So before writing the function call, I'll write here a is equal to 10 and b is equal to 20, and I will pass these arguments in the function call, right? So I am passing these arguments in the function call, and this will be reflected here. This will be reflected here. So see, a plus b, and here we need not write here. So here a and b were declared, I mean initialized outside the function definition, and those things were passed to the function call, which will be passed to the function definition, and that will be get executed. And here you observe that there is not necessary to give the same name. Okay, it is not necessary to give the same name for the arguments which are written inside the function call and the function definition. So in this example, I am giving a and b are the variables in the function call, and the same a and b in the function definition, and it's not necessary. So here we can take it as x comma y, and here we'll write it as x plus y. So what happens? So A and B we are passing. So the value of the first argument in function call will be copied to the first argument in the function definition. So that means it will follow the positional order. So it follows positional order. Positional order. So in which order we are passing the arguments here, the same order it will be followed here. Okay, so A is the first argument, so value stored in A will be copied to X here, because X is the first argument in the function definition, right? So similarly B value will be copied to Y. So it is not necessary to take the same name in both function call and function definition. So this is the second category, function with arguments. Next, function with default arguments. What is this default arguments? That means we will give some default arguments inside the function definition. So if there are any inputs sent from function call, that values will be copied to the arguments, and if there is no value sending from function call, these default values will be get executed. For example, let us take. So here observe, here one thing is we need to use the same names. Okay, so here I will give A is equal to 100 and B is equal to 200. So what happens here? Here if I am using add, so I am not passing the arguments here. Okay, I am not passing any argument from the function call. So these are the default values assigned for A and B. These are the default values assigned for A and B. Those values will be occupied. Okay, and if the values are sent, that means A is equal to 10 and B is equal to 20, and add 10 comma 20. So here we are passing the arguments from the function call. So 10 will be copied to A. That means this 100 will be replaced with 10, and 20 will be replaced with 200 will be replaced with the 20, because the first preference will be given to the inputs passed from the function call itself. Okay, if there are no arguments here, automatically default values will be taken. Okay, so here one thing we have to remember. So whatever the values we are passing, the same variable names should be there. Okay, so this is the third category of arguments. So these are the three ways we can pass the arguments to the function. One is a function without arguments, function with arguments, and function with the default values or default arguments. Right? So hope you understood. Let's move on to the RStudio. So I'll demonstrate each and every category by executing a small program. So let's move on to the system.
Hello friends, so just now we have seen the procedure of passing the arguments to a user defined function. So we have seen three categories: function without arguments, with arguments, and default arguments. Now we will see an example. So let me open the RStudio and clear all the previous data, and then we'll start with the first category, that means function without arguments. Function without arguments, right? Now, so let us take the here, let us write a function definition. So I'll go with the add. So as we have discussed in our theoretical session, so function keyword, and I'm not passing any arguments, and here we are supposed to write the data. So just read the values. So A is equal to as dot integer of read line and enter value of A, and the same thing we'll see. We'll read one more variable, that is a B. So one more variable, it's a B, and now we'll write here print A plus B, right? And now we have to write down the function call. So unless you write the function call, this complete data will not be get executed. So I'm writing the function call here, so without any arguments. So simply I just want to execute this one. So it was prompting for A value. I'll give 10 and okay, here we did not modify, so here also we have given a, okay, 20, so we got a 30, right? So we got 30. So once again I'll execute. So a value it's at 10 and 30, so we'll get a 40. So normal, right? So we are not passing any arguments, so we are taking the inputs inside the function definition itself. Now we'll pass the arguments to the function definition. So here in the function call I'm passing the arguments a comma b, and here we need to take the values a and b, right? So it follows the positional order. The value of first argument will be copied to the first argument in the function definition, and the value of first argument in function call will be copied to the argument second argument in the function definition. So you can observe here again it was prompting for a 100, b 200, and we are getting some addition as 300. So hope you understood this one, right? So it is not necessary to send the arguments from function call to function definition, and also we can pass the arguments from function call to function definition. So here we can simply change the arguments. In the function call I'm taking it as a and b, and in the function definition I'm taking it as a y, x and y. That means it's not necessary to give the same names. So it follows the positional order and it copies the values. I'll go with 100 and 200, and again we are getting the 300. So the value of a will be copied to x and value of b will be copied to y, right? Hope you understood. Yes. Now coming to the default arguments. So here consider let us take a and b, and I'll give the default arguments. A is equal to 100 and b is equal to 200. Okay, so if you pass the arguments from this particular function call, automatically these default values will be replaced with the inputs sent by the function call. So you can observe here. So it was prompting for a, I am giving some 10 and 20. Oh, okay, here we have given some x plus y, which is not correct, and here we are giving a plus b. Yes, once again let us take 10 and 20. So we got a 30 because 100 is replaced with 10 and 200 is replaced with 20. And now let us check here. So here we are passing only an empty function call. We are passing an empty function call. We are not giving any values, right? So automatically the default values will be taken here. So you can observe 300 will be taken, right? So here function call doesn't have any arguments, but here function definition we are having the arguments, and these arguments must be the default values. So if you pass like this, a comma b, obviously it will get an error. A is missing, okay, with no default. So we can pass the default value. Okay, if I go with 100, and I give some 20, okay, so 20 is again it will follow the positional order. So 20 will be taken into a, right? See, the result will be 120. So 20 will be passed to a, and b value is not there, so 100 will be taken, and 20 plus 100 will be calculated here. And you can observe a is equal to 100, and let us take some b. Okay, what happens? Obviously it will get the error because it will follow the positional order. So 20 is the first argument, so 20 will be moved to variable a. Okay, so here there is no second argument, so the second argument here also there is no default values for the second argument. So obviously b value is missing. So always the default argument should be at the end of the arguments list, right? So let us take some 20 plus 30. Now we can get the result as a 50 because 20 will be copied to a, that means 100 is replaced with a 20, and 30 will be copied to b, and the addition will be performed and we'll get the addition as 50. Okay, and let us take a different argument, some x comma y, and take okay, yes, here we'll take some x and y, and let us check what happens. So here in the function call we are giving x comma y, and in the function definition we are passing a comma b, and we'll check. So it was prompting for X. I'll go with a 10 and Y is 20 and we got 30. Okay, here also it is not necessary to have the same name for the arguments in the function call and function definition. So here we are giving X value which is copied to A and we are giving Y value which is copied to B. And if you give here B as 100 and if you pass only one value X, see X value 20, Y value some 30 which is not used in our program. So 20 will be copied to A and here we are not passing X value. So the second argument will be considered as 100, right? A plus B 20 plus 100. So that means it will follow the positional order to copy the values, as well as if there is no value sent from the function call, automatically the default value will be taken as a consideration in the function definition, right? So hope you understood the three categories. That means a function without arguments, function with arguments, and function with the default values, right? So let us stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. In this session we'll see the mathematical functions. So these are all the built-in functions, so we need not write the code explicitly, so we can make use of the existing functions. So now we'll see the math functions, all the mathematical functions. The first one is absolute function. So absolute function, the syntax is ABS of a variable or expression. So it gives absolute value, right? So we'll explain you with an example. So let us open the RStudio and let us clear everything which is appeared earlier, and then we'll execute the things. Okay, so yes, so let us clear all the logs, that means the previous outputs. Now you can see absolute, so print absolute of -10. So if you execute this one, we'll get the absolute value of that particular -10, that is a 10, right? So absolute. And the second one is a square root function, square root of variable, and it will work for a positive value and a negative value. So if it is a positive value, then it will return square root of given variable, square root of given variable. And if the value is negative value, then it will return, or it will treat the variable as nan, that means not a number. So square root function should take always a positive value, not a negative value. And see, you can observe here. So the second thing, print sqrt, the function name sqrt, and here you need to give the value. So I'll give some 16 and execute. See, you got a 4 as an output, and if it is a -16, that means if the variable is a negative value, it gives a nan. So see, nan, not a number. Okay, it doesn't consider it as a number. Okay, so square root works with the positive value and negative value. It will give the square root only if it is a positive value, and if it is a negative value, it will return nan. And the third one is a ceiling function. And here also we'll take one variable as a parameter, right? So it will return smallest integer which is larger than given value, the given value, right? So whatever the value we are passing to the ceiling function, so it will return the smallest integer which is larger than given value, and simply we can say it as a round up function. So we can call it as a round up function. Okay, simply. So let us check. So ceiling function, print ceiling, I'll give some 10.1. So it will return the smallest integer which is greater than given value. So 10.1, what is the smallest integer greater than 10? That's nothing but 11. So, okay, sorry. Yes. So 11, we got as 11. If it is a 10.1 or a 10.9, we'll get 11, right? So ceiling function. What happens if you give the negative value? Check out. So still we are getting the same thing. So 10 minus 10 is a greater number than minus 10.9. So we got a greater number. Okay. So this is a third function, and a fourth one is a floor function, which is quite opposite to the ceiling function. So it will return largest integer. Yes, it will return largest integer which is smaller than given value. Okay, and here we call it as a round down function. So this is similar to round down. Floor function, which is similar to round down function. Let us check. So sorry. And if you apply the same thing and give the floor function here and give 10.9, okay, execute, you will get the result as 10, because it returns the largest number which is less than the given number, largest integer which is less than the given number. Okay, 10.9. So round down, so it will be 10. And even though if it is 10.1, it will return 10 itself. Okay, and if it is minus 10.1, it will return minus 11. Okay, so minus 11 will be the largest. Clear? So hope you understood. Then the next one is a truncate function. Truncate. Trunk of variable. So it returns the truncate value of given variable or given input. Okay, so the decimal part will be truncated here. So print the function trunc 10.5 or 10.4 we can go with, so it will return 10, and if you go with the 10.6, again we'll get a 10. So the decimal part will be truncated, only integer part will be returned. Okay, even it is a 10.9, it will return 10. Even it is a 10.1, it will return 10. Right? So that means it only returns the integer. So the decimal part will be get truncated, removed. Okay, and then the sixth category or sixth function is round function. So round function will take two arguments. One is a variable or a value, and the second one is how many digits we need to round. Okay, we need to round. So this function, it returns round value of given variable with a given digits. So the variable or a value will be rounded and according to the digits specified in the second parameter. For example, here you can take it as print, let us take round function of 3.1234567 and see, for example, if you execute, we'll get it as a 3. That means if it is the decimal point is equal and above 5, it will truncate to the next number. So here 3 point, after decimal we are having 1, so that's why we got a 3. Okay, if it is a 3.5, you will get a 4 as a round function. If you apply the round function, you will get a 4. So that means if the decimal point is less than 5, so that will be ignored. The decimal part will be ignored and the integer part will be immediately displayed. And if the decimal value is greater than or equal to 5, then the round function will be acting as a round up function. Okay, round up function. So here the second parameter we can take, that is number of digits we need to round. So digits is equal to 2. You can check 3.52. So here these are the two values, and after 2 the value is 3, so which is less than 5, so this will be ignored and we'll get 3.52. For example, if it is 6, now it will be 3.53. So here we need to give the number of digits, the value as well as the number of digits. So the value will be rounded with respect to the number of digits given in the second parameter. So that is the use of round function. And the next one is a trigonometric functions. Trigonometric functions like sin x, okay, cos x, similarly tan x. So x can be the value, so trigonometric functions. Trigonometric functions, right? So here you can check print sine of 0, which will return, and you can see 0. Sine of 90, we can see 0.89. Sine of 45, we can see the value 0.8502, right? Similarly, the sign can be replaced with cos and also tan. So you can go with the cos 45, sorry, COS, trigonometric function, right? 0.52. Similarly, print tan of 90 degrees, which is minus 1.92. Okay, 90 is a value. Okay, 90 is nothing but a value. So doesn't consider it as a degrees. Don't consider it as a degrees. It's a normal value. Okay, and then these are all the trigonometric functions. And the next one is a logarithmic. It's a logarithmic. That's also a natural logarithm. That means simply log of variable or x. So it is natural logarithmic. Natural logarithm of given value. That means base e. Base e. So you can observe here print log of 2. So log of 2 means, log of 2. Yeah. Log of 2. That means log 2 base e. So that's why we call it as a natural logarithm. We call it as a natural logarithm. And the next one, log 10 variable. That means base 10. It is a logarithm of given variable with base 10. Okay, so you can observe here print log 10 of 10. That means log 10 base 10. So log 10 base 10, which is nothing but 1. And if it is log 2 base 10, we'll get the result as 0.3010. Okay, so that's the difference. In the above case, it is a log with base e. So that's a normally we call it as a natural logarithm, and this is a common logarithm. So we need to specify the base. Okay, we need to specify the base. So that is base 10. And here we can also change the base value. We can also change the base value. So here you can write it as log base and a variable. Log base and variable. So with a given base. So here also I am writing a general case. not a 10 base. And the 10th last one is an exponential. It returns the exponent of given variable. So it will return exponent of given variable. Okay, it gives an exponent. So we can see here, so print exponent of 1, which gives the exponent of 1, 2.718282, right? So these are the different built-in functions related to the mathematical formulas. So we have seen absolute, square root, ceiling, floor, truncate, round, sine, cos, tan, log, base, and exponent, right? So similarly, we are also having a lot of functions related to strings and statistical formulas. So that we'll cover in our next session. So hello friends, welcome back to our channel. So today we'll see the built-in functions related to the strings concept. So in our previous session, we have already seen a few built-in functions related to math functions, and now we'll go with the string functions in R programming. So it supports a lot of built-in functions, but we'll see the major built-in functions. All right, so let's start. So string functions, and the first one is substr. That means it stands for substring. So it takes a 3 parameters: the string name, the start value, and the stop value. So from which value to which value we have to extract the substring. So it extracts the substrings of a given range from the input string, right? Now we'll see the implementation. So let me open the RStudio and let me clear all the previous content and we'll start, right? So now we'll read two strings. One is normal string, welcome to R programming, and one more thing is a vector, character vector, right? So let us take some Java, some C, Python, right? So here we have taken one is a string, another one is a vector, character vector. Now we'll implement that substring. So print substr from str, and what's the range? From 1 to 7. So that means starting from first character to 7th character, right? So this is not an index, it doesn't start with 0. So here 1 means W. So from 1 to 7. So 1, 2, 3, 4, 5, 6 and 7. So that means welcome. The word welcome will be get printed. Let us check. Execute. Yes. So you got this welcome. And you can change the values, the stop value. I'll go with a 10. So you can execute and see welcome to. Okay. And you can change the start value. So come to. So even the space is also be calculated as a one character, right? So this is how we can extract the substring from the main string. And if you pass the character vector instead of string, what happens? See, sorry, it is yes, right? So from the first element, it starts with the 4th character and it ends with a 10 character. So what's the 4th character? A. So it starts printing from A and it ends at 10. So but obviously here A is itself is the last one, so nothing has been displayed. So here there is no 4th character. Here also there is no 4th character. So no 2 empty spaces, right? And come to here 1, 2, 3, 4. H is a 4th character. So from H 10 characters will be get printed, but here in Python, word Python, so we are having only 3 characters from H, so that will be get printed. So individual elements, the same substring will be applied for the individual elements of a vector. So if it's a normal string, obviously we'll get the substring. If it is a vector, for every string or for every character, the same thing will be applied, right? So hope you understood the first function. And the second function is a grep function. grep. So here we need to pass a pattern. So it will search for the given pattern. So the second parameter is a string pattern and the string, right? So it will return true if it matches in the given string, right? So pattern check will be done on given string, or also we can pass the vector, right? See, for example, take the same example, right? So instead of substring we can take it a pattern, right? So let us check grep, give the pattern here. First give the pattern. So I'll give W from str, right? Cap and W from str. Just a second. Yes. Yeah. So you can observe here. So it will check whether the string starts with a W. So in the str, string starts with a W. So obviously we got the first occurrence. I mean the first place where it starts. For example, if you go with a 2, if the pattern is TO, that means it will search for both the characters TO. So it is at WO. For example, if you go with a WO, see, so one pattern, okay. And also if you pass the same thing, instead of yes we can pass the vector. See, we got a 4, so that means from the fourth element, in the fourth element we got it, okay. And see second element and the third element, in the two positions we got it, And for example, if you go with a false case Z, so 0, it gives it 0 value. So because Z is not available in yes, so even though if you can give str and check, so we'll get a 0. Okay, so this is how we can implement the second one, a grep, for pattern check in the given string, or we can say it as a vector. And the third function is a replacement function, substitute, okay, sub, and substring replacement, and input string. So in which input string we have to change. So replacement of substring will be done, right? So replacement of substring. For example, let us take some yes instead of this one, sub, substitute, and give the string. I'll go with the R. Okay, I'll go with the word R, comma. I just want to replace it with Java in str, right? Let us check. See, welcome to Java programming. So wherever there is a capital R, it will be changed to Java. And see, if you go with a small r, so here you can see in this complete string we are having a 2 possibilities. Okay, then the replacement will be done in the first occurrence. You can observe here in this example. So we are replacing a small r with a Java. So in the given string str. So in this given string str, you can observe. So there are 2 occurrences of small r. So this will be replaced on the first occurrence of small r, right? So this is the replacement. For example, instead of a string, what happens if you take this vector? right? So instead of R, we can go with C. Java, and here we got a C, so that will be replaced as Java. And again the third element again C, Java++, and the fourth element Python. So you can observe here, this is a vector. Vector means a collection of multiple elements. So for every element it will check with this particular case. Okay, for example, if you go with A and if you want to replace with a capital A, and you can observe here, so in the first element we are having a two occurrences small a, so only the first occurrence has been changed. Okay, so if it is a is available here, then in the second element also the replacement will be done on the first occurrence. So if it is a string, the first occurrence will be replaced. If it is a vector, the comparison will be done on each and every element of a vector, right? So hope you understood this one. Next, paste. So this function is used to concatenate the elements. So paste, you can give the str or a substring, string, and also the SEP keyword with delimiter, right? So here what happens? So concatenation will be done. Concatenation of strings with given separator. With a given separator. Right? So let us check. For example, print paste str and substring. First we need to give the substring, right? So I'll give hi str and SEP is equal to space. I just want to give a space. Now you can observe, see, hi will be concatenated with the str with a space, and instead of giving a space, if you give hyphen, see, hi hyphen welcome to R programming. And if you want to give any other special symbols, you can also give that. Hi dollar welcome to R programming. Not only this one. So see, I'll give separator as guest. You can see, hi guest welcome to R programming. So whatever the delimiter or a substring we are giving in the SEP parameter, the strings will be concatenated with this particular separator. Okay, the multiple strings will be separated with this particular thing. And for example, if you go with the same thing, if you paste the string hi to the vector, so the same thing hi will be applied for each and every element. You can see hi Java, hi C, hi C++, hi Python. So the same content will be applied for each and every element of a character vector. So that is the use of a paste function. So simply it gives the concatenation of strings. And the next one, hope you understood this one. And the next one is split. So str split and give the string, and what is a split with which we have to split. Okay, split string, right? So what happens here? It splits the string with given substring, with reference to given substring, right? With reference, right? See, now we can check print str split. Let us take the str function. Okay, here str variable. From the str, if you want to split at the space, so you can see welcome is one word and there is a space, so obviously it will be splitted. And 2, the second word, again there will be a space, and R programming is the third word, again it is split. For example, if you go with the O, what happens? If you go with the O, that means with reference to O, the split should be done. That means in our string, wherever there exists O, the split will be done. For example, you can observe. So here WLC. So here O is there. So that becomes one word. And next it will start with ME space T. So again O is there. This is the second word. And again space R hyphen PR. Another word. And again O is there. So GRAMMING. So this is another word. So with respect to this particular substring, the splitting will be done on the input string. For example, if you go with a vector, so the same thing will apply on each and every element. So in Java there is no O, there is no split. In C there is no O, there is no split. C++ there is no O, there is no split. But in Python there is a O. It will be splitted into two words, PYTH and N. You can observe PYTH and N. So this is how we can implement the string split function. And then the next one is a to lower of string. To lower of string. So converts given string into lowercase characters. For example, let us take, this is all the lowercase. Let us take a one more string, st is equal to capital letters, welcome to R programming, right? Okay, welcome to R programming. Now we can go with the function called to lower of st, and you can observe the complete string is converted into lowercase. The complete string is converted into lowercase. We are passing the string st. What is the string available in st? So capital letters, welcome to R programming. So that will be converted into small letters. And similarly, there is a one more function called to upper. So which will converts given string into uppercase characters. So the complete string will be converted into uppercase characters, right? So hope you understood. Now we'll see print to upper str. So we are passing the parameter str as a string. So str is having all the characters in a lowercase except some r and p. Okay, if you execute, you can see every character will be converted into uppercase. And if the same thing applied for s, so s is a vector with a group of strings, and you can observe, so every element of a vector will be converted into a capital letter, right? So hope you understood. So two upper and two lower. And the next one is nchar of string. So it gives number of characters in a given string. It will give number of characters in a given string. So let us check. For example, print nchar of str. Now you can check how many characters. So we did not count the number of characters. So we can check the number of characters in given string, right? So Let us check. So there are 24 characters. There are 24 characters. Okay, and see what happens if you go with the ST, because both are same, so the characters will be same. And if you go with yes, what happens? Yes is a character vector, right? So multiple elements will be there. And here you can see first element 4 characters, second element 1 character, third element 3 characters, and fourth element total 6 characters. So you will get the result as an individual element, as an individual elements. Okay, so these are the major string functions that will be useful in R programming. Substring, which will extract the substring, grep, which will be used to check the patterns, given pattern, and substitute, which will be used to her replacement, and paste for concatenation. Split, str split is used to split the substring with reference to the given string, and tool upper to change the lowercase and uppercase characters, and nchar is used to count the number of characters, right? So hope you understood this one. Let's stop here, and if you are having any doubts regarding any one of the given functions, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.
So there are different data structures supported in R programming. Those are built-in data structures. So first one is a vector, list, array, matrix, data frame. Right? So all these are the different built-in data structures which are available in R programming. Now we'll see the vector. So here the vector is having again two categories. One is atomic vector, another one is a list. So which is our second category of data structure. Now in this session we'll see the atomic vector, right? So the first one is a atomic vector. So we know that a vector means a collection of elements or a group of elements. Now the atomic vector means a collection of elements of same data type. Same data type, right? So the difference between the atomic vector and the list is the data type. So if the collection of elements are of same data type, we call it as a vector, and the collection of elements with the different data types, we call it as a list concept. So here we are studying about the atomic vector. So elements should be of same data type. So it depends upon the data type. They will be having numeric vector, integer vector, and character vector. So here we can have all the numerical elements, right? And this is all integer elements, and this is all character elements, a group of character elements. So usually we know that a variable is a memory location which can hold the value, right? So which is a single value. But if the same memory location which holds the multiple elements, we call them as a data structures or a sequence types. So here a numeric vector, integer, and a character. So in numerical elements in means 1.0, 2.3, 4.5, etc. all float values, the numbers with the decimal values comes under this one, and integer part, so 1L, 10L, 35L. So we have seen the data types in our previous sessions. So all the integers should be represented with the L as a end, right? So the number appended with the alphabet L indicates that it is an integer. So this is a character, obviously it will be some A, B, and etc. all comes under this character elements. And now how to creation of vector. This also we have already seen in our previous sessions by using the C function. So by using C function, right? So you needed to pass the elements into this particular function as a parameters. So example, we can say C of 10, 20, 30. So this is a normal vector. Okay, this is a normal vector. So the elements have been inserted with the help of a C function. And similarly, we can also use some sequence function. And this sequence function will also create a vector. So here we need to give the range, the start value as well as a stop value. So whatever the elements which are available in between the start and stop range will be created in the vector. And the next one is a column, that means range. We can also give the range, right? For example, so start number colon a stop number. Obviously here also it will take some range of values from start and stop, and those elements will be created by the vector. So this is how we will create a vector. Now another important thing is accessing elements of a vector. So similar to our previous programming languages, in order to access the elements from the sequence or a group of elements, so only one thing, that is by index. So here it will be done with the help of index. And one difference in R programming over other programming languages is, so in other programming languages usually the index will start with 0, but here in R programming the index will always starts with 1. Okay, so that's the main difference. So this index always starts with 1, not a 0. Okay, always it will start with 1 but not 0. That's the main important point which differ the accessing of elements from R programming with another programming languages, right? So this is the introduction about this atomic vector, and there are more number of functions which are being supported in this atomic vector. So we call them as an operations, atomic vector operations, right? So we'll stop here for today's session. So what is a vector, and what are the different types of vectors, and how can we create a vector, and how can we access the elements of a vector, right? So now we'll move on to the RStudio. I'll demonstrate each and every point, so by executing a small program. So in our further sessions we'll see the operations, what are the different operations available in this atomic vector, and then we'll move on with the next vector called a list concept, right? So now let's move on to the system.
Hello friends, so just now we have seen the theoretical part of creating the vectors and accessing the elements of vector. Now we'll see the implementation part of this one. So let us open the RStudio and we'll clear all our previous programs here, all the environmental variables which we have used and everything. So now we'll start. So now the creation of a vector, right? So creation of a vector you can see by using the C function. One is by using the C function. Let us take some A is equal to C function and give the elements 20, 30, 40, 50, and simply you can check with the data type of A, and you can also print A. So execute, you can see, yes, see, you can see the vector A is a numeric vector. It's a numeric vector, and we are printing the elements. And if I use L as an end here, see, by default it will be the numerical vector, and if I use a L here, see, the class is an integer. So an integer value should be represented with a L at the end of the value, right? So this is an integer vector. For example, you can also go with A B C. You can see it is a character vector. So because we are using some character, what happens if we use 2 characters and 1 integer? See, still it is a character vector. It will be considering it as a character vector. Okay, what happens if 2 are integers and 1 is a character vector? Let us try here. Now you can see still it is a character vector. What happens if it is some numeric? So it will be a numeric vector. It will be a numeric vector. Okay, so automatically it will be converted into that particular value. So even though we are giving some 10 as an integer here, so here 1 is a numeric vector, automatically the remaining elements will also be converted into a numeric, because you can observe here 10.0 and 20.0. And if it is also an integer, we can see. So now it will be an integer 10, 20 and 20. So like that it will convert into any one of the atomic vector, either integer or a numeric or a character. So first preference will be for the character. If any one of the element will be in a character, automatically that will be as a character. If any one of the element is in a float, then it will be a numeric vector, right? Now see what are the other ways to create a vector. Here we are using some C function, and what are the other ways? So we have seen by using a sequence. So I am giving some sequence, I am giving some start value, comma, and value. And see, you can observe, so 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it will be a sequence. This will be a sequence. So we can also have the third parameter in this sequence, so which is some 5, and you can observe the difference will be of 5. So first value will be 10, and with a difference of 5, the second value will be 15, and the third value with a difference of 5, it will be 20. Right? So by using this sequence also, we can create a vector. So here A is also a vector, a numerical vector. And third one, by using the column, 10 colon 30. And you can observe here. So from 10 till 30, it will be arranged and it will be created and it will be stored in A, which is of integer data type. Right? So by using these 3 terms, we can able to create the vectors. One is by using a C function, second one by using any sequence, and third one by using the colon operator. Right? Now the question is, the next one, how can we access the elements of a vector? For example, you can consider here 10 to 100 with a difference of 20. We'll take the sequence. Okay, we'll take the sequence of 10 to 100 with a difference of 20. What happens here? So the values are 10, 30, 50, 70 and 90. Okay, so now how can I get the element of 50? So here the index of 1, right? Usually in order to access the elements, we said that will be done only with the help of index, and here the index will always start with 1 rather than 0. The representation is also similar to other programming languages. We need to use the index number in between the subscript. So the syntax for accessing the elements is the vector name followed by the square braces, and inside the square braces we need to give the index which we require. So we are giving A of 1. So obviously we are getting a 10. And if you go with a of 2, so it will get the second element 30. Similarly, we can go with a of 5, which gives some 90. So we know that a will be the last element. Okay, a is the last element. What happens if I access the sixth element, which is not available? So see, it is a not available, NA. So 7, sorry, instead of 6, again give 7. What happens? It's also not available. What about the negative index? If we give the negative index -1, see, -1, so it will remove the first element and it will access all the remaining elements. You can get, see, 30, 50, 60, 70 and 90. And for example, if it is in a -2, so second element will be removed. Okay, second element will be removed, minus. So 10 and second element has been removed. And -3, you can observe the third element will be removed. Okay, in order to avoid that number, we can go with the negative index. So it doesn't raise any error. If you give the negative index, it will remove or discard the value of that particular index. If you give -1, the first element will be ignored. If you give -n, the nth element will be ignored. And all the remaining elements will be displayed same. So this is how we can access the elements of a vector. So hope you understood the creation of vector by using the C function, sequence function and the colon operator. And again, we have seen the different types of vectors: integer vector, character vector and normal numeric vector. And also we have seen how can we access the elements of a vector by using the positive index values and negative index values. So hope you understood the introductory part of atomic vectors. So we'll stop here, and in our next session we'll see what are the different operations that can be performed on these atomic vectors. So hope you enjoyed the session. So if you are having any doubts regarding this session, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Now we'll see the operations one by one. So I'll demonstrate each and every operation by taking a simple example. So we can perform basically these 8 operations: the concatenation, all the arithmetic operations, indexing, multiple indexing and range of index, modifying the elements of vector in both the cases using indexing and the condition as indexing, and how can we delete the vector, and the sorting, how can we sort the elements of a vector. Coming to the first one, concatenation, that means combining 2 or more vectors. So let us open the RStudio and let me clear all the previous data, and we'll start doing with an example, right? So I'm removing all the previous data. Now take the one vector, a C of, let it be some 10, 20, 30, and take the another vector B is equal to C function of 40, 50 and 60. And simply you can combine these 2 vectors or concatenate these 2 vectors and create a new vector called some D is equal to C of, let us take A and B as a parameters to C. So print D, or you can in order to avoid confusion, we can take it as a result. Okay, result. So take result. So you can observe the result is having all the 6 elements of both the vectors A and B. Now, so this is a simple way how we can concatenate. That means we can pass a multiple vectors as a parameters to the vector function, C function. For example, let us take some D is equal to, again, C function of 70, 80 and 90, and pass the third parameter here, A comma B comma D. So you will get all the 3 elements. So simply passing the vectors as an argument to the vector function, will create a new vector combining all the vectors given as a parameters. Next, the second one is a arithmetic operations. So we can perform all kind of arithmetic operations on vectors like addition, subtraction, multiplication, division, as well as a modulo. So all these arithmetic operations can be performed on vectors. So let us see one by one. Okay, let us see one by one. Print, let us take a plus b. You can see the addition of both, addition of elements in both the vectors 10, 20, 30 and 40, 50, 60. For example, if both the vectors are of different length, what happens? Let us check. So first vector is having only 3 elements and the second vector is having the 4 elements, and we are performing the addition, and see, you'll get an warning message. Longer object length is not a multiple of shorter object length. So we can't perform any operation. So one condition to perform these arithmetic operations is both the vectors should be of same length. So if both are same length, you will get the result as 50, 70, 90. So 10 plus 40, it gives a 50, 20 plus 50 gives a 70, and 30 plus 60 gives a 90. And instead of plus, you can also give the minus. That means a subtraction will be done. So 10 minus 40 it's minus 30, 20 minus 50 it's again minus 30, 30 minus 60 again it's a minus 30. And similarly, if you give the multiplication, it will display the product of all the elements of the vector. So 10 into 40, 20 into 50 and 30 into 60. And similarly, the next arithmetic operation division, you can see, so 10 divided by 40, 20 divided by 50 and 30 divided by 60. And if you want to perform the arithmetic operations, modulo, so use a double percentage to represent the modulo operator. So 10 mod 40 is a 10, 20 mod 50 is a 20 and 30 mod 60 is a 30. Because we know that, so if A mod B, if A is less than B, then A mod B will return A itself. Now you can reverse the expression B mod A. Now 40 mod 10, it becomes 0, 50 mod 20, so obviously it will, the remainder is 10, and 60 mod 30, again it's 0. So you can see 0, 10 and 30. So one thing we have to remember, if you want to perform the modulo operation, use a double modulo. Okay, next, indexing. So this already we have seen in our previous session. Indexing means we have to pass the index value inside the subscript of a particular vector, and here the index starts with a 1, not 0. In other programming languages, usually index starts with 0, but here the index starts with 1. So let us create one more vector with a more number of elements. So sequence of 10, 100 with a difference of 10, and see here print A, and now you can observe the elements of A are 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. And index of all these elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because index starts with 1 itself. So here you can see print of A of 4. That means a 4th element. So 1, 2, 3, 4. 4th element is 40. So we'll get the result as a 40. So we need to pass the index as a parameter. Sorry, as a inside the subscript. Okay, we need to pass the index value inside the subscript. So if you give the -4, the element will be omitted from the given list. Whatever the element which is available at 4 will not be displayed on the screen. For example, if you execute the same code, so fourth element is 40, so that 40 will not be reflected in our result. For example, say I'm executing this program, you can see 10, 20, 30 and 40 is not available. So directly we are getting 50, 60, 70, 80, 90 and 100. Okay, so this is a normal indexing, negative index or a positive index. Next, we can also pass the multiple indexes by using a comma operator. For example, if you want to get a multiple index, like we need to get the elements which are available in first index, third index, fifth index and seventh index and ninth index. So obviously we'll get, so we need to pass as a parameter, as a vector function. Okay, see, we need to pass a vector function. I'm sorry. See, we are getting 10, 30, 50, 70, 90. So if you want to pass a multiple indexes, a comma separated indexes, we need to pass a vector of that particular indexes. Vector of that particular index. So what happens if the index is not available? For example, a of 20. So it will give NA, not available or not applicable. So it will return NA. So multiple, if you want to give a multiple, so give the multiple indexes as a vector. 1 comma 10. So you'll get the values 10 and 100. And other than this multiple indexing, we can also give the duplicate indexing. So if you want to give the duplicate indexing, comma 1 comma 3 comma 10, so you'll get the elements. Even though you are giving a multiple times 1, you will get a multiple times the same element. If you are giving the multiple times a 10th element, in the result also we will get the multiple times a 10th element. So duplications were also applicable. Okay, and the next one is a range of index. Instead of passing a vector of indexes, we can give the range of index by using this one. So vector name inside the subscript, in the place of index we can pass the index range using the colon operator. Usually we call this as a slicing operation in Python. So I'll give 1 to 5. So it will display all the elements with the index values 1, 2, 3, 4 and 5. See, and both the indexes are included, not excluded. Okay, so it will start extracting the elements from 1, index 1, index 2, index 3, index 4 and index 5. Because here we are mentioning the index range as 1 is to 5. So total 5 elements will be displayed. And the next one, how can we modify the elements of a vector? So we know that we have created a vector. And how can we modify the vector? So one is by using indexing. So simply by calling the index, we can reassign the value. So a of 4 is equal to 0, and again once again I am printing a. So this is a value without reassignment. Before reassignment 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. And after that the next statement is I am assigning 0 to 4th index element. So whatever the element which is available at the 4th index, the 40 will be replaced with this value 0. Okay, so this is how we can modify the existing vector. And one more thing, we can also give the condition as indexing. Condition as indexing. So you can also give the condition. For example, a of 4. What happens here? So you'll get a 4th element. So here you can give a greater than 40. Inside the index we can pass the condition. So whenever the condition becomes true, then only the element will be returned. So first 10. 10 is greater than 40, false. No, next element. 20 greater than 40, false. 30 greater than 40, false. 40 greater than 40, false. 50 greater than 40, true. So 50 will be printed. 60 greater than 40, 60, yes, true. 60 will be printed. 70, 80, 90, 100. So you can see we'll get the elements from 50, 60, 70, 80, 90 and 100. So instead of giving the index, normal index or negative index, we can also give a condition as an index value. Right? And the next one is a deletion. How can we delete the existing vector? So here deletion means assigning a null value to that particular vector. So here I'll give a is equal to null. So automatically the vector a will be get deleted. You can observe here. So print a, we got a null. Okay, so there's a simple way how we can delete the vector. And the last one is a sorting. So how can we sort the elements of a vector? So here we can sort the elements in a ascending order or a descending order. For example, let us take the vector in a random way. So I'll go with the 50, 10, 40, 20 or 30, 20. So I'll take this one, and now you can observe the same elements will be get printed. So you can see the difference 10, 50, 10. These are unordered. Okay. Now let us check with the sort function. So sort of a, which will give the sorted order. See, all the elements are in sorted order. That means ascending order. Ascending order. By default, the sort function will arrange the elements in ascending order. So if you want to get the same thing as a descending order, So we have to pass a one more parameter inside the sort function called decreasing. So decreasing is equal to true, the keyword true, right? So true should be a capital letter. And by default the decreasing will be false, so that's why we are getting the elements in a ascending order. Now you can observe the elements will be in descending order. Elements will be in descending order. So by using this simple parameter descending, and we are just giving true value for this decreasing, automatically all the elements will be sorted in a descending order. So these are the different operations that we can perform on vectors in R programming. Today we'll discuss about one more concept in R programming, that is list. So in today's session we'll see the creation of a list and how can we access the elements of a list. So here list is also a category of vector, right? So actually the vector is classified into two categories, that is a atomic vector and this list concept. And list concept means a collection of elements with different data types. So actually the atomic vector means it is also a collection of elements, but it should have the same data types. But here the list is a collection of elements with different data types. So the first one is a creation. So how can we create a list? So by using list function we can create a list, right? So we'll see how to create an empty list, and we'll see the data type of that particular variable which we are creating by using this empty list, right? And now let us open the RStudio and I'll demonstrate by using a small examples. So here you can see I'll erase all the previous data. Nice. So L is equal to what happens? List function. I'm taking the list function. So I'll print the class of L which describes the data type, which gives the data type of L, right? So if you execute, you can see the data type of L is a list. And here we can create by using a list function. So we need to pass the elements into the list function. Let us take some 10, 20, 30, 40, 50. And you can see print L, so that see we are getting all the list elements, right? So here the difference between a list and a vector, atomic vector, means different data types. So list can have different data types, it will support different data types. For example, you can see 10 comma 20.5. so 10 is an integer, 20.5 is a float, and instead of integers we can take a string. See, string, and we can also give the boolean type either true or false, and complex type, so 20 plus 40i. So this is a format way how we represent the complex numbers, which is having both real values and imaginary values. Now here we are passing all these elements into a list function, so automatically it will create a list with all these elements. So you can observe, execute, so you can see, so 10, 20.5 R programming true, and 20 plus 48. And now let us check with the class. So I'm just printing the class, so you can see a class of L is list. Okay, so now, so these are the different ways we can create a list: empty list and normal list. And then how to access the elements of a list. So usually So accessing elements from list. So that is by index, and here the index starts with 1, right? Index starts with 1. Let us check. So take the same example. I'm taking L of 1. What happens? See, we are getting 10 as a value. And then if you go with the 4, it will return true value, right? So here we can also give the range of indexes. Let us check. 1 is to 3. So we are getting 3 elements, 1, 2 and 3. Also we can give the range of elements. And similarly, a list of indexes, we can pass a vector of indexes, not a list of indexes. We can pass a vector of indexes. Let us try with this one. So C of 1, 2, 3. So still we are getting the 3 values. So here we can see 1, 3, 5, and you'll get the same 10 R programming and 20 plus 4, 40 I. So all these things, that means whatever the operations we are performing on vectors, everything can be implemented on list, but only difference is list supports multiple elements with different data types. So all these indexing, everything we have seen in our previous session. So I'll post the link in the description so that you can follow that. Okay. So whatever the operations we are doing on vectors, the same thing can be applied on list also. So the similar way we can access the elements of a list. Now, here we can also create a nested list. So how to create a nested list? So creation of nested list. So inside the list, writing the another list as a function, right? For example, list. So this means this is a nested list. So we are giving a list as a parameter to again one more list function. For example, let us take here. So I'll remove all these things. Some L is equal to. So take again take the list. So 10, 20, 30, comma. Again one more list. Let us take. Or simply you can go with the R programming and 90.5 float, string and list, and see if you print L, just a second. Sorry, here we need to pass everything in a list function, right? So yes, now you can see the first one will be 10, 20, 30, and the next one is R programming, and the next one is 90.5, right? So this is called a nested list. So even though if you go with the class for this particular L, it will show it as a just a list. It doesn't give it as a nested list, but we can identify that we are giving one list as an element into another list. Okay. Now in this case, how can we access the elements? So for example, let us take L of 1. So what happens here? So you'll get all the 3 values. And if you want to get only one value, use a double subscript. For every index, right? So see, by using this one, we'll get only one element. That means first element, and again inside that first element, again we are getting only first element. If you go with the 2 here, we'll get a 20. If you go with the 3 here, we'll get a 30. Okay, and if you go with the 4, we'll get error, out of bound. So first element, we are not having 4 elements in the first sublist. So simply you can go with the L of 2, which will give R programming as a result. Okay, so this is how we can create a nested list and how we can access the elements from the nested list. Okay, use a double subscripts. Use a double subscript. Okay, then how can we give names for a list? For example, if you want to access this particular element, list of 10, 20, 30, we are just using this double subscript, and inside that we are giving the index. So can't we give the names for this one? Let us see. Let us have a look. Let us take three sublists. So in the first sublist, I am giving some names ABC and DEF, two names. Okay. In the second sublist, I am giving here as roll numbers. So imagine that these are the student details. Okay, ABC in one name of one student and DEF is a name of another student. And the second parameter is the roll numbers. So 101, 102. So let us take 101, 102. And the third parameter is a percentage. So 90.5 and 98.4. So we have taken the three elements and now just print the elements. So you can see. Okay. So in order to access this 90.5, so we need to use the index in this way. See, if you use the index in this way, you will get only one element, that is 90.5. For example, if you want to give names to this particular list, so use a function called names of L is equal to, then give the list function, use a vector also, give the names. First one, name of student, and the second one, roll number. Sorry, so these are all strings, so we need to enclose in a double quotations. And the third one, percentage. And just now print the L. See, instead of getting the indexes, you can see the names for each and everything. Okay, and you can access this particular element with the help of this name of student. So how? So you need to pass the same thing in the subscript. See, L of name of student. So it will give only the names of a students. So A, B, C, D, E, F. So instead of that, you can also give a roll number. So which will give only the roll number. Only the roll number. Okay. So in this way, we can name the elements of a list. Right. So hope you understood. So creation of a list by using the list function. Creation of a nested list. So giving a list as an element to another list and accessing the elements of a list. So usually you using index values inside the subscript, and also you can give index range. Also you can give a multiple indexes or comma separated multiple indexes as a vector in the index place, right? And again giving a names for a list. So instead of using the index values, we can use a names. We can assign some names to the values and we can access the elements with the help of name. So simply we can call it as a named index. Named index, not a numbered index. So numbered index, the index will always start with 1 and you can simply use the numbers to get the elements of a list. And this is a named index. So we are assigning some names to the list, and with the help of names, we are accessing the elements from the list. Right. So hope you understood this complete introduction and how to create a list and how to access the elements of a list and the nested list. So let's stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. So today we will discuss about various operations that can be performed on list in R programming. So operations on list concept. So the first operation is the manipulations. That means adding elements, deleting elements, and updating elements. This is a common operation that can be performed on any data structure. So we'll see how we can add. So this can be done with the help of index, and this can be done with the help of assigning a null value. Okay, assigning null, and this is also possible with the help of index. So now we'll see by demonstrating with an example. So I'll open the RStudio. So I'll erase all the previous data. Now let us take two lists or one list. L1 is equal to list function of 10, 20, 30, 40, 50, 60, and we can print first, and let us check. Yes, so this is 10, 20, 30, 40, 50, 60, right? Now addition of elements, simply we can access the elements with the help of index, right? So if you give the index inside the subscript, so it will display that particular element, right? So you can see here, and we know that the index starts with 1, and if you go with the 6, the element is 60, and if you try to access a 7th index value, so we'll get a null. Now let us take that L of 7 is equal to 70 and execute. Sorry, here we have taken L1, right? Okay, so L1 of 7 is equal to 70, and after that assignment you can simply execute to print L1, so you'll get total 7 elements. Okay, so this is how we can add a few more elements to the list. And the second one, see, deleting, how we can delete. So that will be done by just assigning a null value to that particular index. For example, if you want to delete the element 7, okay, so L of 7 is equal to, use a word null, keyword null, and simply try to print the L once again, and you will not L1, right? So you will not get the 7. Okay, what happens if you remove the 5th one? So that means 5th element means a 50. Okay, now execute. So you can see the 50 has been removed. Okay, so if you assign a null value to the particular index, that element will be deleted. And the next, if you want to update the elements, so you can use L1 of 5 or L1 of 2 is equal to 200, and once again print L1, and you will be finding the second element as a 200. So previously it was 20 and now it was 200. Okay, so these are the basic operations, that means manipulating the list, that means addition of elements, how we can add the elements, how we can delete the elements, and how we can update the elements. So update means nothing but a reassignment of a list. Now the next operation is conversion. So conversion of list to vector. See, in this example we can check class of L1, which will give it as a vector, list. Now how we can convert this list to vector? So simply give the vector name some v is equal to, use a function called unlist. unlist of L1 and simply print V, and you will be finding all the elements. So you can observe previously, if it is a list, you will get the elements to be displayed in this way, okay, with the help of indexes. Okay, and if it is a vector, we'll get the elements in this way. And once again, you can check the class of L1, sorry, V, which is nothing but a numeric. It's a vector. It is a vector, right? So by using unlist function, list name, right? So by using the unlist function, we can convert any list into a vector. And now the next operation is a merging. That means simply a concatenation, we can say, merging of two lists. So that will be done with the help of list function itself. Okay, we have to pass a multiple list into that list function so that the multiple list will be get merged. See, for example, we can take it as 3 elements and consider L2 is equal to list of 100, 200 and 300, and see, pass both the list into a list function, right? So L3 is equal to list of L1 comma L2. So this will be combining both the list elements and we'll get a single element, single list. See, so it was considering as a nested list. Because you can observe here the first row or first element, and this first element will be having 2 indexes, right? 10 and 20, sorry, 3 indexes, 10, 20, 30. And again the second element we are having 3 indexes, and the elements are 100, 200 and 300. So merging means by using the list function we can combine a multiple list. You can also take the third one. So L3 is equal to list of -1, -2, -3, and you can go with the 4. L4 is equal to list of L1, L2 and L3, and you can execute. So it will combine every element. Sorry, L4. We are printing L3 here, and we need to print L4. Okay, so L4. So we'll get every element. See, first element index 1, second element index 2, third element index 3. Again in the first element there are 3 more elements, so 3 indexes, 1, 2 and 3. And coming to the second element, again we are having 3 indexes, 1, 2, 3, and again in the third element we are having 3 indexes, 1, 2, 3. So like this we can merge a multiple list into a single list. Okay, so for that we have to use a list function. Okay, use a list function, and these are all the operations that can be performed on list in R programming. So hope you understood and enjoyed. So if you are having any doubts regarding this concept, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. So today we'll discuss about one more data structure in R programming, that is a matrix. So in today's session we'll see how to create a matrix and how can we access the elements of a matrix. So the topic is matrix, and the first one, creation. Matrix can be created by using matrix function, and this function will take 3 parameters. So the first one is a data, which is nothing but a vector of complete information or elements, and the second one is number of rows, we call it as a n row, and the third one is number of columns, we call it as a n column. And the elements of the data should be the multiples of rows and columns. For example, if the number of rows are 2 and number of columns are 2, the data should contains 4 elements. And if the number of rows is 3 and number of columns is 3, then the data should contain 9 elements. So this is how we have to create a matrix. So 3 parameters. So data, which is a vector with elements, and number of rows and number of columns. So let me explain you with an example. So I'm opening the RStudio. So first we'll remove all the previous results. Now let us take a variable m is equal to matrix function, and let us check the class of m. So because whether it is a matrix or not. Yes, it's a matrix. Now see, m is equal to, and this matrix will be having the 3 parameters here. First one is the data. Let us take the data here. Data is equal to vector. I'll take some 10, 20, 30, 40, 50 and 60. Okay. Now m is equal to matrix of data, comma, number of rows we need to give, n row is equal to 3 and n col is equal to 2. So now you can see the maximum number of elements that this matrix hold is 3 into 2, 6 elements. So we need to check whether there are 6 elements or not. Okay, so 6 elements or a multiple of 6. You can also have a multiple of 6. Okay, now see, let us print the matrix m and you will be understanding. See, 10, 20, 30. So column wise creation 10, 20, 30, 40, 50 and 60. For example, let us take a few 60 more. So 70, 80, 90, 100, 110 and 120. Now let us check. See, so data length differs from the size of the matrix. So even though it is a multiple of rows and into columns, it was not going to be accepted. So only it should contain the number of elements as rows into columns. Or simply you can go with 2 rows and 3 columns. That's also possible because number of rows into number of columns is 6 and the data should contain 6 elements. So in both cases, 2 rows and 3 columns, 6 elements, 3 rows and 2 columns, 6 elements. Now you can execute and see 10, 30, 50, 10, 20, 30, 40, 50, 60. That means 3 columns and 2 rows. 3 columns and 2 rows. So this is how we have to create a matrix. Now the second one is accessing. How to access the elements? Accessing elements of matrix. So here also we'll using index. Okay, using indexing. So index inside subscript. So this is a format we have to follow for accessing the elements. So here we need to give matrix name. Okay, so I'll write it down. So here we can access one element. So where we have to give a matrix name followed by the subscript, and inside the subscript we need to give row number, comma, column number. So the corresponding element with the given row and column will be displayed. So this is for getting one element, that means a single element. Okay, see, let us check. Now we are having let us take some 3 rows and 2 columns. 3 rows and 2 columns. See, 3 rows and 2 columns. Now let us check. I just want to get a 20. Okay, I need to get the value 20. So 20 is in a second row and a first column. So here we need to give inside the subscript row number second row, column number first column. So m of 2 comma 1, so this will give a 20. For example, if you want to get a 60, okay, then what is the row number? 3. And what is the column number? It's a 2. So you'll get the element as 60. So this is the syntax to get one element, right? Next, if you want to get a whole row, complete row, if you want to get a complete row, the syntax is matrix name followed by the row number, and you need not specify the column number. So just give the comma and close the subscript. So most important, give the row number, comma, and leave the column number. Don't write the column number. So automatically whatever the row number we are giving, the complete row will be accessed. For example, here you can see, so before this we will print m so that we'll be having some clarity. Yes, so this is a matrix m, and here I just want to give like this, m 3 comma, and we are not specifying any column number. That implies it will access all the elements of row 3. See, all the elements of row 3. Similarly, if you go with a 1, see, all the elements of row 1. So 1040 is row 1. So row 1 will be accessed. Similarly, the third one is if you want to access whole column. So quite opposite. So same matrix name and followed by subscript, and use a comma and column number. So that means we have to mention the column number and we should not mention any row number, and that should be differentiated with a comma. That's most important. See what happens if we are not giving this comma. Let us check. So we are getting only one element, the first element. For example, if you go with a 4, what happens? 40. So what is the fourth element? Okay, fourth element is 40. So it will be considering as a vector, normal vector. Okay, so in order to access the complete row or a particular element, we need to give some row, corresponding row and corresponding column. And coming to the whole row, we have to give the row number and comma. And if you want to get a column number, for example, comma 2, so I need to access the complete elements of a column 2. You can see 40, 50, 60 are the elements of column 2. And if you give 1, so we'll get, here we need to check. So if you give 1, we'll get the elements of first column, 10, 20, 30. Okay, and then if you want to get more than one row, then the syntax will be matrix underscore name. And see, here we need to give the row numbers which we want to access as a vector. So we know that a vector means we need to use a C function. Similarly, C, give the row 1, row 2, and etc. And comma, don't give the column number. So obviously the complete row numbers, so whatever the rows you are mentioning here, the elements of those rows will be get accessed. Let us check. Let us take some more values. So 70, 80, 90, 100, 110, 120. So total 12 elements are there. We need to give here 3 into 4. We can take it 3 into 4. So this is the matrix, 3 by 4 matrix, and among this 3 by 4 matrix we are just printing m. So the complete elements have been displayed here, and here we are giving only column 1. So what is the column 1? Here, this one. And if you want to go with the multiple rows, give the row numbers as a vector. For example, I'll give 2 comma 4 and comma. Okay, comma. And see, you can observe, just a second, subscript out of bound. Okay, fourth row is not available, right? So I'll give 3. second row and third row. So I'll get a second row and a third row. So you can see 20, 50, 80, 100 is a 110 is a second row. So this is again new matrix. Okay, new matrix. That's why we are getting two different rows, 1 and 2. So 20, 50, 80, 110 and 30, 60, 90, 120 both we got. For example, if you want to get a 1, 3, so it will display the elements of first row and third row. First row and third row. Right? Similarly, if you want to give a more than one column, quite opposite which we have discussed just now. So it's matrix name, this is a common thing, and leave blank for a row number and give the vector of column numbers as a second parameter. So column 1, comma, column 2, comma, so and so on. Right? So we need to leave a blank for rows. So all the columns will be accessed. For example, if you give here comma and leave it, so that implies first column and third column. So if this particular vector is in the first position, it displays the row, and if it is in the second parameter or a second position, it implies that it points to the columns. So first column, third column. So you can see first column, third column. So 10, 20, 30, 70, 80, 90. For example, if you go with the 1, 3, 4, so you'll get 1, 4, 10, 20, 30 and 100, 110 and 120. And again, if you go with the 3, see, first row, first column, fourth column and then third column. So it will also display in the same positional order. So we have given some 1, 4 and 3. So that means the first column, then fourth column, then third column. And if you go with the 2, so first 4 and 2. So this is how we can access the elements from a matrix. So accessing one element and accessing one element, accessing whole row and accessing whole column and accessing more than one row and accessing more than one column. So very simple syntax. So hope you enjoyed the session. So if you are having any doubts regarding this matrix creation or accessing the elements of a matrix, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. So today we'll see one more concept in R programming, that is operations that can be performed on matrix. So in our previous sessions we have seen the matrix creation and how can we access the elements of a matrix. So in terms of rows and columns. Now we'll see the operations on matrix, right? The first operation is a manipulations. So adding rows and columns. So for this we have to use a new matrix. The syntax I am writing here, new matrix is equal to, and in order to add rows we have to use a rbind function. So first I will write the function rbind. Rbind means adding rows, right? So rbind function will take two arguments. One is matrix name and the data. Matrix name and data, right? So data means in terms of vector. Okay, so this is for rows. And similarly, if you want to add columns, so the syntax, again we have to use a cbind function. Cbind means columns, adding the columns. So here also the same syntax. The first parameter will be matrix name and the second parameter will be the data which we want to add. So these are the two syntaxes to add rows and columns into a matrix. So we'll see an example by executing a small program. So let me open the RStudio and let me clear all the previous inputs and outputs, and then we'll take one matrix. So we know that creation of matrix M is equal to, we have to use a matrix function. So matrix of a data. So we can give a data 10, 20, 30, 40, 50 and 60. Okay, and after that, that next parameter is we have to go with the number of rows. So I'll give it as 3 rows, and n col is equal to 2 rows, 2 columns. So total 3 into 2, 6 elements, right? Now let us print the matrix before applying the operation. Let us check whether it is working or not. Yes, so the matrix have been printed with the 3 rows and 2 columns. Now we have to add one more row. For example, let us take a row. So we need to use a rbound function. So I'll take another matrix, n is equal to, so rbind function, and here we need to pass a matrix, existing matrix, and the vector. So the data means here vector. So how many elements we have to do? So in each row, how many columns are there? So in the first row we are having 2 columns, in the second row we are having 2 columns, and the third row we are having 2 columns. And here we are inserting row. That means we need to give 2 values, because every row we are having 2 columns. So I'll give it as some 100 and 200, and simply print the new matrix. So you'll be finding the row added. See, 10, 40, 20, 50, 30, 60 and 100, 200. So what happens if you give 3 columns? I mean 3 elements. See, you'll get a result as error. So number of columns of result is not a multiple of vector length. So here every row is having only 2 columns. So we need to give only 2 elements here. Okay, now if you want to add new column, okay, if you want to add a new column, then we have to use cbind function. Okay, cbind function. So c, let us take some p is equal to cbind function of, let us take it as n comma, we have to give the elements. How many elements we have to give? So for every column there are different rows, right? So in the first column we are having 4 rows, in the second column we are having 4 rows. So I mean after updating, so without confusion, let us remove this one previous thing, so don't get confused. Okay, yeah. So in this we are having, for every column we are having 3 rows. Okay, 3 elements, that means 3 rows. So here also we are adding 1 column, so we have to give 3 rows. So 300, 400, and simply print n. Okay, so here I'm changing m, and here I'm using n, and you can see the third column has been created. So previously only 2 columns, and now it was third column has been executed. So these 2 are the functions in order to add rows and columns. And the second operation, deletion. So both comes under manipulations, right? So deletion or deleting rows and columns. Rows and columns. So here syntax is small difference. So we need to give a matrix is equal to, and give the matrix and give the indexes with a minus c of row number. Similarly, we can also give minus c of column number. So the row and column will be get deleted. The given row and given column will be get deleted. For example, let us take. So we are having one matrix with the 3 by 2. So total 6 elements. Now I'll give m is equal to m of minus c of 1. Sorry, 1. Okay. So what happens now? Let us observe. Print m. So first row should be deleted. So first one will be row, and see the first row. Just a second. So 20, 30, 40, 50, 60. So only first element has been deleted. Okay, first element. So if you are giving only one, so obviously in the inside the subscript we are having. See, I have forgotten. Right. See, single element. Okay, single element. We have to go with a matrix of minus C of index. So index always starts with 1, right? And this is for multiple entire row. See, entire row means just give colon and just observe. See, the first row has been deleted. Okay, 1 minus C of 1 colon. So minus, let us take my matrix minus C of row number comma close. Okay, so for entire row the syntax is matrix and minus C row comma. If you use a comma, then automatically the complete row will be deleted. Similarly, entire column, same syntax, matrix of comma minus C of matrix minus C of column number. Okay, so here let us replace this comma front of the subscript. So the first column will be deleted. Okay, so only the elements are 40, 50, 60. So 10, 20, 30 has been deleted. Okay, hope you understood. Yes, so then multiple rows and columns, then we have to give minus C1 comma minus C1. That means from the result, I mean from the existing matrix, the first row and first column will be deleted. First row and first column. Let us take, so 50, 60. So first row, first column. So only 50, 60 will be printed. Okay, first row and first column. Right? So hope you understood how can we delete the rows and columns. And the third operation, searching an element. So for this we are using the operator called membership operator in. Membership operator, right? So here the syntax is element, and we should not use a simple in. We have to enclose that in inside the percentage symbol. So percentage in, percentage matrix name. So obviously it is a boolean. So if the element exists in matrix, automatically it will return true, otherwise it will return false. So let us check. So I am writing here instead of deleting. See, I am executing here. Yes. So I'm giving some 10 percentage in percentage m. So what we get? It's a true. And if you use 100 and execute, we'll get a false because 100 is not available in m. So if you delete these percentage symbols, you will get an error, unexpected in, right? So we have to use the membership operator in between the percentage symbols. So just remember, and that is the syntax for searching an element. And the next one is a dimension of matrix. So how to know the dimension of matrix? For this we are going to use a dimension function. So dimension dim function, and pass the parameter as a matrix name. So instead of this one, I'll go with a print dim of m. So here we'll get 3, 2. That means the so it will display rows followed by columns. So that means whatever the first number represents the number of rows and the second number represents number of columns. So 3 rows and 2 columns. 3 rows and 2 columns. So if you change here 2 rows and 3 columns, what happens? So we'll get 2, 3. dimension is 2 3 because 2 rows and 3 columns. So the first number always represents the rows. And the next one is a length of the matrix. Length of matrix. So how can we find the length of the matrix? That means the maximum number of elements that the matrix can hold. So for that we are having a function called length, and followed by we have to pass the matrix name. So it will display total number of elements in matrix. So here you can see instead of dimension I am using length, length of m. So obviously the maximum number of elements we can store in that given matrix is 6, because we are using 2 rows and 3 columns. 2 into 3 total 6 elements. So we can pass only 6 elements. We can store only 6 elements. And the next one is finding number of rows and number of columns. So simple for this one. So in the creation we are giving n row and n column. So the same function we are going to use n row of matrix name will give this function will return number of rows, and n call of matrix name, and this will also number of columns. Okay, so let us check. N row of m, and here I will go with the print of n call of m. So let us execute here. See, number of rows is 2, number of columns is 3, and if you change here 3 and 2, so we'll get number of rows as 3, number of columns as 2. So this is one more operation, how to find the number of rows and columns. And the next, with the help of this number of rows and number of columns, we can loop the matrix elements. So how can we loop all the elements of a matrix? So for that, simply we have to use a for loop. For, and the syntax, we know that the variable 1 in sequence, we can give a sequence, or n row of matrix, and from this we can use a nested. Okay, so normally if you are going with rows and columns, so the outer loop represents the row and inner loop represents the columns. So again, for where 2 in 1 is to or c n call and m, and we can give the index value here. See, simply we can give the index value. So matrix of row and column. So suddenly you might be worrying about what are the rows and columns. So this is nothing but rows and columns. So this is a row and this is a column. Okay, so row in and col in. So row and column. So simply we can get every element in a iteration. So see, well, let us take. So for R in, R stands for row, R in. So sequence 1 colon n row of m. That means the sequence will be having from 1 to number of rows 3, 1 to 3, right? Again, inside the for loop I am going to give column C in 1 to n call of m. So how many columns are there? Only 2 columns. So 1 and 2. C will be moving with 1 and 2 values. So here I am printing. So print m of matrix of, so R comma C. So this will always print the elements, each and every element. So you can see. So all the 6 elements have been printed by using the looping variable. So we can use the n row and n column in order to loop each and every element of a matrix. Okay, so the next operation, combining 2 different matrices. So combining two matrices. So this is for this also we have to use rbind and cbind functions. Okay, instead of giving the data, we can give the matrix. Okay, so let it be m1 is one matrix and m2 is the second matrix, and you can see the result is equal to rbind of m1 comma m2. So that means rows will be inserted. Then I mean the matrix m2 will be inserted in terms of rows. For example, let us take the here. So I'll remove all things. N is equal to, let us take one more matrix C of, so let us take 100, 200, 300, 400, 500, 600. Okay, and column n row is equal to 2 or 3, n col is equal to 2. Two matrices I am giving, right? So let us check whether they are correctly syntaxed or not. Yes, we got elements. Now what happens here? Result is equal to, so rbind of m comma n. Okay, so print result. So execute, and you can see all the second matrix elements have been connected with the first matrix, combined with the first matrix. And if the same thing happens with the cbind, so two more columns will be added. Instead of rows, columns will be added. Okay, so what happens here? The question is, what happens if both the matrices are of different sizes? For example, let us take here only 4 elements. So number of rows will be 2 and number of columns will be 2. And see, number of rows of matrix must match. That means both the matrix which we want to combine should have the same dimension. That means number of rows and number of columns should be equal. Then only we can combine both the matrix and we can form the resultant matrix. Right? So these are all the different operations that can be performed on matrices. Okay, so hope you understood this one and enjoyed the session. So I'll stop here, and if you are having any doubts regarding any one of these operations, so feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. So today we'll discuss about one more data structure in R programming, arrays. So in our previous sessions we have discussed about a few more data structures like vector, matrix, etc. So now we'll see what is an array, how to create an array in R programming, and how we can access the elements of an array. Right? Now the creation of array. So here arrays are categorized into a single dimension and multi-dimension. Right? So we'll see both the cases how we can create a single dimensional array and multi-dimensional array. So first one, single dimension array, and we can create this single dimension array by using array function. Right? So the syntax is array of give the data which we want to convert into array. Right? So let me create by in the RStudio. So I'll open the RStudio and I'll demonstrate the creation of single dimension array. So here we are not giving any dimensions, only one parameter, that is the data. Okay, now see, I'll take some data like in terms of vector. Some a is equal to vector c function 10, 20, 30, 40, 50, 60, 70, and pass this data as a parameter to array function. So I'll take it as array is equal to array function of a. So you can check the data type here. So in order to check the data type, we have to use a class function. So let me check. So you can see the class of ARR data type, I mean ARR variable is array, right? Now if you print this one, so you can get the complete elements of array. So this is a single dimension array, creation of single dimension array. Similarly, multi-dimension array. How to create the multi-dimension array? So here also we are going to use a array function, but with the three parameters. So what is the three parameters? The first one is data, which can be a vector, and the second one, two parameters. Okay, two parameters. And second one is a dimension. We need to mention the dimension with rows, columns, and dimensions. That means number of arrays. How many number of arrays we want to create. Okay. So here I'll write with one parameter. So the one parameter is nothing but data. Okay. Data. Now we'll see the syntax of creating multi-dimension. So syntax. So what we have done, array, the first parameter is data and the second parameter is dimension is equal to, and we have to pass all the three parameters, that means the rows, number of columns and the number of dimensions in terms of vector. So C function, so number of rows, number of columns, number of arrays. That we call it as a dimension. So this is a simple syntax in order to create a multi-dimension array. Now let us execute here. Let us take 660. So 6 elements. I am creating an array. So n is equal to, let it be n is equal to array function. Pass the parameter here. First one data, that is a. Second one is a dimension in terms of vector, number of rows. So 60, that means 6 elements we are giving. Either we have to take a 2 by 3 array or a 3 by 2 array or a 6 by 1 or 1 by 6, right? So that means the maximum number of elements that array can hold is a 6. So what are the combinations if you we have to consider if there are a maximum number of 6 elements? So it can be 2 rows and 3 columns, which will give 6 elements, and it may be 3 rows and 2 columns, again which will give the 6 elements, and 1 row with 6 columns or 6 rows with 1 column. So I'll take 2 by 3. So number of rows 2, number of columns 3, and only 1 array. Okay, and simply I'll print n, and you can see 2 rows and 3 columns. So the first one will be the rows, the second one will be the columns, and the third one will be the number of arrays. And see, you can observe print n, I am getting only 1 array because we have given 1. And if you give 2 here and observe, you will get 2 different arrays. Even though it is having the same name. Same number of elements, 2 arrays will be created. For example, consider here 70, 80, 90, 100, 110 and 120. So total 12 elements are there. So 12 elements, the combinations we can get 3 by 4, 4 by 3, 2 by 6, 6 by 2, 1 by 12, 12 by 1. And also we can have 2 by 2 in 3 arrays. So 2 by 2 means 4 elements will be there. So 3 arrays. So 3 4s are 12. So let us check here. So 2, 2 and 3. So this implies it will create 3 different arrays with a 2 by 2 elements. 2 rows and 2 columns. Right? See, you can observe here. Print. See, the first array, it consists of 10, 20, 30, 40. and second array 50, 60, 70, 80, and third array 90, 110, 100 and 120. So this happens here. And if you give only one array with a 2 by 2, it will consider only first 4 elements from the given data. You can observe. So 10, 20, 30, 40. So only 4 elements will be taken from the given data. So like this we can create an array with a single dimension or multi-dimension. Right? So the next one is accessing. How can we access the elements? Accessing elements of array. So if it is a single element, we have to give array followed by the subscript and give the index value. Single element. If you want to access the single element, for example, you can consider here, let us take some 3 arrays, right? Yes. So if you want to access the elements, print n of 1, so it will access only one element, I mean first. So here array means it consists of multiple elements, so the index value will be starting from 1, so it gives the index value. Okay, so if you give a 12, you'll get the index of 12th, I mean the element of in 12th index. Okay, and if you give 2, 3, 1, say subscript out of both. So because each and every array size is 2 by 2. So now you can see 2 by 2, 1. So you'll get a 40 because the first array is this one. So 2, second row, second column element, second row, second column element, it's a 40 from the first array. So you'll get a 40. If you go with here 2, the second row, second element of second array will be displayed. So this is the second array, you can observe here, right? So 80. And if you go with 3, the second row, second column of third index, third array. So like this we can access the elements from a multi-dimensional array or a single dimensional array. If it is single dimensional array, simply you can give a single index. If you give the single index, you will get a single dimensional array, the element from the single dimensional array. Now the question is, if you want to access single row, the complete row, then go with the array function and give the list of a number of rows, the row number in the C function as a vector, right? So I'll give 1 and give the entire row, so just leave alone the column from the first array. Okay, so here you need to give the row number and here array number. Okay, see, for example, you can consider here the C of 1 entire row, and from second array you can get it 50, 70. What is the second one? 50, 70. So first row 50, 70 will be displayed from the second array. And if you go with the 2, what happens here? It will display 60, 80. It will display 60, 80. Okay, and if it is 1, you can observe from the second row only one element, the first index. Okay, the first index, and here you need to give the index, element index. Okay, element index. And if you are not giving the element index, so this is a single row, complete row, so you need to give an empty. Okay, you need to give an empty. Why? If we want to access the complete column, quite opposite. So complete column and leave the row space as a blank and give the vector in column place. See, first one space, the row, entire row, and second column or first column, and the next one is an array number. For example, you can consider this one. So n of c of 1 2, sorry, yes, and you can see the first we have left blank, that means complete row. Okay, and this is a complete first column, and from the second matrix, and you can observe 50 60. What is a 50 60? So this is a first column, all the rows. Okay, and if you go with the 2, you will get second column, and you can also pass a multiple columns. Let it be 2 comma 1, you will get both the elements. So 2 comma 1. Okay, so first column and second column from the second. And if you give the change the array number from the third array, you will get the elements. Okay, so this is how we can access the elements from the array from a single dimension or multi-dimension. So we can access the single element, or we can access the complete rows, and we can access the complete columns. So if you pass a single number inside the vector, so it will consider it as a complete row, only a single row. And if you would mention 2 or more row numbers in the vector, so it will consider the multiple rows and it will display. And the third parameter will be the array number, from which array it have to access the elements. Right? So hope you understood this simple concept, the creation of single dimension array, multi-dimension array, and accessing the elements from the single dimension array, multi-dimensional array, accessing the single element, accessing the rows, accessing the columns. So let's stop here, and if you are having any doubts regarding this session, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. And now we'll see the operations that can be performed on arrays. So the first one, so array operations, the first one is an apply function. And this apply function is used to apply a particular function on the given array. Right? So this takes 3 parameters, and the first one is an array on which we have to apply the function, and the next one is a margin. So margin is either the operations or the calculation to be done on row or column, right? And the third one is a function. So this is a function which we need to apply on array of elements, right? So this is the apply function, and let us demonstrate, let us understand by executing a small program. So I'm opening the RStudio, and let me clear all the previous data. So if it is available, yes. Now create a vector, an array. So a is equal to array function. The first one is the data, which in terms of vectors, so 10, 20, 30, 40, 50, 60, and then the dimensions. So the dimensions should be written in terms of vectors, the number of rows, 3 rows and 2 columns, and only one array. And you can see, first let us print the complete array. Yes, array has been created. Now we can apply the function. So result is equal to apply. Okay, the first one is an array, and the margin, so it should be in terms of C of 1, and the function is sum. So this is used to I'll write here an example, right? So here a C of 1. So margin 1 gives a row operations or row calculations. Okay, calculations on row, and coming to the 2, if it is 2, calculation on column, right? And sum is the sum of elements of an array. For example, let us take this one. So we are giving 1, so row wise data will be calculated. Now if I print result, and you can see, so what happens, we need a sum of array elements, and what is a data set, so which is a row wise because it's a 1. So from array A, so in the array A, 10 plus 40 50, 20 plus 50 70, 30 plus 60 90. So 50 70 90 will be the result of arrays, 50 70 90. And if you go with 2, that implies a column wise sum will be done. So 10 plus 20 plus 30 is totally 60. 60 plus 50 plus 40 totally 150. So 60 150 will be the result if we give C of 2. 60 150. So the second one, margin, is a data set, so on which the function should be applied. So either it is a row wise or a column wise. 1 represents the row wise, 2 represents the column wise. So this is the first operation we can done on arrays. The second one is a arithmetic operators, arithmetic operations. So like addition, we can go with subtraction, multiplication, division, and modulo, right? So let us take a 2 arrays. Let us take a 4 elements, 2 by 2, and again I'll go with one more array. B is equal to array function of a data, so which is 1 2 3 4 comma dimension is equal to C of 2 comma 2 comma 1. And now you can observe, so print A and B and take this one back and just execute. So sorry, yes, you can observe, so 10 20 30 40 is a first array A, and B 1 2 3 4. Now you can see result is equal to, simply apply the arithmetic operations A plus B and print result, and you can see the result. See, 10 plus 1 20 plus 2 20, 30 plus 3 and 40 plus 4, so 11 22 33 44, the addition. And if you give it the minus, the subtraction will be done, so the difference will be displayed. So 10 minus 1 9, 20 minus 2 18, 30 minus 3 27, and 40 minus 4 36. And if you give it simply multiplication, and the multiplication will be done, 10 into 1 20 into 2 30 into 3 and 40 into 4. And division also similar, so it will apply the division operation, right? 10 by 1 20 by 2 30 by 3 40 by 4. And also you can apply the mod operation. So this is a mod operation, obviously it will be 0, 10 mod 1 0, 20 mod 2 0, 30 mod 3 0, 40 mod 4 0, right? So we can apply arithmetic operations on arrays. And the third one, searching an element. Searching an element. So we can also search for a particular element in the given array. So for example, let us take some print A, and we can check a result is equal to let us take 10 in A. So obviously it will return true if 10 is available in array A. If you go with a B, it is not there, so the result will be false. Okay, so the operator in should be written in this way. It should be enclosed in between two percentage symbols. Okay, the in operator. So in operator will be used for searching a particular element in the array. So if you go with 100 here, so 100 in B, it will return false because 100 is not available in B. And if you go with a 1, it will return true because 1 is available in B. So that's our third operator, third operation. And the next one is finding dimensions. So we can also find the dimensions. If you don't know the dimensions, so we can also go with the dimensions. So let us take here dimensions. So here we can give a dimension of A so that it will display the complete dimensions of A. So 2, 2, 1. That means the elements are of 2 rows and 2 columns with one array. Right? So dimension function. So this is with a dimension function. And the next searching will be enclosed in percentage. And the next one is an array length. That means how many elements the array consists of. Right? This is by using the length function. We can find out. So simply you can observe length of A and you can see GTH complete. Okay, so length of A is 4. So totally the array A consists of 4 elements, so it displays the length as 4. GTH, yes, right. And the next one is looping through array. So we can consider, and if you want to display all the elements, we can loop through the complete array by using some for loop. So for I in A, print I. So you can also loop with array. Okay, here I is a loop variable. So I is not a fixed variable. So I is a loop variable. Instead of I, you can also go with the ELE, that means element. It's an identifier. Simply we can say it is an identifier. Okay. So hope you understood. These are all the various operations that can be performed on arrays. One is the apply function, arithmetic operations we can apply, and searching an element in an array, finding the dimensions of an array, and finding the length of the array, and iterating the array using some loop variable. So these are all the different operations that can be performed on arrays. So hope you understood, and if you feel any difficulty on any one of the operations, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. Channel. So today we'll see what is a data frame and what is the syntax for creating a data frame and accessing the elements of a data frame in R programming. So that is one of the data structure, right? So in our previous session we have seen the matrix, array, vector, etc. Now we'll see the data frame. So data frame, the first we have to go with the creation, right? And this will be done by using data.frame function. And the syntax for creating this one, so usually the data frame will be represented in a tabular format. That means the complete data will be in rows and columns, and the columns will be having some names, and we can also give the names in the syntax itself, right? So go with the data.frame function, and inside the frame function we have to give the column name 1. That means the first column is equal to, give the complete data in terms of vector. So value 1 comma value 2 comma and so on, right? and move with the comma, give the second column. So column name 2 is equal to, again give the values in terms of vectors, right? So similarly you can go with the different columns and finally close the data.frame function. And also you can take three different vectors and you can pass all those vectors into the data.frame function, right? See, I'll write here, or simply you can go with the column name 1 is equal to vector of value 1, value 2, and so on. Similarly, column name 2 is equal to vector value 1 comma value 2 comma and so on, right? Then pass these two columns, okay, the complete data into the data dot frame function, right? So call 1 underscore name, sorry, column name 1 comma column name 2. So obviously that will be the data frame, right? Now we'll see with an example. So let me open the RStudio and first let us clear all the previous data. Yes. Now let us take say df as a data frame is equal to data dot frame, okay, and give the column name. Now let us take the student details. For example, the student details. So student details means having a student name, a roll number, and the percentage. Okay, first let us take the roll number. So the column name should be roll number. Roll number is equal to, give the complete roll numbers as a vector, right? Let us take the three student details, 101, 102, and 103. These are the roll numbers of a particular student. Then the next column will be, let it be student name, st name, okay, is equal to, again give all the names as a vector, right? So three names we have to give. So let it be abc comma def comma ghi, three names. These are all the three names, okay, right, comma, and the third column is a percentage. Let us take a percentage. Percentage is equal to vector 99.4, 98.5, 92.9. So this is a thing, right? Now simply print this data frame df so that you will be getting the complete data in terms of rows and columns. See, you'll be getting the data in terms of rows and columns. So roll number, student name, and the percentage, the three columns. So this is one way to create a data frame. And one more way, what we have said, consider all these three as a different vectors, all three as a different vectors, and pass all these vectors to the data frame function. Yes. Now you can pass everything to the data frame function, df data dot function. So roll number, student name, percentage, and simply print a df. So again it creates the same data but in terms of rows as well as columns. Okay, now we'll see how can we access the elements of a data frame, right? That means rows, right? Accessing data frame, right? So the first one, we have to go with a data frame name of index. Pass on the index. So let us take df of 1, what happens if you give df of 1? See, you'll get the complete first column roll number, and if you pass here 2, it will give the complete second column. So return columns with specified index, right? So here the index terms with the column number, and here also the index starts with 1. And if you want to get a more than one column, let us take 1 comma 2 and execute. So you will get multiple columns by taking the vector as an index, right? See, data frame and C of call 1 comma call 2 comma so and so. So it returns multiple columns with having given index, right? So if you want to get a multiple columns, simply we have to pass a vector of column numbers as a parameter or as an index to the inside the subscript. And the next one, so in order to access the values of a particular column, then so data frame, and this is a data frame name. Okay, so in all these cases we have to consider it as a data frame name. Okay, data frame name, and here also it is a data frame name of, and inside again give the subscript and give the quotations and give the column name, so that a particular column will be returned, right? So return column having given name. Okay, see, for example, let us consider student name. Give st underscore name. So we are giving st name as an index to the data frame, right? Now you can observe. So we'll get all the data frame and student names of a particular data frame. Okay, and then, and also this can also be done in the same way, data frame name. Okay, dollar column name. So this will also return column having given name. Okay, see, the same way we can also print df dollar st name. If you execute, both will get the same thing, right? This will be in the column way, this will be in the row ways. Okay, but the data will be displayed here. And you can, if you want to get only a particular column in that particular element in that column, right? See, so data frame underscore name dollar column name, inside the subscript give the index. So return element having index in specified column. For example, see, dollar st name, and I will go with the 2. You can see only def will be get printed because def is a second name. Okay, and if you give here 3, you get only third one, that is ghi. And if you give 4, which is not available, so it will give NA. Okay, it doesn't raise any error, it will give NA, not available. Okay, so this is how we can access a particular column elements, multiple columns the elements having with a multiple columns, and elements with a specified column name, and also the element having the index in a specified column. So these are the different ways how we can access the elements or columns from a data frame, right? So hope you understood this one. So in today's session we have seen how to create a data frame and how can we access the elements of a data frame. So hope you enjoyed and hope you understood. If you are having any difficulty, if you face any difficulty in creating or accessing the elements of data frame, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much. So today we'll see the operations that can be performed on data frame concept in R programming. So data frame, operations on data frame, right? So the first operation is a summary. Summarize. So the function is summary function of, here we need to give the data frame so that it will give the complete summary. That means mean, median, and some sort of statistical operations will be performed and that will be displayed, right? So let us take an example and I'll demonstrate this summarize function. So let me open this one, and first let us create the data frame with the three concepts. So st name is equal to vector of ABC. Let us take our name Sundeep, Saradhi, Raju, right? And also we'll take some roll number. Roll number is equal to again vector 101, 102, 103. And again the third one percentage. Let us take about the percentage. A vector some 99, 98.4, 97.6. we have taken, and now we will create a data frame df data dot frame function and pass all these vectors as a parameters. So st name, roll number, and percentage. Now let us print this df so that we can observe whether the data frame has been created. Yes, so you can observe the data frame has been created, and see student name, roll number, and a percentage. Yes, now the function is summarize function, summary function, which will give the complete details. So summary of df, and let us take, you can observe for every column there will be some sort of summary will be there. So length 3, class, character, and roll numbers. Coming to the roll numbers, minimum 101, and first quarter it will be 101.5, median, mean, third quarter maximum, similarly percentage also. Okay, so you can also use only one column, let it be like df dollar percentage. Okay, and that will give only the details of the summary of particular column percentage. So in the percentage, the minimum percentage is 97 and a maximum is 99, a median and a mean values, right? So this is the first operation, and the second one, adding rows. So in adding rows, we have seen in our previous sessions rbind function. Okay? So rbind function is used to add the rows. So it takes two parameters, the data frame and data in terms of vector, right? So let us add the data frame, right? So df is equal to df, rbind, and I need to add a df, and one row means we need to give a 3 columns, one student name, one roll number, and one percentage. So I'll take it as a C of, and we need to pass the data here. So I'll give a vector. The first one, let it be Ramu 104 and 95, right? And after that, just print the df and execute. You can see the fourth row was also been inserted. Fourth row was also been inserted, right? So this is R bind function. Okay, R bind is to add a row, and the third one, adding columns. So this is for C bind function. So we have to use a C bind function, and one column means one more property of a student should be added. So the first parameter will be the data frame, and next column name is equal to, give the vector, give the values, whatever the values we need to give, right? So now if I want to add a college, okay, see, df is equal to C bind, and I need to add into the data frame, and I want to insert a college is equal to vector. 4 categories are there. I'll give some ABC college, DEF college, GHI college, JKL, right? Now you can observe the data frame. See, the fourth column was also being added with the different college names, right? So it will give the positional order. So the first value in the vector will be assigned to the first student name. So it follows the positional order, right? So R bind and C bind is used for adding rows and columns, and then removing rows and columns. So for this we just use a negative C function, right? So data frame, inside the subscript, give a minus C of column number, okay, and similarly minus C of, so sorry, this is a column number and that will be the roll number, okay, row number. See, this will be the row number. The first is row and the second one is a column, right? So whatever the row number, whatever the column number we are giving, that will be removed from the data frame. For example, let us take, so df is equal to data frame of minus C of 1, and just observe, see, just a second, yeah. So before this one, we'll print before removing so that we can observe what has been deleted, right? See, yeah. So we have deleted the first column, okay? So extremely sorry, this will be the column. If there is only one parameter, okay, if there is only one parameter, that will be treated as a column. And see, if I give a minus C of 1, and you can see now the first row and first column will be deleted. First row and first column will be deleted, right? And see, here also the first column has been deleted. Okay, so if you are giving only one parameter, hope you understood this one. If you are giving only one parameter, that will be considered as a column. If you are giving two parameters, then it will be considered as a row and column. The first one will be the row, second one will be the column. Okay, so I'll write here adding column. Adding column means simply use only one thing. Next, removing rows. Then simply we have to go with the data frame of minus C of row number and obviously give comma. Let us check. So let us remove this one and execute. So 4 rows are there and 4 columns are there, and if I give comma, and now we can observe the first row has been deleted, the first row. So you have to use a comma if you want to remove the first row. Okay, and removing both rows and columns, so simply use data frame of minus c of row number comma minus c of column number. So you can also give a multiple columns and multiple rows, no worry, because this is a vector, right? So here we can pass 2 columns and 2 rows. Okay, so if I give this one, it will remove the first row and first column. Okay, and I'll give 1 comma 3 and 1 comma 3, so that you can see 1 and 3 has been deleted. So what is a 1 and 3? So first and third, you can see percentage and student name, and the 1 and 3, Sundeep and Raju, the data of Sundeep and Raju will be deleted. So roll numbers 101 and 103 has been deleted. Okay, so like this we have to give a multiple columns. Okay, multiple column numbers, right? Next, this is about the removing rows and columns. Next, dimension. So what in order to find the dimensions, you have to use dim function, and we have to pass data frame into the dim function. It will display the complete dimensions. So I'll remove all these things. Okay, and see, yes, print dimension of data frame, and you can see the dimension of data frame is now 4 by 4. That means 4 rows and 4 columns, 4 rows and 4 columns. And the next operation we can do is number of rows. Okay, number of rows. So for this we are having a function called n row of data frame, which will give the number of rows. Okay, so you can see n row, which will give the number of rows, so 4 rows. And similarly, the next operation, number of columns, so which gives n col of data frame. And see, if in place of row we can give n column, so that it will display the number of columns, 4 columns. And the next one is length of data frame, length of the data frame. So you can go with the length function of data frame. So here you can check length of data frame. So length of data frame is 4. That means it consists of 4 records. Okay, so it doesn't gives the multiples of rows and columns. Okay, so it will give only the number of rows. So we have to create the data frame for such a concept like maintaining the student records, maintaining the inventory, stock management, like that. So one product will be having the complete details in one row. One student details will be considered in a one row. So how many rows or how much data is available is nothing but our length. So we are having only 4 students data. So the length of this data frame will be obviously 4. Right? So hope you understood these operations on a data frame. So let's stop here. If you feel any difficulty while using these operations, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.